Hi all. In this session, we'll discuss the previous year questions of ISI entrance from the chapter of continuity and differentiability. The chapter is not that big. Okay, just to mention before we begin, for this session, I have chosen those questions which are based on the core definitions of continuity and differentiability. Apart from the core definitions, you also learn three crucial theorems. In fact, four crucial theorems in this particular chapter, which are kind of direct or indirect applications of continuity and differentiability you can consider. So what are those theorems? Those are basically intermediate value theorem, IVT. Then you have the Bolzano's theorem, which is a direct consequence of this intermediate value theorem. So this is considered to be a single topic only, intermediate value theorem and Bolzano's theorem, because Bolzano is just the application of intermediate value theorem, which deals with the roots of the function. And then there comes the extreme value theorem, extreme value theorem, extreme value theorem. And lastly, we have the fixed point theorem. We have the fixed point theorem. These are some of the crucial theorems which you learn under this chapter. Now here in this particular session, I haven't considered the questions which are based on these four theorems. We'll discuss this in a separate session once we do the session for applications of derivatives. Okay, before we begin, let us just quickly go through some of the basic fundamental points based on which we'll do the questions. So for this session, what you need to know, you just need to know the basic definitions of continuity and differentiability, which you people already know. This is the basic definition of continuity. So what is a continuous function? A function is said to be continuous at some specific point A, where A is the domain of this function, right? If this following condition is being satisfied, limit extending to A minus, which means the left hand limit and the right hand limit must be equal, and they must be also equal to the function value. This is the very fundamental definition of continuity. And the basic definition of differentiability, similarly, a function is said to be differentiable at some specific point if this limit exists finitely. Either you go by this definition or you'll have to use this definition. So what is this? Basically your LHD, and this is your RH, the basic definitions. These are all basic definitions known to all of you, and these are something which are taught at the board level as well. The very basic definition of left hand derivative and the right hand derivative at the specific point C. So left hand derivative is given by limit h tends to 0 f of c minus h minus fc divided by minus h, and right hand derivative is given by f of c plus h minus fc divided by h. Apart from these four definitions, you should know some of these points as well. Like a function is said to be, whenever we are saying a function is differentiable, that automatically means the function is continuous as well. But the converse of this theorem is not true, right? So when a function is continuous, so we cannot say the function is differentiable. Now this chart is very important from the question solving point of view, where the algebra of continuity and differentiability is given here. Means what happens when two functions are continuous or non-continuous, or differentiable or not differentiable. This is a very important chart. Let's say for the first one, like this is one chart and this is another one. So first one says that if two functions are continuous, then their sum and difference are always continuous and their product is also continuous. Similarly, if fx is continuous, gx is discontinuous, then their sum and difference is always discontinuous, but their product can be continuous. And you can verify this thing with the help of some examples as well. And similarly, for when both of these functions are discontinuous, then their sum may be continuous. Similarly, the product can be also continuous. So similar kind of arguments will hold for differentiability as well. If fx is differentiable, gx is differentiable, so as their sum and their product, both of them are differentiable. And if this is differentiable and this is non-differentiable, then their sum is also non-differentiable, but their product may be differentiable. Okay, and similarly, we are having non-differentiable plus non-differentiable may be differentiable, and their product also may be differentiable. So similar to the continuity one. You can all verify this thing with the help of some examples like I have said. Now some fundamental things regarding graphs should be also known to you, that at sharp corners, the function is not differentiable. It may be continuous at the sharp corners, but the function is not differentiable at sharp turns. So these are some fundamental things which should be known to you. Now the rest of the things we'll see with the help of the questions. Let us start with the questions directly. Okay, so we start with the 2025's PYQ first. Here we have the first question, which says that fx is given to be this function This is a signum function. Hopefully you people know this is called the signum function, signum x. Then the function f, capital F, we have one more function defined by fx is integration minus 5 to x ft dt. So we have to comment on whether this function, this capital fx is continuous or differentiable or not. We have to comment on this thing. So what we do first is we need to define this function fx. Okay, with the help of this small fx, we'll define this capital fx function. Now here, x is stuck inside this integral. So this x can be anything. This x can be less than 0, equal to 0 or greater than 0. So what we can do, we can make the cases and then we can solve. Likewise, we have the first case when x is less than 0. What happens when x is less than 0? Okay, because our concern function is this, fx is integration minus 5 to x ft dt. This is our concern function. So when x is less than 0, if we see on the number line, this is where we are having 0 and then we have minus 5. So minus 5 is somewhere over here. So when x is less than 0, x can be somewhere over here because our lower limit is what? Restricted to minus 5. This is our limit. This is our limit. So when x is less than 0, so x is somewhere over here. So when x is less than 0, ft will be what? Clearly minus 1 because fx is this thing or whatever it is. Basically x, you want to consider t because they are using t over here. So because x is stuck over here in this integral, so they are not using the same variable. So if x is less than 0, so ft is what? Minus 1. So ft will be directly minus 1. So here integral will be minus 5 to x, not minus 5 to 0. We are having minus 5 to x is the limit, right? So minus 5 to x and ft in this case will be minus 1. So minus 1 dt. This is the function when x is less than 0. So once we solve this thing, what is this? Basically minus of t and range is going from minus 5 to x. So this is basically x plus 5. So that's minus of x plus 5. Now, when x is greater than 0, in that case, if you see on the number line once again, this is 0 and this is minus 5. So when x is greater than 0, x is somewhere over here, right? And you're integrating from minus 5 to x. So in between, we are having 0 as well. So what we need to do, we need to define this properly as fx will be defined as integration minus 5 to 0 and then from 0 to x. Okay, because the upper limit is x and lower limit is minus 5. So we are defining from minus 5 to 0 and then 0 to x. So minus 5 to 0 means ft is still negative, right? Minus 5 to 0 means ft is still negative. So when ft is negative, in that case, I mean the values of x, here the values of x is still negative. So when x is negative, so this branch will be considered minus 1. So this will be minus 1 of dt. And when x is positive, from 0 to x is positive. So when x is positive, this branch will be considered, ft will be 1. So this is 1 dt. And then you simply solve it. So this is just t, minus of t, range goes from minus 5 to 0. And this is t, range is going from 0 to x. So once we solve this thing, this becomes 0 plus 5, which is minus of 5. And this is basically x. So x minus 5. More specifically, this is x minus 5. Okay, now you can also check for the case when x is equal to 0, or you can combine with this case as well. Let us check this separately. When x is equal to 0, then what happens? In that case, this integral will become minus 5 to 0 itself, right? When x is 0, which means you're plugging the value of 0 over here only. So when x is 0, so this is minus 5 to 0 f of t dt. And ft in this case will be what? Minus 5 to 0 means you are there in the negative region only. So in this case, this will be minus 1 only. Ft will be minus 1. So minus of 1 dt, right? So once you solve this thing, what will you get from here? The same thing, minus of 5. Minus of 5. So you could have just combined this with second case as well. Okay, in second case also, you could have just simply combined this with x is greater than or equal to 0. In that case also, you would have got the same thing, like minus 5 only, right? Second case bolo ki first case bolo. In one of these cases, you could have just simplified. I mean, simply included this value itself, right? क्योंकि हर एक में देखो minus 5 ही आएगा. हर एक में minus 5 ही आएगा, right? So if we define the function fx properly, so fx is, capital Fx is, when x is more than 0, fx is x minus 5, and when x is less than 0, x is less than 0, this is minus of x plus 5. And when x is equal to 0, this will be minus of 5. This is our definition of the function. So now you can clearly check at 0 plus, this is basically you will take this branch, right? So in that case, the limit value will be what? -5. And for 0 minus, you will take this branch. So in that case also the limiting value will be what? -5. So this function is continuous. So not continuous option is discarded, right? Now checking for the differentiability criteria, if you differentiate this branch wise, then f dash of x will be 1 when x is more than 0 and minus of 1 when x is less than 0, and this will be 0 when x is equal to 0. So clearly you can see for the left hand derivative we are having -1, and for the right hand derivative this is +1. You can directly differentiate this branch wise. This is a kind of a short trick. You can do this for piecewise functions. Okay, not for all functions. Whenever you're getting piecewise function of this type, you can differentiate this branch wise and check the differentiability criteria. So here for x is more than 0, which is indicating the right hand derivative, that is +1. And when x is less than 0, the limiting value is basically -1, which is nothing but the left hand derivative. So left hand derivative is not equal to the right hand derivative, right? So definitely in this case, the function is not differentiable at 0. Okay. So option D must be correct. The function is differentiable everywhere except 0. Okay, next we move on to ISI 2024 PYQs. Now, before we start, just to mention, there were two more questions from differentiability, kind of, that is, both of them were based on applications of derivatives only. One was directly based on fixed point theorem, and the other one was from the chapter of applications of derivatives. So that we'll discuss in the next session. Let us move on to 2024's PYQs. Okay, so here we have the first question, which says that consider the two following statements. Consider the following two statements. The first statement says there exists a differentiable function g such that R2R such that g of x cubed plus x to the power of 5 is e raised to the power of x minus 100. And second statement says there exists a continuous function g such that R2R such that g of e raised to the power of x is x cubed plus x to the power of 5. So we need to identify which one is correct. So let's deal with the first statement. If we differentiate this functional relation, what they have given, what we get from here, g dash of x cubed plus x to the power of 5, because we need to check for the differentiability only, whether there exists a differentiable function or continuous function. So we'll stick to differentiation. So once you differentiate this thing, so this becomes g dash of x cubed plus x to the power of 5 into differentiation of x cubed plus x to the power of 5, chain rule. So 3x square plus 5x to the power of 4, and right hand side will be having e raised to the power of x. Okay, so if we rewrite this thing, this is gx cube, g dash of x cube plus x to the power of 5, which is e raised to the power of x upon 3x square plus 5x to the power of 4. So here you can clearly see that this function is not defined when x is equal to 0. So the moment you put x is equal to 0, this part will become undefined. Okay, so the function cannot exist over here. So which means that g dash of 0 is not defined. So if g dash of 0 is not defined, which means there cannot exist a differentiable function such that whose domain is all real numbers and with this given condition. Now, for the second statement says we have to find a continuous function. We have to verify whether a continuous function exists or not. So g of e raised to the power of x is x cubed plus x to the power of 5. So here one benefit is this function can be simplified further in terms of t or x, let's say. So what I'm trying to say is if you take e raised to the power of x as t, so we can explicitly find something in terms of g of t only. So if e raised to the power of x is t, then x is what? Log of t, ln t. So g of t will be what? G of t will be ln t whole cube plus ln t whole raised to the power of 5. This is what we are having. Now, if you carefully see, they have given the domain of the function to be all real numbers. Now here, first of all, when t tends to 0 minus, first of all, t tends to 0 minus is not defined over here. So we can't even think of taking t tends to 0 minus. So all real number thing fails over here because t tends to 0 minus, we cannot take, we have some restrictions because of this t. Log t, we cannot take t tends to 0 minus. Otherwise, log is not defined. Now for t is equal to 0, this fails again when t is equal to 0, ln t is undefined. And when t tends to 0 plus, this will tend to plus infinity. This will tend to plus infinity. So as this will also tend to plus infinity. Plus infinity whole cube is plus infinity only. Entire quantity tends to plus infinity. So when t tends to 0 plus, the function is tending to plus infinity. So in this case, the limit does not exist. So at 0, the function is not continuous. So for the given domain, which is all real numbers given over here, this function cannot exist. I mean, so this function, there cannot exist a continuous function whose domain is all real numbers and this given functional equation satisfies. Okay, so both of them are incorrect statements. Okay, next we have this UGB question, which says that let f r to r be a function which is differentiable at 0. We define another function g, which is also going from r to r, such that gx is fx into sine 1 by x when x is not equal to 0 and 0 when x is equal to 0. So gx is another function. Now g is also differentiable at 0. Okay, so we have to prove that g dash of 0 is the same as f dash of 0, which is the same as f of 0, which is the same as g of 0, and all these values are all equal to 0. Okay, so one funny thing regarding this question was that we have to prove this part g of 0 is equal to 0 and g of 0 equal to 0 is already given over here. So it's given in the question, so you don't need to prove anything, right? So g of 0 is 0 from here itself. G of 0 is 0. Okay, so what you need to prove is the other three parts, g dash 0, f dash 0 and f of 0. All these are the same, so you just need to prove this one. Okay, so we start off with the very basic definition, because this is a very routine function which you all face in class. These kind of functions are quite common. So we start with a very basic definition. So what we'll do, so we'll start simplifying this g dash of 0 and this f dash of 0, because we have to use the definition and show from there itself. So we start off with g dash of 0. What is g dash of 0? G dash of 0 will be what? Limit h tends to 0. G of h minus of g of 0 divided by h. H minus 0, which is h only. We are using the very basic definition of differentiability. Okay. And similarly, we'll use the definition of f dash of 0 as well. What is f dash of 0? F dash of 0 will be limit h tends to 0. F of h minus f of 0 divided by h. Okay. Now, g of x is known to us, so we can start simplifying this. G of h, so limit h tends to 0. G of h will be what? F of h into sine 1 upon h minus g of 0. Now, g of 0 is 0 only, okay, which is divided by h. So this is what we are having, and this exists finitely. This will exist finitely. Why? Because they have said this thing that g is also differentiable at 0. So definitely this limit will exist. G dash of 0 will definitely exist, and this will be finite. So as f dash of 0, this will also exist. This will also exist, and this will be finite as well, because they have also mentioned that f is also a differentiable function. It is differentiable at 0. Okay. G is differentiable at 0. F is also differentiable at 0. So what else we can do? What do we need to do? So we have to find the value of g dash of 0, and so as f dash of 0. Okay, so let us take the help of this differentiability of g. Now g is also differentiable at 0, right? So if g is differentiable at 0, which means gx is also continuous at 0. Right? So you need to write this thing, since g is differentiable at x is equal to 0, which implies g is also continuous at x is equal to 0. So what happens is, limit x tending to 0, g of x will be equal to g of 0. This is by the definition of continuity, and this is equal to 0 only because g of 0 is known to us. This is 0. So this is by the definition of continuity. Limit x tending to 0, g of x will be g of 0, which is 0 only. Okay, so what we can say from here? That limit x tending to 0, g of x. Now g of x is known to us, which is fx into sine 1 by x. So limit x tending to 0, fx into sine 1 by x. This will be equal to 0 itself. Okay. This will be equal to 0. This much we have derived. We are simply using the informations whatever they have given. We need to simplify this. We need to find the value of this. We need to find the value of this. We need to find the value of this. So we are simplifying whatever they have given. Using that, we are simplifying. Okay. Now what we can say from here? Sine of 1 by x, this is an oscillating function. It's an oscillating value. This will give you an oscillating value in between -1 to 1. This is any oscillating value in between -1 to 1 as x tends to 0. So fx into any oscillating value in between -1 to 1, and their limiting value is given to be 0. The output is given to be 0, which means definitely limit extending to fx will be also 0. This has to be 0. There is no other option. Otherwise, their limiting value, their product won't be 0. Okay, so this implies from here limit x tending to infinity, extending to 0, fx will be equal to 0. Okay, ये ब्रैकेट में लिख लेना कि because sin x is in sine of 1 by x, limit extending to 0, sine of 1 by x is an oscillating value. Sine of 1 by x is an oscillating value from -1 to 1. ठीक है, ये ब्रैकेट में लिख के रखना अच्छे से, ठीक ठाक से. You have to write down each and every point in detail. Okay, so now we have derived this thing, limit extending to 0, fx is equal to 0. So next what we can say from here, since f is differentiable at 0, differentiable at x is equal to 0, f is also continuous. F is also continuous at x is equal to 0. So which means if f is continuous, so we can again use the definition. So which means limit extending to 0, f of x will be equal to 0, which is the same as f of 0. Because limit extending to f0, fx is 0 is known to us from here itself. And this must be also equal to the function value by the definition. So limit extending to 0, fx will be also equal to 0, which is the same as the function value f of 0. So f of 0 is 0, we are proving from here itself. F of 0 will be 0, we are proving from here itself. Okay. So this part of the proof we are done. G of 0 is 0 done. F of 0 is 0. We are also done. Next, we'll try to prove that G dash of 0 and F dash of 0 are also equal to 0. So let us focus on this f dash of 0. Let's consider this to be equation number 1, let's say. This is basically your f dash of 0 is limit h tends to 0, fh minus f0 divided by h. So now since we know what is f of 0 is 0, so we can find what is f dash of 0. So f dash of 0 will be what? Limit h tends to 0, fh minus f of 0. Now that is basically 0 only. So minus of 0 divided by h. So this is what we are having, limit h tends to 0, fh divided by h. Now since f is differentiable at 0, so the limit will exist over here. We know this thing. Because f is differentiable at 0, the limit will definitely will exist and will be finite. Okay. So we now need to focus on g dash of 0. So let us focus on g dash of 0. अब देख लो भाई, suppose if I consider, देखो we have to simplify g dash of 0, right? Okay, तो g dash of 0 को, g dash of 0 is basically, if you think of g dash of 0, then g dash of 0 will be, g dash of 0 is basically from here, g dash of 0 is limit h tends to 0, f of h into sine 1 by h upon h. Okay, sine 1 by h upon h. Now this is equal to 0. This, we have to prove this thing that this is equal to 0. Okay, so what I do, देखो, I consider this limit to be lambda or something, where lambda is not equal to 0. Suppose lambda is any finite number which is not equal to 0. ठीक है? Because this limit, we can clearly see this limit is present over here. Once you separate this, this limit is present over here. This is an oscillating function, and this, if this becomes 0, खुद ही सोचो, if this becomes 0, then only this limit will be finite and this will be equal to 0. That's what we need to prove, right? ठीक है ना? अगर ये 0 नहीं होता है तो if this is not 0, then a non-zero quantity multiplied by oscillating number, non-zero quantity है ना, non-zero quantity multiplied by oscillating number, this won't be 0 in that case. Then the limit won't be defined, right? So what you need to do is, so you need to show that this is equal to 0. If this is equal to 0, then only the product will be equal to 0. So for which what I'm doing is I'm considering this to be a lambda, this limit to be a lambda, because this limit is present over here, no? So we have to deal with this limit. So I'm taking this limit to be as lambda. Chalega, where lambda is any finite quantity and this is non-zero. I'm considering this to be non-zero. So next what I'm going to do is, if you separate these terms, limit h tends to 0, f of h upon h into limit h tends to 0, sine of 1 by h. This is an oscillating number, and limit of h tends to 0, f of h divided by h is lambda. This is lambda. So lambda multiplied by any oscillating number from -1 to 1, the limit will not exist in this case, right? So in that case, so if lambda is not equal to 0, in that case, g dash of 0 won't be defined, which means lambda has to be 0, which means therefore lambda has to be 0. So if lambda is 0, then only this limit will be a finite quantity, which is equal to 0. Then only this will be 0. So lambda has to be 0. Okay. So we are proving by the contradiction method. ये properly लिख लेना कि contradiction से. Suppose let us consider lambda to be as non-zero quantity, and lambda here becomes 0, which means this thing fails, right? This property fails. So lambda cannot be 0. Lambda must be equal to 0. It's a contradiction method. You know? Because if lambda is 0, then g dash of 0 will not exist. Okay? So which means what we have proved? Lambda 0 हो गया. So if lambda is 0, which means f dash of 0 is 0. है ना? क्या prove हो गया? If lambda is 0, which means f dash of 0 is 0. Right? And if lambda is 0, g dash of 0 will be also 0. So g dash of 0 भी prove है. देखो. G dash of 0 will be 0 as well. So f dash of 0 will be 0, g dash of 0 will be 0, f of 0 and g of 0, all of them are 0. So f of 0 is 0, we have proved. और आगे g of 0 तो 0 is given. So all the things we have proved. है ना? तो ये properly एकदम आपको लिखना है. Step by step, you have to write down all the things. Whatever they have given, we are simply using this thing. This is a very simple problem given. Okay, next we move on to 2023 PYQs. Here we have the first question, which says that if f is a function which is defined from 0 to infinity to r, it's a continuous function such that this relation is given, then for all x greater than or equal to 0, we have to find the function. So basically we need to solve from this function from this differential equation given. Okay. So the very first thing what we need to do is we need to remove this integral from here. So for which what we'll do is we'll differentiate this thing. We'll differentiate both the sides and we'll solve. Okay. So once you differentiate this thing, this becomes f dash of x plus ln2. ln2 is just a constant. Now the differentiation of this thing will be done by the Newton-Leibniz rule. Now I have taught Newton-Leibniz in the previous session where I have discussed integral calculus. So you can watch that. So ln2 times of differentiation of integration 0 to x ft dt, which is straight away fx only. Fx into integration fx into differentiation of x, which is 1. So we'll not write that. And the right hand side is basically 0. Okay, this is what we are having. So if I simplify this thing, this is just a common format of differentiation which you people do. Minus of ln2 times of f of x, and we are getting f dash of x divided by fx, which is minus of ln2. I have said this thing that whenever you are seeing this thing that explicitly these things are visible, f dash of x, fx. So always bring into this format because this is a common differentiation format which is known to all of you, or common integrable format which is known to you, right? Which you people do in separation of variables. And then what you do? You simply integrate both the sides. Then you will simply integrate both the sides. And in this case, this left hand side will become ln fx and right hand side will become minus of ln2 is just a constant, integration dx, which is x only. So minus of ln2 times of x. This is what we are having. And then plus c. Okay. Now the question is, there is no information given over here to eliminate c because we need to find the particular solution over here. Fx is given in terms of particular value. So we need to find the particular solution for which we need the particular values of c. Okay, for which f of 0 or something needs to be given over here. So for which what we can do, we can take the help of this mother equation itself. From here itself, we can find the value of this constant. We can take the help of this mother equation to find the value of this constant. So what we do is we plug in the value of 0 because 0 is one of the simplest possible value which we can see from here. Okay, because if you put the value of x to be 0, this part will go off. Okay, and directly you will find out the value of f of 0 from there itself. So you put the value of x to be 0, so you will get f of 0 over here. F of 0 plus this part will completely become 0, and this is equal to 1. So you find some particular values from here by which we can eliminate this constant c over here. So f of 0 is 1 means for x is equal to 0, y is 1. So you plug in the value of x to be 0 and y to be 1 over here. Y माने fx. ठीक है, so this becomes ln1, and right hand side is basically ln2 times of 0 plus c. तो ये तो 0 ही हो गया. This part is 0 and log 1 is also 0, तो c is 0. ठीक है. So if c is 0, so we find the particular solution from here, that is ln fx. Ln fx will be minus of ln2 times of x. Okay, so this we can further simplify, that fx is basically e raised to the power of minus of x into ln2. This much we can do. Further, we can simplify this thing to as e raised to the power of minus of ln2 raised to the power of x. And ln2 raised to the power of x, we can take this minus sign inside as well. So in this case, this will become, by the properties of log, so this will become e raised to the power of ln 1 upon 2 raised to the power of x. So this minus sign goes up, right? तो वो minus x हो जाएगा खाली, बस इतना ही है. This will become minus x. 2 raised to the power of minus x माने 1 by 2 raised to the power of x only. ठीक है, and e raised to the power of ln 1 upon 2 raised to the power of x will be 1 upon 2 raised to the power of x. Okay, so your function, fx function will be 1 upon 2 raised to the power of x or 1 by 2 whole raised to the power of x. माने option D is correct. You get these kind of questions in JE as well, right? A very common format of the question, that integral is stuck over here, some integral equation is given and you have to find the function from there. Okay, we move to the next question, which says that fx is given to be a cubic function where a, b, c, d are all real numbers. Then this equation fx is equal to 0 has exactly two distinct real solutions. Okay, so fx is equal to 0 has two distinct real solutions, and also fx is a cubic equation. So let's see what we can decode from there. Okay, so what we need to find out is, we need to find out which of these are a possible graph of f dash of x. This is the main question. Which of these is a possible graph of f dash of x? Okay, so what are the things they have given? You need to write this down. Okay, whatever you are seeing over here, एक एक करके ना लिख लो. Whatever you are seeing first, like fx is a cubic polynomial given. Then this equation has exactly two distinct real roots, is one more information given. So whatever informations you are seeing, you keep on writing them. Okay, likewise fx is, mark करते हो जाओ. लिखना नहीं है तो मार्क कर लो. Simply mark it that this is number 1, fx is ax cube plus bx square plus cx plus d. They have given a cubic polynomial, they are given, and a is not equal to 0. Fx is equal to 0 has two distinct real solutions. Acha. So we need to identify the graph of f dash of x. तो इतना तो clear है कि f dash of x will be a quadratic. F dash of x will be a quadratic and the graph will be a parabola type. And all these graphs they have given, all these 4 graphs they have given are all parabola types only. Okay. Now let us see what we can decode from this line, that fx is equal to 0 has exactly two distinct real solutions. Now two distinct real solution means the third one will be real solution only, because complex solutions always come in pair. Okay, so one complex solution cannot be possible. So two distinct real solution means the third solution will be also real solution itself. Acha, two distinct real solution hai, so out of which two can be repetitive as well. So what I mean to say, the graph can be in this way. Two distinct real solution they have saved. Sun lo. The graph can be, suppose the graph can be in this way. They're having two distinct real solutions. Dekh lo. They're having two distinct real solutions. Here, the two roots are repetitive and here we are having distinct. मतलब यहाँ पे suppose alpha beta है, alpha is equal to beta and here we are having gamma. So two distinct real roots are there. Okay. Out of which two roots are what? Repeating. है ना? Fine. Also, one more case can be, इसी का similar case can be, likewise, what if the graph is in this way? The graph touches from below. यहाँ पे touch करके the graph goes in this way. The graph goes in this way. Here also we are having the same condition. Same condition. यहाँ पे two roots are repeating and third root is completely distinct. So two of the roots are completely distinct over here. So what is the benefit? We can see from here that f dash of x will be 0 at two places. F dash of x will be 0 at two places from here. What is this? Mind it, this is the graph of y is equal to fx. क्यूबिक पॉलिनोमियल वाला ग्राफ है ना. यहाँ पे ये भी देख सकते हो कि as x tends to minus infinity, as x tends to minus infinity, this will also, y will also tend to minus infinity, and x as x tends to plus infinity, ये इसे हम क्या बोलेंगे? We call this as the leading coefficient test. As x tends to plus infinity, this also, the leading coefficient also tends to plus infinity. ठीक है, कुछ भी हो जाए, because we don't know the sign of a, so a can also impact this sign, है ना. तो both of these cases we have considered. As x tends to plus infinity, y also tends to plus infinity, and as x tends to minus infinity, this also tends to minus infinity. So both of these cases we have considered, है ना. तो हर एक में देखो minimum two places we are getting where f dash of x will be equal to 0. यहाँ पर भी f dash of x will be equal to 0, है ना. माने f dash of x has two roots minimum. मिनिमम टू रूट्स तो मिलेगा ही मिलेगा, है ना. मिनिमम टू रूट्स ऑफ f dash of x is definitely possible. हाँ, what is your question? No, that graph is not possible. That graph is not possible. That graph, the one which he's saying, is कि sir, the graph can be in this way. Can the graph can be in suppose यही वाला ग्राफ अगर हो जाए तो, ये वाला ग्राफ हो जाए तो, in this case we are having two distinct solution, लेकिन यहाँ पे three distinct solutions हो गए ना. तो they have said कि exactly two distinct real solutions, so this graph is not possible. The normal cubic polynomial वाला graph is not possible here. Okay, like all three roots are distinct. यहाँ पे two distinct, exactly two distinct real solutions are there. So these are the only two possibilities for the graph. So for all these cases, यहाँ पे tangent is parallel to the x-axis. So definitely these places are the places where f dash of x is equal to 0. इतना तो मालूम होगा ही. So in any case, f dash of x is equal to 0 for exactly two places. So which means that in other words, we can say that f dash of x is having two distinct roots. Two distinct real roots are minimum two distinct real roots are definitely possible. ठीक है, minimum two distinct real roots are definitely possible. So for the first graph, you can see over here कि the graph touches over here at this place. तो यहाँ पे roots are equal, है ना. तो यहाँ पे तो two distinct roots है. Two distinct roots of f dash of x are there. So here the graph touches over here. So this will not work. ठीक है, तो ऑप्शन बी में देखो, ऑप्शन बी में द ग्राफ कट्स एट टू डिस्टिंक्ट पॉइंट्स, है ना. द ग्राफ कट्स एट टू डिस्टिंक्ट पॉइंट्स, व्हिच मींस डेफिनेटली देयर आर टू डिस्टिंक्ट रियल रूट्स ओवर हियर. तो ऑप्शन बी विल बी करेक्ट. तो सी और डी में भी देख लो, सी और डी में भी ऑल्सो हियर ऑल्सो द ग्राफ टचेस, दिस विल नॉट वर्क. एंड डी में तो टच ही नहीं हो रहा है. डी में तो ग्राफ इज नॉट इवन टचिंग ओनली. सो दिस गोज डाउन कंप्लीटली, है ना. तो रूट्स है ही नहीं. तो डेफिनेटली ऑप्शन बी इज करेक्ट. Okay, next we move on to 2022 PYQs. So here we have the first question, which says that we have what is the minimum value of the function mod of x minus 3 plus mod of x plus 2 plus mod of x plus 1 plus mod of x. Now this is a very routine question once again. And the main thing is this is not a question from differentiability, but still I have taken this over here. This is rather a question from functions. वो जहाँ पे वो mod functions वगैरह सीखते हो ना, where you learn all those boat shape diagrams, boat shape graphs when you learn graph transformations and all those things, है ना, graphs of different functions. तो वहाँ पे ये चीज़ें करवाया जाता है. And you should be able to draw the graph of this function. I am saying this thing because this is a very important type of format. काफी बार repeat भी हो चुका है, and they can ask any type of question from here, like what is continuity, what is number of points of continuity, बोलो कि number of, or rather number of points of non-differentiability, है ना. Because there will be sharp corners. Once you draw the graph of this function, you will know that there are sharp corners, sharp turns पे function is not differentiable. ठीक है ना. तो what we do, I'll just teach you the how to draw the graph of this function. ठीक है, कि suppose here देखो, पहले तो आपको देखना क्या है. फर्स्ट यू आर सपोज टू सी द टर्निंग पॉइंट. ठीक है, यू आर फर्स्ट सपोज टू सी द टर्निंग पॉइंट्स. टर्निंग पॉइंट्स क्या क्या है भाई? टर्निंग पॉइंट्स फ्रॉम हियर इज जीरो. टर्निंग पॉइंट्स माने वेयर द ग्राफ इज चेंजिंग इज डेफिनेशन. तो हर एक जो मॉड है ना, ऑल दीज मॉड्स आर प्रेजेंट. यू आर सपोज टू फाइंड द टर्निंग पॉइंट्स ऑफ ईच ऑफ दीज मॉड फंक्शंस. ठीक है, टर्निंग पॉइंट्स और क्रिटिकल पॉइंट्स. इन अदर वर्ड्स यू ऑल्सो कॉल दिस एज क्रिटिकल पॉइंट्स. सो क्रिटिकल पॉइंट्स पे फंक्शन विल चेंज इट्स डेफिनेशन. एंड हाउ टू फाइंड आउट दीज टर्निंग पॉइंट्स हियर? एट टर्निंग पॉइंट्स द फंक्शन, इनर फंक्शन विल बिकम जीरो. तो वो जहां पे वो सोचो, where this inner function will become 0. So x plus x minus 3 will be 0 when x is equal to 3. Similarly, x plus 2 will be 0 when x is minus 2. x plus 1 is 0 when x is minus 1. तो ये टर्निंग पॉइंट है और ये तो 0 ही आ गया. So these are your turning points. And then next what you will do is you will find the function value at these turning points. ठीक है, you'll find what is f of 3, you will find what is f of 2, f of minus 1 and f of 0. ठीक है, तो f of 3 निकालोगे, f of 2 निकालोगे, f of minus 1 निकालोगे और f of 0 निकालोगे. You will find the function value at the turning points. So let's find what is f of 3. f of 3 is what, this part was 0. Then mod लेके निकालोगे, mod of 3 plus 2 is what, 5. ठीक है, mod of 3 plus 1 is what, 4 and mod of 3 is what, 3. So 5 4 3 which is 12 actually. अच्छा, फिर this will be minus 2. I'm sorry, this is minus 2. ये minus 2 होगा because we are finding f of minus 2, right? The turning point is f of minus 2. So you'll find what is f of minus 2. f of minus 2 is what, 5. First one is what, 5. Minus 2 minus 3 minus 5. Mod of minus 5 is what, plus 5. 5 plus 0 plus 1 plus 2. So total हो गया, this is 8. Okay, f of minus 1 is what? f of minus 1 will be 4 plus 1 plus 0 plus 1. And this is equal to 6. f of 0 is what? f of 0 will be 3 plus 2 plus 1 plus 0. And this is equal to 6. So these are your function values. Okay. Now next what will you do? You will search for the highest critical point and the lowest critical point. You will search for the highest turning point and the lowest turning point. माने highest in terms of value. तो highest turning point क्या है यहाँ पे 3 and lowest turning point क्या है यहाँ पे -2, right? तो highest point you will take one extra point more than the highest turning point and one extra point less than the lowest turning point. मतलब क्या है कि highest turning point is what, 3. तो you will also check for the function value at f of 4 and the lowest turning point is what, f of -2. तो -3 करोगे, है ना? एक उस तरफ एक इस तरफ, है ना? हाईएस्ट टर्निंग पॉइंट से ज्यादा, लोएस्ट टर्निंग पॉइंट से कम. तो f of 4 is how much? f of 4 will be 1 plus 6 plus 5 plus 4. So this is basically 16. And f of -3 is how much? f of -3 will be 6 plus 1 plus 2 plus 3. So this is basically 12. These are your function values. Next, what will you do? You will simply join these points. कौन से points? -1, 6, 0, 6, all these points we are having. बस ये point plot कर लो by joining with a straight line. And that's all. We'll have the graph. ठीक है. Okay, so here we have the graph. Let us plot these points accurately on the graph paper. So likewise here we are having 0, 6. So 0, 6 will be somewhere over here, 0, 6. ये height होगा 0, 6. -1, 6. The -1 पे भी the height is same, which is 6. अच्छा, -2 पे we are having 8. So slightly up. -2 पे we are having 8. 3 पे we are having 12. 3 पे we are having 12, which means slightly up over here. 3 पे 12 है. And then we are having 4 पे 16 है. थोड़ा और जाएगा ऊपर, 4 पे 16 है. ठीक है. And lastly, -3 पे 12 है. तो -3 पे 12 will be at the same height. Somewhere over here. -3 पे 12 है. And then next what you're supposed to do, you're supposed to simply join this with the help of a straight line. Straight line नहीं क्यों? क्योंकि यहाँ पे linear है. अगर linear नहीं होता, then we would have joined this. Then we would have done something else. अगर parabola suppose अगर square होता, cube होता, then things would have been different. When linear terms are there, you simply join with a straight line. So once you join this, the graph will be something like this. Now once we have the graph, just look at this graph over here. देखो हर एक पॉइंट पे हर एक टर्निंग पॉइंट है, ये सारे टर्निंग पॉइंट्स है. देखो -2 was a turning point. -2 चार टर्निंग पॉइंट्स है जहां पे 4 places where the graph is turning. So this is one turning point, -2. Then this is one turning point. 1 is one turning point. यहाँ पे देखो टर्न हो रहा है. और -1, सॉरी, -1 is one turning point. 0 is one turning point. यहाँ पर भी ब्रेक हो रहा है, मतलब ब्रेक नहीं, टर्न हो रहा है. यहाँ पे शार्प कॉर्नर है यहाँ पे. ये टर्निंग पॉइंट है. एंड here at 3 also we are having a turning point. ठीक है. Rest of the points are just taken just to mark this or draw this graph accurately. ठीक है, so these are your this is the structure of the graph. और बाकी ये straight lines है, सब के सब straight lines से join करोगे. You will join all of this thing with the help of the straight line, and this is what we are having. This is our final graph. So you can see the minimum value of the function will be at these two places. minimum value पूछा है ना, कि इस पॉइंट पे वो नहीं पूछा है. which point they are not asking for which point you are getting the minimum value. मिनिमम वैल्यू क्या है, तो व्हाट इज द मिनिमम वैल्यू, यहाँ पे आया ना मिनिमम वैल्यू माने लोएस्ट हाइट. यही तो है ना लोएस्ट हाइट, सबसे जो लोएस्ट हाइट है तो यही तो है. तो व्हाट इज दिस 6 है ना, -1 पे और 0 पे. Both of these places we are getting minimum value. So what is the minimum value? Minimum value is what? 6. So option C must be correct. You could have also solved this question with the help of, just simply breaking this function. इसको ब्रेक कर लो, केसेस बना लो. कितने केसेस बनेंगे, दैट विल बी अ बिट लेंदी. लेकिन केसेस कितने बनेंगे, केसेस विल बी समवेयर अराउंड हाउ मेनी 5 केसेस विल बी देयर. व्हाट आर द केसेस? -2 से लेके -1, फिर -1 से लेके 0, फिर 0 से 3 है ना, फिर मोर देन 3, और फिर दिस साइड वी आर हैविंग लेस देन -2. सो ऑल टोटल 5 केसेस आर देयर है ना. तो दैट विल बी अ बिट लेंदी, सो यू कैन गो बाय दिस ग्राफ मेथड व्हेनेवर दिस काइंड ऑफ फॉर्मेट्स आर गिवन. अब देखो, विथ रिस्पेक्ट टू कॉन्टिन्यूटी एंड डिफरेंशिएबिलिटी दे कैन ऑल्सो आस्क द क्वेश्चन इन दिस वे कि व्हाट आर द पॉइंट्स ऑफ नॉन डिफरेंशिएबिलिटी. देखो हर एक टर्निंग पॉइंट्स पे शार्प कॉर्नर्स है. ऑल दीज टर्निंग पॉइंट्स आर हैविंग शार्प कॉर्नर. सो टोटल देर आर 4 पॉइंट्स ऑफ नॉन डिफरेंशिएबिलिटी ओवर हियर. तो हर एक टर्निंग पॉइंट पे देख के ही बोल सकते हो, यू डोंट इवन हैव टू ड्रॉ द ग्राफ. देख के ही बोल सकते हो हर एक टर्निंग पॉइंट पे द फंक्शन इज नॉट डिफरेंशिएबल. ठीक है, सो देर आर 4 पॉइंट्स वेयर द फंक्शन इज नॉट डिफरेंशिएबल. ठीक है ना. Now, suppose you can ask the question, sir, is there any more shorter method by which we can draw these kind of graphs? Yes, there is a much more shorter method by which you don't even have to, find out all these function values and solve. Direct function देखोगे and you will directly draw the graph of the function. So that we'll discuss in a separate session. Okay, we move on to 2021 PYQs. Okay, here we have the first question which says that fx is a twice differentiable function on AB such that f of a is equal to 0 and f of b is also 0. And this differential inequation is given. So what we need to do actually, we need to comment on f, whether f is negative, positive, or 0 for one of the values or more than two values. This is what we need to comment. So we need to comment on f, which means we need to, anyhow, we need to find f from here. So from this differential inequality, how can we generate f? So see, whenever, like I have said, whenever these kind of expressions are given, the manipulations, you need to just manipulate this thing. In general, in nature, the questions are manipulative, okay? Because these kind of expressions are not there in your syllabus. You only have a till, I mean, linear differential equations are there है ना, वो linear terms में है, तो linear, degree 2 वगैरह these things are not there. Order 2 जहाँ पे है, order 2 higher order differential equations are not there. Only order 1 you're solving. So what I try to do, I'll try to bring this into some differentiation format. ठीक है, means this thing will be differentiation of some specific functions. Let us see whether we can do this or not. Likewise, here we are getting x square d2y by dx2 plus dx 4x into dfx by dx or dy by dx. If I try to break this 4x over here, that is x square d2y by d2fx upon dx2 plus 4x. If I write this 4x as 2x, 2x plus 2x, I'm writing this 4x as 2x plus 2x. Okay, so what happens is 2x, this becomes 2x dfx upon dx plus 2x into dfx upon dx plus 2fx, and this is greater than 0. What is the benefit? We can try to think why sir, why do we think of this thing, why, how this will come to your head कि देखो x square is there and 2x is there. Anyhow, if we try to bring this thing, ये फॉर्मेट दिख रहा है ना, x square आ गया, फिर 2x आ गया, फिर dfx है, d2fx है ना, dfx का डिफरेंशिएशन इज d2fx by dx2 है ना. सो दिस वे वी आर ट्राइंग टू जनरेट समथिंग. ये भी देखो डिफरेंशिएशन फॉर्मेट में आ गया अगर ध्यान से देखोगे. सो दिस इज वन डिफरेंशिएशन फॉर्मेट. इफ यू केयरफुली सी, दिस इज डी बाई डी एक्स ऑफ एक्स स्क्वायर इंटू एफ डैश ऑफ एक्स, है ना, और डी एफ एक्स बोलो, वट एवर डी एफ एक्स बोलो कि एफ डैश ऑफ एक्स बोलो, दिस इज डी बाई डी एक्स ऑफ एक्स स्क्वायर इंटू एफ डैश ऑफ एक्स। ये अगर क्लियर नहीं हुआ, सो बेसिकली आई एम राइटिंग दिस डी बाई डी एक्स ऑफ, ध्यान से अगर देखोगे दिस इज नथिंग बट डी बाई डी एक्स ऑफ एक्स स्क्वायर इंटू डी एफ एक्स बाई डी एक्स, है ना, प्लस डी बाई डी एक्स ऑफ, similarly here also we are having 2x into fx, है ना। देखो once you differentiate this thing with the help of product rule, you will end up getting this thing only, है ना। So this quantity is given to be greater than 0, तो d by dx can be taken out common, तो d by dx एक ऑपरेटर है, so this we can take out common from here। तो अगर d by dx को अगर कॉमन लोगे, so we can get some explicit function from here। तो देखो ध्यान से, x square, this is x square f dash of x plus 2x into fx, तो ये कॉमन लेते ही वी आर गेटिंग सम मोर थिंग्स ओवर हियर। ये तो और सिंप्लीफाइड हो गया, देखो ये और सिंप्लीफाई होके वी कैन राइट दिस एज डी बाई डी एक्स ऑफ, दिस ब्रैकेट पार्ट इज नथिंग बट डी बाई डी एक्स ऑफ एक्स स्क्वायर इंटू एफ एक्स, है ना। ये तो और सिंप्लीफाई हो गया, डी बाई डी एक्स ऑफ एक्स स्क्वायर एफ एक्स, मतलब कि दिस एंटायर लेफ्ट हैंड साइड वॉज गिवन टू बी डी बाई डी एक्स ऑफ डी बाई डी एक्स, माने डी टू बाई डी एक्स टू ऑफ दिस फंक्शन एक्स स्क्वायर एफ एक्स, मतलब यही मेन फंक्शन है, ठीक है, यही मेन फंक्शन है डी टू बाई डी एक्स टू ऑफ एक्स स्क्वायर एफ एक्स, दिस क्वांटिटी इज मोर देन जीरो। और ये जान के रखो, डू रिमेंबर दिस थिंग, दिस इज अ वेरी इंपॉर्टेंट कंसेप्ट कि डी टू वाई बाई डी एक्स टू, इफ डी टू वाई बाई डी एक्स टू इज ग्रेटर देन जीरो, मतलब कि फंक्शन इज कॉनकेव अप, कॉनकेव अप। आई हैव सेड दिस थिंग बिफोर एज वेल इन माई प्रीवियस सेशंस कि डी टू वाई बाई डी एक्स टू, if d2 y by dx2 is less than 0, then f is concave down, concave down, concave up माने ये concave up, y is equal to x square वाला होता है ना, y is equal to x square is concave up, and concave down माने ये downwards, concave down, ठीक है। so whenever d2 of dx2 of some quantity is greater than 0, this simply means what, this simply means x square fx is concave up, x square fx will be concave up, ठीक है। सो व्हाट वी कैन कंक्लूड फ्रॉम हियर, दिस इज अ वेरी इंपॉर्टेंट फंडामेंटल एज वेल एज इंपॉर्टेंट कंसेप्ट दैट डी टू एक्स वेन एवर डबल डेरिवेटिव इज पॉजिटिव, डबल डेरिवेटिव इज लेस देन जीरो, माने फंक्शन इज कॉनकेव अप और फंक्शन इज कॉनकेव डाउन। तो आप बोलोगे सर इफ डी टू वाई बाई डी एक्स टू तो जीरो भी हो सकता है, हाँ जीरो इज पॉसिबल इफ दिस इज इक्वल टू जीरो, विच मीन्स एट दैट स्पेसिफिक पॉइंट जहां पे जीरो हो रहा है, दैट पॉइंट इज अ पॉइंट ऑफ इन्फ्लेक्शन, माने वहां पे कॉनकेविटी चेंज हो रहा है। ओके, सो डिटेल में वी लर्न दिस थिंग इन द नेक्स्ट सेशन। In applications of derivatives, there we learn all these things like concavity, convexity, and points of inflection. So x square fx. So now what we know, x square fx is concave up. This will be concave up. Clear? This is concave up. So concave up means the graph will be something like this. Graph will be something like this. और ऊपर से they have said कि f of a is 0. देखो f of a is 0 and f of b is 0. तो एफ ऑफ ए इज जीरो माने सपोज ये कोई एक फंक्शन मान लो y इज इक्वल टू एक्स स्क्वायर एफ एक्स इज है ना, दिस ग्राफ इज आई मीन y का ग्राफ इज कॉनकेव अप, मान लो सपोज ये एक फंक्शन है एक्स स्क्वायर इंटू एफ एक्स। नाउ द थिंग इज एफ ऑफ ए इज गिवन टू बी जीरो एंड एफ ऑफ बी इज गिवन टू बी जीरो, मतलब यहां पे अगर ए डालोगे, इफ यू प्लग इन द वैल्यू ऑफ ए ओवर हियर, दिस विल बिकम ए स्क्वायर टाइम्स ऑफ एफ ऑफ ए विच इज जीरो, ओके, माने y विल बी जीरो, राइट। तो a और b, कैन आई से सिमिलरली सेम थिंग विल गो फॉर b एज वेल, तो कैन आई से a और b आर सिंपली द रूट्स ऑफ दिस फंक्शन, रूट्स ऑफ दिस फंक्शन। और अगर रूट्स है, दीज आर टू डिस्टिंक्ट रूट्स बिकॉज a और b आर व्हाट, डिफरेंट वैल्यूज, डिस्टिंक्ट वैल्यूज, तो a और b आर सिंपली द रूट्स ऑफ दिस फंक्शन, तो ये रूट्स है, क्लियर है। तो a और b आर सिंपली द रूट्स ऑफ द फंक्शन। नाउ वी लुक एट द ऑप्शन, ऑप्शन a सेज f इज नेगेटिव फॉर ऑल x बिलोंग्स टू ab। तो इन दिस इंटरवल देख तो पा रहे हो, द ग्राफ इज लाइंग बिलो द एक्स एक्सिस, द ग्राफ इज लाइंग बिलो द एक्स एक्सिस, और इस रीजन में फंक्शन इज व्हाट, नेगेटिव ओनली। सो व्हेन x इज लाइंग इन बिटवीन माय a टू b, f इज नेगेटिव, सो डेफिनेटली ऑप्शन ए इज करेक्ट, ठीक है। बाकी ऑप्शन भी चेक कर लो, f इज पॉजिटिव फॉर ऑल x बिलोंग्स टू ab, ये तो होगा ही नहीं, अगर ए ट्रू है तो बी तो ट्रू होगा ही नहीं। अच्छा, एफ एक्स इज इक्वल टू जीरो फॉर एग्जैक्टली वन एक्स बिलोंग्स टू ए बी ना। एफ एक्स इज इक्वल टू जीरो कहां पे हो रहा है, टू डिफरेंट वैल्यूज, टू डिफरेंट एग्जैक्टली टू डिफरेंट वैल्यूज पे हो रहा है ना। दैट्स व्हाट दे हैव मेंशन कि एग्जैक्टली टू डिफरेंट वैल्यूज पे फंक्शन कॉनकेव अब भी है, एंड एग्जैक्टली टू डिफरेंट वैल्यूज है ना, एटलीस्ट भी नहीं होगा, एग्जैक्टली टू डिफरेंट वैल्यूज पे फंक्शन इज बिकमिंग जीरो, राइट। सो ऑप्शन ए मस्ट बी करेक्ट. Okay, next we have this question which says that let f r2r be any twice differentiable function such that its second derivative is continuous and dfx by dx is not equal to 0 for all x not equal to 0. And also this limit is given, limit x tend to 0, fx upon x square is pi. So we have to comment on fx. Which of the following options are correct? So basically we need to find the comment on fx, whether fx is more than f0, fx is less than f0, or we need to find d2 fx upon dx2. So all these options are dependent on fx, which clearly states that we need to find out fx. So likewise I have said, do write down whatever you clearly see from here, है ना. So like f is twice differentiable function, फिर second derivative is continuous. So all these are informations what they have given. फिर dfx by dx is non-zero. अच्छा, तो इफ यू डिकोड दिस लिमिट, ये जो है ना लिमिट एक्सटेंडिंग टू जीरो, फर्स्ट ऑफ ऑल तो दिस इज अ फाइनाइट क्वांटिटी, लिमिट एक्सटेंडिंग टू जीरो एफ एक्स अपॉन एक्स स्क्वायर इज अ फाइनाइट क्वांटिटी पाई गिवन, मतलब कि नीचे देखो, नीचे जीरो हो रहा है, एज एक्स टेंड्स टू जीरो दिस पार्ट बिकम जीरो, नीचे जीरो हो रहा है, विच मीन्स अपर लिमिट, लिमिट एक्सटेंडिंग टू जीरो एफ एक्स विल बी ऑल्सो जीरो, एफ जीरो तो जीरो होगा ही भाई, इतना तो क्लियर है कि एफ जीरो विल बी डेफिनेटली जीरो. समझ पा रहे हो ना, अदरवाइज फाइनाइट लिमिट तो देगा ही नहीं, देन ओनली ना यू विल बी गेटिंग जीरो बाई जीरो फॉर्म, एंड दैट विल बी अ स्टैंडर्ड लिमिट, फिर जाके वो फाइनाइट क्वांटिटी आएगा, है ना. सो लिमिट एक्सटेंडिंग टू जीरो, एफ जीरो यहां से जीरो आएगा, समझ पा रहे हो, एफ जीरो विल बी जीरो. सो वन इंफॉर्मेशन वी हैव डिकोडेड कि एफ जीरो विल बी जीरो. What else if we differentiate this thing by the L'Hopital's rule, if we try to solve this thing like f dash of x divided by 2x is equal to pi, we try to differentiate this thing by the L'Hopital's rule. ठीक, so what we get from here again, this limit नीचे देखो, still the form is there, still नीचे we are having zero, denominator is zero, which means numerator has to be zero. So as limit extending to zero, f dash of x will be zero as well, which means f dash of zero will be zero as well. आ गया देखो, f dash of zero is zero as well. One more information we are getting. Again let us differentiate this thing, limit extending to zero by the L'Hopital's rule. So f double dash of x divided by 2 will be pi. ठीक है, चलेगा. सो विच मीन्स कि लिमिट एक्सटेंडिंग टू जीरो, वी कैन से लिमिट एक्सटेंडिंग टू जीरो एफ डबल डैश ऑफ एक्स विल बी इक्वल टू 2 पाई इफ वी क्रॉस मल्टीप्लाई, क्योंकि 2 तो कांस्टेंट है ना. सो विच मीन्स वी आर ऑल्सो फाइंडिंग कि एफ डबल डैश ऑफ जीरो इज ऑल्सो 2 पाई. यहां पे अगर लिमिट्स डालोगे कि एफ डबल डैश ऑफ जीरो इज ऑल्सो 2 पाई, ठीक है. और आप ये भी बोल सकते हो कि सर हाउ डिड यू टेक दिस लिमिट इनसाइड, तो जाएगा तो भाई एफ इज ट्वाइस डिफरेंशिएबल फंक्शन, दे हैव सेड दिस थिंग, एफ इज ट्वाइस डिफरेंशिएबल फंक्शन, ट्वाइस डिफरेंशिएबल है माने कंटिन्यूअस भी है, ट्वाइस कंटिन्यूअस भी है. अगर ट्वाइस कंटिन्यूअस है माने एफ डबल डैश ऑफ एक्स कंटिन्यूअस तो है. सो इफ outer function is continuous, you can take this limit inside and plug in it simply directly. So f double dash of 0 is 2 pi, we are getting from here. देखो, three informations we have generated from this single line itself, है ना. तो what we can say from here, सोचते हैं. अच्छा, तो यहाँ पे सम कंसेप्ट ऑफ एप्लीकेशंस ऑफ डेरिवेटिव्स विल बी यूज, लेकिन वेरी बेसिक कंसेप्ट इज देयर, वेरी बेसिक कंसेप्ट कि देखो भाई एफ डैश ऑफ जीरो, ये अगर देखोगे एफ डैश ऑफ, देखो सिंगल डिफरेंशिएशन, सिंगल डेरिवेटिव इज बिकमिंग जीरो एट एक्स इज इक्वल टू जीरो, एफ डैश ऑफ जीरो इज गिवन टू बी जीरो, ठीक है. ऑल्सो एफ डबल डैश ऑफ, वन मोर थिंग टू सी इज एफ डबल डैश ऑफ जीरो, ये हायर ऑर्डर डेरिवेटिव टेस्ट होता है. देखो एफ डबल डैश ऑफ जीरो इज बिकमिंग 2 पाई, है ना, एंड 2 पाई इज पॉजिटिव. If f double dash of 0, this is a very basic level, basic knowledge I'm using, basic knowledge of applications of derivatives. When you maxima and minima, concept of maxima and minima we are using over here. F double dash of 0, देखो 0 पे f double dash of x is becoming 2 pi. 2 pi is what? Positive. माने 0 is a point of minima, बोल सकते हो ना. 2 pi is what? Positive, which means 0 is what? X is equal to 0 is a point of minima. पॉइंट ऑफ मिनिमा, चलेगा। x इज इक्वल टू 0 इज अ पॉइंट ऑफ मिनिमा, 0 पे पॉजिटिव है, सेकेंड डेरिवेटिव इज पॉजिटिव, ठीक है। व्हेन सेकेंड डेरिवेटिव इज पॉजिटिव, 0 इज सेड टू बी अ पॉइंट ऑफ मिनिमा। व्हेन सेकेंड डेरिवेटिव इज नेगेटिव, दैट पॉइंट इज सेड टू बी अ पॉइंट ऑफ मैक्सिमा, ठीक है। तो सेकेंड डेरिवेटिव इज पॉजिटिव मींस x इज इक्वल टू 0 इज अ पॉइंट ऑफ मिनिमा। तो क्वेश्चन ले लिया अभी, हालांकि क्वेश्चन यहाँ का क्वेश्चन है नहीं, दिस इज नॉट अ क्वेश्चन फ्रॉम दिस सेक्शन, दिस इज अ क्वेश्चन फ्रॉम एप्लीकेशंस ऑफ डेरिवेटिव्स ओनली, ओके। लेकिन कर लेते हैं क्योंकि दिस इज बेस्ड ऑन वेरी बेसिक कंसेप्ट। तो x इज इक्वल टू 0 इज अ पॉइंट ऑफ व्हाट, मिनिमा। तो योर ग्राफ विल बी समवॉट लाइक दिस, 0 पे 0 है, 0 पे फंक्शन वैल्यू इज 0, है ना। ग्राफ विल बी लाइक दिस एंड 0 इज ऑल्सो अ पॉइंट ऑफ मिनिमा। सो द रफ स्केच ऑफ द ग्राफ विल बी समथिंग लाइक दिस, यही चीज बनेगा, ठीक है। द रफ स्केच ऑफ द ग्राफ विल बी समथिंग लाइक दिस। तो what can we comment from here? So when x is 0, देखो x is 0 तो 0 ही हो रहा है। तो when x is non zero, fx is what, क्या बोल रहा है, फर्स्ट ऑप्शन इज सेइंग कि fx is more than f0, fx is more than f0, definitely yes। देखो anywhere you take x over here, anywhere you take x, fx will be this, anywhere you take x, यहां ले लो, यहां ले लो, यहां ले लो, यहां ले लो, because here we are having a point of minima, ये तो minimum value है। तो anywhere you take x, fx will be always more than f0, because f0 तो यहां पे है। Anywhere you take x, this is your fx, this is your fx, fx will be always more than f0, so definitely option A is correct. Okay, next we have this question which says that let f such that R2 0 to infinity be a continuous function such that f of x plus I is equal to fx into fy for all xy belongs to R. Now suppose if f is differentiable at x is equal to 1, okay, which means f dash of x exists at x is equal to 1, dfx by dx at x is 1 is given to be 2. अच्छा, this simply means f dash of 1 is given to be 2, ठीक है। So we have to find the value of f of 1 into log of f of 1. अच्छा, now this is a very standard functional equation which is known to all of you. When fx plus y is equal to fx into fy, you can take this function to be a raised to the power of x itself, right? fx plus x, fx plus y is equal to fx into fy is, you can just directly take the functional equation fx to be, ये स्टैंडर्ड फंक्शन होता है, यू पीपल लर्न दिस थिंग, ये बेसिक चीज है। fx इज a raised to the power of x, एक्सपोनेंशियल फंक्शन है, एक्सपोनेंशियल फंक्शनल इक्वेशन, ठीक है। नाउ द ट्रिक ओवर हियर इज यू कैन टेक a raised to the power of x and solve as well। ये कंडीशन यूटिलाइज करो, use these conditions and simply plug in all these values। in that case you need to also find the value of a भी चाहिए होगा, so use these conditions over here। likewise f dash of 1 is 2, right? so you find what is f dash of 1, ठीक है। तो वहां से you need to find out a and then you have to find out all these values over here, तो वहां से concrete चीज चाहिए। now there is one shortcut technique is basically whenever, देखो f of 1 is given ना, whenever f of 1 is given तो आप f of 1 को ही ले लो a, whenever f of 1 is given ना, यहाँ पे चालाकी से f dash of 1 was given, तो f dash of 1 is given to be 2 and they are asking you to find out what is f of 1। So I have given a note over here कि whenever fx plus y is equal to fx into fy is given and if f of 1 is known to you now, you directly take that as a, माने fx will be f of 1 raised to the power of x, इसी को फंक्शन मान लो, this is itself your function, ठीक है। अब आप बोलोगे सर कैसे आया, how can we consider this thing? So you can prove this thing, I mean I am just showing you this overview of this proof कि आप, तो you people can see from here itself, just if you plug in the value of x and y to be 1 both, so this becomes f of 2 and right hand side will become f of 1 into f of 1 माने f of 1 का whole square, ठीक है। Similarly you plug in the value of x to be 2, x to be 2 and y to be 1, let's say, तो क्या बन जाएगा, this will become f of 2 into f of 1, है ना, and f of 2 is basically f of 1 whole square, मतलब this will become f of 1 का whole cube and so on, this will continue। तो f of 1 के टर्म्स में सारे जो टर्म्स है, you can write all these terms in terms of f of 1 itself। So function can be written in terms of f of 1 raised to the power of x। Now this is only for positive integers I have taken, you can similarly prove this for negative integers, so as well as for rational functions, I mean rational numbers as well, ठीक है। तो ये जनरल प्रूफ भी कर सकते हो, you all can try the general proof। तो इफ एफ ऑफ वन इज गिवन तो आप एफ ऑफ वन को ही डायरेक्ट ले लो, ठीक है। तो दिस विल बी, you can solve the question in a much more faster way. Similarly, I've given few more points over here. तो सेकेंड पॉइंट भी देख सकते हो, सेकेंड पॉइंट में भी देखो, सेकेंड पॉइंट इज एफ एक्स प्लस वाई इज एफ एक्स प्लस एफ वाई, ठीक है। यहां पर भी देखो x इंटू एफ वन इज गिवन, आई हैव टेकन द फंक्शन टू बी x इंटू एफ वन। नॉर्मली फंक्शन क्या होता है, x ही होता है। तो इफ एफ ऑफ वन इज गिवन ना, x बोलो कि ए एक्स बोलो, ए एक्स बोल सकते हो, है ना। ए एक्स होता है फंक्शन, क्या होता है इन जनरल, इफ एफ ऑफ वन इज नॉट गिवन, तो इन जनरल फंक्शन क्या होता है, फंक्शन इज एफ एक्स विल बी ए एक्स, ठीक है। तो आप बोल रहे, यहां पे बोल रहे हैं कि आप अगर फंक्शन एफ ऑफ वन इज गिवन तो यू कंसिडर ए टू बी एफ ऑफ वन इटसेल्फ, जल्दी हो जाएगा, ठीक है। सो नाउ वंस वी नो दिस शॉर्ट ट्रिक, सो व्हाट कैन वी से फ्रॉम हियर, सो एफ एक्स इज एफ ऑफ वन रेज टू द पावर ऑफ एक्स, ठीक है, एंड हियर एक्स बिलोंग्स टू ऑल रियल नंबर्स, चलेगा। तो डी एफ एक्स, चलो डी वाई बाई डी एक्स करेंगे। तो डी वाई बाई डी एक्स इज वॉट, dy by dx of a raised to the power of x will be f of 1 raised to the power of x into log of f of 1, है ना, into log of a, यही होता है ना। a raised to the power of x क्या होता है, a raised to the power of x into log of a। तो a आज क्या है, a is basically f of 1, ठीक है। तो dy by dx, now dy by dx at x is equal to 1 is how much, this will become f of 1 into log of f of 1, this will be dy by dx at x is equal to 1 will be f of 1 into log of f of 1, चलेगा। And this is exactly what they have asked to find out. This is exactly what they have asked to find out. F of 1 into log of f1 is how much? This is exactly what they have asked to find out. और ये चीज तो दे के ही रखा है क्वेश्चन में, ये जो चीज है ये चीज तो दे के ही रखा है क्वेश्चन में। व्हाट इज दिस, 2, है ना। अरे ये जो चीज है ये तो क्वेश्चन में दे के ही रखा है। व्हाट इज दिस, 2, आंसर इज व्हाट, 2 ओनली, ऑप्शन बी इज करेक्ट। This was a very simple question if you know this short trick. Otherwise, you can solve it with a raised to the power of x as well. In that case, you have to find the value of a and just find it. I mean, you have to just show that ki a will be f of 1. ठीक है, तो if f of 1 is given, तो ये याद रखो, if f of 1 is given, then you can directly use this shortcut. ठीक है। अच्छा, आप बोलोगे सर पॉइंट नंबर 1 तो आपने बोला ही नहीं। पॉइंट नंबर 1 इज वेरी सिंपल। देखो, पॉइंट नंबर 1 इज अ जनरल पॉइंट। आई मीन, यू पीपल लर्न दिस थिंग इन कॉशी फंक्शनल इक्वेशंस, है ना। वो जब सीखते हो तो ऑल दिस थिंग्स आर टॉट, ठीक है। इवन इफ यू आर प्रिपेयरिंग फॉर जेई ऑल्सो, यू पीपल विल नो दिस सी कि एफ एक्स इज अ पॉलिनोमियल फंक्शन एंड इफ दिस कंडीशन इज गिवन, दिस रिलेशन इज गिवन, देन एफ एक्स इज 1 प्लस माइनस एक्स टू द पावर ऑफ एन, ठीक है ना। जहां पे ये चीजें बोला जाएगा, दिस इज अ वेरी कॉमन थिंग। आई मीन, गिवन इन ऑल द बुक्स, यू पीपल मस्ट हैव विल नो दिस थिंग। Okay, next we have this question which says that define a function f r to r by this. So we have to comment on the continuity and differentiability of this function. Now this is a very common, basic question. You people have faced these kind of question quite a few times. ठीक है, तो आप क्या करोगे बेसिकली, लेट्स स्टार्ट विद द कंटिन्यूटी पार्ट। तो फंक्शन तो कंटिन्यूअस, फंक्शन इज क्लियरली कंटिन्यूअस फंक्शन। हाउ, देख के बोल सकते हो कि फंक्शन कंटिन्यूअस है कि नहीं। लिमिट डालो, लिमिट एट व्हाट, एट जीरो, ठीक है। लिमिट एक्सटेंडिंग टू जीरो, 1 माइनस कॉस एक्स इंटू साइन ऑफ 1 बाई एक्स। अगर लिमिट्स डालोगे तो दिस विल बिकम 1 माइनस 1 जीरो, एंड दिस इज व्हाट, एंड एनी ऑक्सिलेटिंग वैल्यू फ्रॉम -1 to 1, है ना। तो जीरो इंटू सम फाइनाइट नंबर इन बिटवीन -1 to 1 विल बी जीरो ओनली। तो बस ये जीरो हो गया। सो लिमिटिंग वैल्यू इज जीरो एंड फंक्शन वैल्यू इज ऑल्सो जीरो, विच मीन्स क्लियरली द फंक्शन इज कंटिन्यूअस। सो ऑप्शन ए तो होगा ही नहीं, फंक्शन कंटिन्यूअस है, ठीक है। नाउ वेदर द फंक्शन इज डिफरेंशिएबल और नॉट, what we can do, we can just simply verify with the help of definition key, find what is f dash of 0. So f dash of 0 will be what, limit h tends to 0, limit h tends to 0, f of h minus f of 0, which is 0 only, तो लिखना ही नहीं है, divided by h। तो f of h क्या होगा, f of h is 1 minus cos h, है ना, into sin of 1 by h, और फिर whole divided by h। तो divided by h यहाँ कर देते हैं, divided by h, अच्छा, as h tends to, let's solve this thing. So ये तो this is basically any oscillating number from -1 to 1, ये मालूम तो है ही. Let us deal with this limit. Let's solve this limit. ये कैसे सॉल्व करोगे? 1 माइनस कॉस एक्स. चलो, वी कैन थिंक ऑफ सम ट्रिगो सिंप्लीफिकेशंस. 1 माइनस कॉस एक्स है माने 1 माइनस कॉस एच मीन्स 2 साइन स्क्वायर एच बाई 2. ठीक है, या तो डायरेक्टली लॉपिताल जूली यूज कर दो, वो भी अगर सिंपल लगता है तो आई एम यूजिंग ट्रिगो फॉर्मूला, प्रैक्टिस हो जाएगा. 2 साइन स्क्वायर एच बाई 2, और नीचे क्या है भाई? एच. तो एच को एच बाई 2 बनाओ, है ना. सो दिस 2 एंड दिस 2 विल कैंसिल आउट. तो देखो, साइन एच बाई 2 और एच बाई 2, वन ऑफ दिस साइन एच बाई 2, सोच लो, वन ऑफ दिस साइन एच बाई 2 एंड एच बाई 2 विल बिकम 1, एंड वन ऑफ दिस साइन एच बाई 2 विल बी रिमेनिंग, और वो तो जीरो हो जाएगा. दैट पार्ट विल बिकम जीरो. समझ पा रहे हो ना? साइन एच बाई 2, साइन एच बाई 2 डिवाइडेड बाई एच बाई 2 विल बिकम 1 एज लिमिट एच टेंड्स टू जीरो. वन ऑफ द साइन एच बाई 2 इज रिमेनिंग, एज एच टेंड्स टू जीरो वो जीरो हो जाएगा. तो जीरो इंटू एनी ऑक्सीलेटिंग फंक्शन फिर से क्या हो जाएगा? दिस विल बिकम जीरो, विच मीन्स द फंक्शन इज डिफरेंशिएबल एज वेल. ठीक है, तो बी भी कैंसिल आउट हो गया. एफ इज कंटिन्यूअस बट नॉट डिफरेंशिएबल. डिफरेंशिएबल तो हो रहा है. इसमें एक और ट्विस्ट है. ट्विस्ट इज व्हाट? डेरिवेटिव इज डिसकंटिन्यूअस या फिर डेरिवेटिव इज कंटिन्यूअस. दिस इज आल्सो व्हाट वी नीड टू कमेंट ऑन. एफ डिफरेंशिएबल तो है, वो तो हमने देख ही लिया है. एफ इज डिफरेंशिएबल. नाउ द डेरिवेटिव इज कंटिन्यूअस और डिसकंटिन्यूअस. दिस इज व्हाट वी नीड टू फिगर आउट, व्हिच मींस वी नीड टू फाइंड द डेरिवेटिव ऑफ दिस फंक्शन. ठीक है, इसका डेरिवेटिव माने एफ डैश इज कंटिन्यूअस और नॉट, दिस इज व्हाट वी नीड टू फिगर आउट. तो वो तो कर लोगे, ब्रांच वाइज डिफरेंशिएट करो. ठीक है, एफ डैश ऑफ एक्स ब्रांच वाइज डिफरेंशिएट करोगे. सो वंस यू डिफरेंशिएट दिस थिंग ब्रांच वाइज, क्या आएगा? 1 माइनस कॉस एक्स है. 1 माइनस कॉस एक्स इंटू डिफरेंशिएशन ऑफ साइन 1 बाई एक्स विच इज कॉस ऑफ 1 बाई एक्स इंटू डिफरेंशिएशन ऑफ 1 बाई एक्स विच इज माइनस 1 अपॉन एक्स स्क्वायर, है ना. और फिर प्लस साइन 1 बाई एक्स इंटू डिफरेंशिएशन ऑफ 1 माइनस कॉस एक्स. ठीक है, विच इज साइन एक्स. माइनस माइनस प्लस हो जाएगा, प्लस साइन एक्स. ठीक है, दिस इज व्हेन एक्स इज नॉट इक्वल टू जीरो, एंड दिस इज व्हेन x इज इक्वल टू जीरो, व्हेन दिस इज x इज इक्वल टू जीरो. अब ये तो जीरो ही होगा, जीरो का तो जीरो ही होगा डिफरेंशिएशन. सो दिस इज योर f डैश ऑफ x. अब बोला है कि वेदर दिस इज डेरिवेटिव इज कंटिन्यूअस और नॉट, दिस इज व्हाट वी नीड टू चेक. तो क्या चेक करो? लिमिट चेक करो, यहां से लिमिट चेक करो. अच्छा, दिस इज ऑक्सीलेटिंग नंबर, यही से देखते हैं. दिस इज एन ऑक्सीलेटिंग नंबर, सोच लो. दिस इज एन ऑक्सीलेटिंग नंबर, दिस इज एन ऑक्सीलेटिंग नंबर. अच्छा, 1 माइनस कॉस एक्स डिवाइडेड बाई एक्स स्क्वायर विल टेन टू हाफ. ठीक है, दिस विल टेन टू हाफ. समझ पा रहे हो ना? दिस विल टेन टू हाफ, मतलब सामने माइनस भी है तो दिस विल टेन टू माइनस हाफ. और प्लस साइन 1 बाई एक्स, दिस इज वन सेकेंड एन ऑक्सीलेटिंग नंबर, इंटू साइन एक्स. नाउ साइन जीरो इज जीरो, तो जीरो इंटू एनी ऑक्सीलेटिंग नंबर क्या हो जाएगा? जीरो ओनली. ठीक है, तो दिस लिमिटिंग वैल्यू विल बी माइनस हाफ. लेकिन फंक्शन वैल्यू एफ डैश ऑफ जीरो, एफ डैश ऑफ जीरो इज जीरो, limiting value is minus half, function value is zero, so this is derivative is not continuous, derivative is discontinuous. So option C must be correct. Derivative is discontinuous. यहाँ पे derivative continuous नहीं है. Okay, so next we move on to 2020 PYQs. Here we have the first question which says that for the function on the real line R given by fx is mod x plus 1 plus e raised to the power of x, which of the following is true? Differentiable कहाँ पे ये देखना है बस. So can you see over here that this is a similar type of function which we have learned before, है ना, वो board shape वाला graph. One extra thing what they have given is e raised to the power of x. पूछ रहा है कि uh, whether this is differentiable at which of these following points. x is 0, x is minus 1, half, minus half. ठीक है ना. तो खुद सोचो, e raised to the power of x is always differentiable. वो चार्ट याद है ना, e raised to the power of x is always differentiable. फिर माइनस वन पे दिस फंक्शन इज नॉट डिफरेंशिएबल, क्योंकि माइनस वन पे देयर विल बी अ शार्प टर्न. सो माइनस वन पे नॉट डिफरेंशिएबल. वो बोर्ड शेप वाला ग्राफ में माइनस वन पे नॉट डिफरेंशिएबल. दिस इज ऑल्सो नॉट डिफरेंशिएबल एट जीरो. ठीक है, अब सोचो डिफरेंशिएबल, डिफरेंशिएबिलिटी एट एक्स इज इक्वल टू जीरो. सोचते हैं एट जीरो टर्निंग पॉइंट्स पे देखेंगे, बाकी सब जगह पे तो डिफरेंशिएबल है ही. रिमेनिंग प्लेसेस पे तो द फंक्शन इज डिफरेंशिएबल. ओनली द प्रॉब्लम लाइज एट द टर्निंग पॉइंट्स एंड इन द नेबरहुड ऑफ टर्निंग पॉइंट्स. तो एट जीरो पे दिस इज नॉन डिफरेंशिएबल, दिस इज नॉन डिफरेंशिएबल, प्लस दिस इज डिफरेंशिएबल, है ना. डिफरेंशिएबल प्लस डिफरेंशिएबल इज डिफरेंशिएबल, plus non-differentiable function is always non-differentiable. वो चार्ट से चार्ट याद है ना वो वाला चार्ट. तो non-differentiable plus differentiable function is always non-differentiable. So the function is not differentiable at 0. ठीक है. तो यही से ही b बोल सकते हो, चेक भी नहीं करना है, लेकिन फिर भी चेक कर लो. एट x इज इक्वल टू -1 व्हाट हैपेंस. दिस इज डिफरेंशिएबल, ये तो डिफरेंशिएबल है. At -1 this is non-differentiable, but this is also differentiable. So differentiable plus differentiable is differentiable, plus non-differentiable is a non-differentiable function. So it is not differentiable at -1. और half पे differentiable होगा, half पे this will be differentiable. So option B must be correct, that this is everywhere differentiable except 0 and -1. ठीक है. So these questions are time saver, ये तो verbally solve हो रहा है. Okay, next we have this question which says that f and g are real value differentiable functions on the real line R such that f of gx is equal to x and f dash of x is equal to 1 plus fx square. So some differential equation is given. We have to find out g dash of x. Now f of gx is equal to x. ये बोलो कि ये बोलो, both have the same meaning. So you can start with any of these things because you know this thing that if g is the inverse of f, or या फिर बोलो f is the inverse of g, है ना. If both are inverse of each other, in that case we can say f of gx is x or g of fx is x. Both will hold. This simply means that g is the inverse of f. f is the inverse of g बोलो कि g is the inverse of f बोलो. Inverse कभी भी अकेला नहीं आएगा. Inverse will never come alone. I am the inverse of that function. That function is the inverse of me. ये वाला कंसेप्ट लगेगा. ठीक है. तो I'm starting off with this g of fx. You can also solve with this thing, but going with this method will be much more simpler. G of fx is equal to x. So g dash of fx will be how much? Differentiating both the sides. So g dash of fx into f dash of x by the chain rule, and right hand side we are having a 1. So g dash of fx is how much? 1 upon f dash of x. This is what we are having. We need to find what is g dash of x, right? So we have the value of f dash of x here. So 1 upon f dash of x is 1 upon 1 plus fx का whole square. ठीक है. तो हमने क्या किया, basically we are finding g dash of fx in terms of fx only. So if I replace fx by x, so this looks like a decent function, 1 upon 1 plus x square. तो हाँ, तो बस यही g dash of x है. So option A is correct, 1 upon 1 plus x square. ठीक है. तो यहां से सब सपोज कल को अगर gx भी पूछ ले तो वो भी निकाल सकते हो, gx भी निकाल सकते हो यहां से, है ना. Now suppose if you ask the question, so can we start from the given condition? हाँ भाई, given condition से भी कर सकते हो. That will take 2 or 3 more steps. You can try with the given condition as well. वही differentiation ही करना है, differentiation and differentiate and try to figure out. Okay, next we have this question which says that let f and g be differentiable functions on the real line R with f of 0 is greater than 0. Assume that the set M which is given by t belongs to R such that ft is equal to g of t. This means all the solutions of, or rather the points of intersection of the graphs of ft and g of t, है ना, or all the solutions of this equation fx is equal to g of x, ऐसे सोच लो, is non-empty. This set is non-empty and f dash of t is also greater than or equal to g dash of t for all t belongs to m. Then which of the following is necessarily true? ठीक है. तो हमें ये देखना है कि whether f dash of t is more than g dash of t for some t belongs to m or some t does not belongs to m, or if t belongs to m whether t is less than 0. These are all what we need to verify. मतलब बात वही है कि we need to deal with f and g functions. ठीक है. These conditions have to be maintained. F of 0 is greater than g of 0 and f dash of t is greater than or equal to g dash of t. These conditions needs to be maintained. अच्छा. So for which what we can do, let us try to draw the graph of this f and g functions. Okay, so here I have taken two graphs. This blue graph is the graph of fx. This blue graph is the graph of fx. And this red graph is the graph of gx I have considered. Okay, this red graph is the graph of gx. This has been taken in such a way that f of 0, this is f of 0 and this is g of 0. F of 0 is more than g of 0. And also, these graphs are intersecting somewhere and f dash of t is greater than or equal to g dash of t in most of the places. And at one point, at some point, or at some instant, you can see at this particular point, f dash of x is equal to g dash of x. Okay, f dash of x is equal to g dash of x. At some point, f dash of x is equal to g dash of x. And for the remaining points, you can see, either it's like somewhere over here, you can see that f dash of x, here f dash of x, here the tangent, this tangent is lying above and this tangent is lying below. And for the rest of all these points over here, that f dash of x is more than g dash of x. Okay, that's how we have constructed the graph of the function. So you can clearly see from the graph itself that f dash of t is more than g dash of t only for these places. This is f dash of t and here this is g dash of t. This is more than, f dash of t is more than g dash of t only for these places, only for t positive, है ना? या फिर ये वाला प्लेस, यहाँ देखो, यहाँ पे ग्राफ ऑफ the red graph is lying above, right? The red graph is completely lying above. यहाँ पे in this region f dash of t is less than g dash of t, तो वो हमेशा तो होगा नहीं, so b will be wrong, है ना? b will be wrong. f of t is more than g of t, क्लियरली दिस, यही से ही देख पा रहे हो कि फॉर एनी टी डज नॉट बिलोंग्स टू एम, बोल रहा है कि एफ ऑफ टी इज मोर देन जी ऑफ टी, तो एफ ऑफ टी मोर देन जी ऑफ टी, तो यही वाला ग्राफ देख लो यहाँ पे इन दिस रीजन जी ऑफ टी, यहाँ पे देखो जी ऑफ टी इज वॉट मोर देन एफ ऑफ टी, जी ऑफ टी क्या हो रहा है मोर देन एफ ऑफ टी, कोई ना कोई रीजन लिया ही जा सकता है वेयर जी ऑफ टी इज वॉट मोर देन एफ ऑफ टी, है ना? तो फॉर एनी टी डज नॉट बिलोंग्स टू एम, ये एफ ऑफ टी कैन नॉट बी मोर देन जी ऑफ टी एज वेल, ठीक है? दिस इज नॉट नेसेसरीली ट्रू, तो ये भी ट्रू नहीं होगा, तो ये भी ट्रू नहीं होगा, तो बोल रहा है कि इफ टी बिलोंग्स टू एन देन टी इज नेगेटिव ना भाई, टी पॉजिटिव सोल्यूशन भी तो आ रहा है, पॉजिटिव वैल्यूज भी तो आ रहा है ना? इफ टी बिलोंग्स टू एम वेयर एफ ऑफ टी इज इक्वल टू जी ऑफ टी, जहां पे कहीं पे सपोज सपोज द टू ग्राफ्स आर इंटरसेक्टिंग, सो इट इज नॉट नेसेसरीली ट्रू कि द ग्राफ्स विल इंटरसेक्ट एट द पॉजिटिव रीजन, टी तो पॉजिटिव आ रहा है यहां से, सो ए भी ट्रू नहीं है, सो ऑप्शन डी नन ऑफ द अबव इज करेक्ट. Okay, next we have this question which says that fx and gx are functions on the real line such that both fx plus gx and fx into gx are differentiable. Okay, fx plus gx and fx into gx are differentiable. So which of the following is false? Okay. Option A says fx square plus gx square is necessarily differentiable. Now this is differentiable, this is true, this is not false. This is absolutely true because fx square plus gx square, देखो f square plus g square बोलो तो ये तो आप लोग लिख सकते हो कि f plus g का होल स्क्वायर लिख लो, f plus g का होल स्क्वायर माइनस ऑफ 2 टाइम्स ऑफ f into g, एंड प्रोडक्ट ऑफ टू फंक्शंस इज डिफरेंशिएबल, और ये भी डिफरेंशिएबल तो है ही, सम ऑफ टू फंक्शंस डिफरेंशिएबल गिवन है, सो एंटायर फंक्शन इज फॉर डिफरेंशिएबल फंक्शन, और टू तो कांस्टेंट फंक्शन है, कांस्टेंट फंक्शन इज ऑलवेज डिफरेंशिएबल, सो दिस इज डिफरेंशिएबल माइनस डिफरेंशिएबल, तो डिफरेंशिएबल तो होगा ही, so option A is definitely correct. Now for option B also you can take the help of this chart. It's quite visible from here. देखो if fx is differentiable if and only if gx is differentiable, because देखो product will not matter, product में gx differentiable है कि नहीं, this will not matter, लेकिन sum में this will matter, fx plus gx, so gx has to be differentiable. In order for fx plus gx to be differentiable, तो gx को तो differentiable होना ही है, and if gx is differentiable automatically this will hold for this product also, है ना? fx into gx will be also differentiable if gx is differentiable. So entire thing will hold if gx is differentiable, so which means B is also true. अब देखो fx and gx, option C says fx and gx are necessarily continuous. Now this we can take some counter example and verify. This suppose fx को मान लो fx is 1 when x is greater than or equal to 0 and 0 when x is less than 0. ठीक है? So what is this? A discontinuous function I have taken. And similarly you take one more function gx, which is 0 when x is greater than or equal to 0 and 1 when x is less than 0, है ना? तो in both of these cases can you see over here कि fx plus gx क्या होगा? 1 which is a continuous function, continuous as well as differentiable, है ना? और प्रोडक्ट देखो, प्रोडक्ट भी क्या होगा? कंटिन्यूअस एंड डिफरेंशिएबल, प्रोडक्ट क्या होगा? कंटिन्यूअस एंड डिफरेंशिएबल, ये 0 है, प्रोडक्ट इज व्हाट? प्रोडक्ट ऑफ दीस टू फंक्शंस इज 0 ओनली, 1 into 0 0 into 1, हर एक केसेस में 0 ही होगा. In this case this is also differentiable function, so in any case, ठीक है, तो देख लो भाई, फंक्शन अगर डिफरेंशिएबल fx and gx आर नॉन डिफरेंशिएबल, सॉरी fx and gx आर नॉट कंटिन्यूअस, discontinuous functions there, then also their sum is continuous, their product is continuous, so as differentiable, which means C must be definitely false. कि बोला है कि fx and gx are necessarily continuous. Even if they are not continuous, then also their sum is continuous. So option C must be correct. Which of the following is false पूछा है, so definitely C is false. ठीक है. Okay, next we have this question which says that for any real number x, let box x be the greatest integer m. It's the greatest integer function, so we have to find the number of points of discontinuity of this function gx is equal to box of x square minus 2. So box of x square minus 2, you can simplify this thing by the properties of greatest integer function. This minus 2 can be taken out. You know this thing, box of x square, property, box of x square or box of any function, box of x plus n is basically box of x plus n provided n belongs to z. This is a property of greatest integer function. So you can take this outside. So gx function will be box of x square minus of 2. ठीक है. अब पूछा है कि find the number of points of discontinuity of this function. Now minus 2 is always a continuous function. So if we just deal with this function only, so we are done. So we will just simply deal with the number of points of discontinuity of this function in this interval minus 2 to minus 3 to 3. ठीक है. तो minus 3 और 3 के बीच में let us try to draw the graph of this function. Which function? Box of x square. Box of x square. ठीक है. तो एक रफ स्केच बना लेते हैं. वो पूरा नहीं बनाना है, बेसिकली अ रफ स्केच जस्ट टू फाइंड द कंसर्न. तो वही है ना, बेसिकली वी नीड टू फाइंड द नंबर ऑफ पॉइंट्स ऑफ डिसकंटिन्यूटी. ठीक है ना, स्केच थोड़ी करना है यहाँ पे ग्राफ, लेकिन एक रफ स्केच कर लेते हैं. क्या है कि दीज आर आवर रेस्ट्रिक्शंस. बनेगा तो पैराबोला. ठीक है तो पैराबोला, लेकिन बनेगा ग्राफ कैसा बनेगा? स्टेप फंक्शन. बिकॉज बॉक्स ऑफ एक्स स्क्वायर इज देयर, माने स्टेप फंक्शन, और हर एक स्टेप में वील गेट द पॉइंट्स ऑफ डिसकंटिन्यूटी. चलेगा. सो व्हाट इज दिस? बेसिकली देखो, माइनस 3 और 3 के बीच में ये माइनस 3 है, ये 3 है, ये 0 है. सो माइनस 3 पे और 3 पे देखो, 3 पे फंक्शन वैल्यू क्या होगा? 9 है ना, 3 स्क्वायर 9. और माइनस 3 पे भी फंक्शन वैल्यू 9 है. एंड देयर आर ओपन होल्स ओवर हियर बिकॉज दीज पॉइंट्स आर एक्सक्लूडेड ओवर हियर, है ना, दीज पॉइंट्स आर एक्सक्लूडेड. ठीक है, और यहाँ पे भी कुछ पॉइंट्स मार्क कर लेते हैं. नाउ द थिंग इज, इफ यू ट्राई टू ड्रॉ द ग्राफ ऑफ दिस फंक्शन, ये जो फंक्शन होता है ना, दिस बॉक्स ऑफ एक्स इज ऑलवेज डिसकंटिन्यूअस. ठीक है, बॉक्स ऑफ एक्स जो बॉक्स फंक्शन होता है, बॉक्स फंक्शन इज ऑलवेज डिसकंटिन्यूअस एट इंटीजर पॉइंट्स. इट्स अ वेरी स्टैंडर्ड फंक्शन. Hopefully you people know कि box of x, greatest integer function is always discontinuous at integer points. So when this will be discontinuous? This will be discontinuous when x square is equal to k, where k belongs to integer, where k belongs to z. ठीक है, where k belongs to z. तो x will be what? X will be plus minus root over of k. ठीक है, मतलब क्या हो जाएगा? This will be x will be plus minus root 1, plus minus root 2, plus minus root 3 and so on. Likewise, all these are the points of discontinuity. तो यहां से ओवरव्यू आ गया कि दीज आर द पॉइंट्स ऑफ डिसकंटिन्यूटी. अब देखना है कि विच आर लाइन इन दिस इंटरवल, और जंप कहां पे हो रहा है. जहां पे जंप हो रहा है ना, जहां पे वो स्टेप्स बनेंगे, ऐसे ऐसे करके स्टेप्स बनेगा ना, यहाँ पे सब वन स्टेप देन सेकंड स्टेप. तो एंड दीज प्लेसेस विल बी द पॉइंट ऑफ डिसकंटिन्यूटी. तो सो व्हेन एक्स इज लाइंग इन बिटवीन, ध्यान से देखो. अच्छा, जीरो भी है यहाँ पे, जीरो भी आएगा, जीरो भी तो ले सकते हो. जीरो इज ऑल्सो इंटीजर. सो जीरो प्लस माइनस रूट 1, plus minus root 2, plus minus root 3 and so on. So when x is lying in between 0 and 1, ठीक है, तो x square क्या होगा? x square will lie in between 0 and 2, 0 and 1. तो box of x square will be what? Box of x square in this case will be 0. When x is lying in between root 1 and root 3, box of x square will be what? X square is lying in between 1 and 2, and box of x square will be 1. है ना, बॉक्स तो यही यही ले लेगा ना बॉक्स. सिमिलरली व्हेन एक्स इज लाइंग इन बिटवीन, यहाँ पे इनइक्वालिटी आएगा, इक्वालिटी यहाँ पे नहीं आएगा. इनइक्वालिटी, स्ट्रिक्ट इनइक्वालिटी हियर एट द लास्ट प्लेस. सो रूट 2, व्हेन एक्स इज लाइंग इन बिटवीन रूट 2 टू root 3, in that case x square will be lying from 2 to 3. So box of x square will be what? Box of x square will be 2 and so on. This will continue. कहां तक जाएगा? Until this reaches box of x square is equal to 9. तो इतने सारे इंटरवल्स बनेंगे. These many intervals will be there until box of x square is 9, because box of x square is 9 is the maximum capacity. वो 3 पे जाके गिरेगा, है ना. आउटपुट इज बेसिकली मैक्सिमम कैपेसिटी है ये. ठीक है, दीज मेनी इंटरवल्स विल बी देयर. तो रफली अगर ड्रॉ किया जाए ना ग्राफ, रफली इफ यू ट्राई टू ड्रॉ द ग्राफ, देखो एट व्हेन x is lying in between 0 and 1, एक्स स्क्वायर इज लाइंग इन बिटवीन 0 and 1, बॉक्स ऑफ एक्स स्क्वायर विल बी 0। मतलब फंक्शन क्या बनेगा, फंक्शन 0 का फंक्शन बनेगा, 0 का ग्राफ बनेगा, है ना। तो 0 और 1 के बीच में y इज इक्वल टू 0 इज द फंक्शन, और 1 पे होल बनेगा। दिस इज द ग्राफ ऑफ द फंक्शन, 1 पे होल बनेगा, और 1 पे चेंज हो रहा है डेफिनेशन। ओके, सो नेक्स्ट ब्रांच इज फ्रॉम वेयर, नेक्स्ट ब्रांच इज फ्रॉम when what happens when x lies in between √1 to √2। अब √1 माने तो 1 ही है, तो √1 से लेके √2 में बॉक्स ऑफ एक्स स्क्वायर इज 1, है ना। तो बॉक्स ऑफ एक्स स्क्वायर माने 1 माने y इज इक्वल टू 1 होगा। तो ग्राफ विल बी समथिंग लाइक दिस। यहाँ पे जंप हो रहा है, 1 पे जंप हो रहा है, ठीक है, 1 पे जंप होगा, देन द ग्राफ विल बी समथिंग लाइक दिस। और यहाँ पे समवेयर हियर वी आर हैविंग √2 मान लो, ठीक है, और यहाँ पे √3 मान लो। √2 इज 1.414, √3 इज 1.732, ठीक है। तो √2 और √3 के बीच में बॉक्स ऑफ एक्स स्क्वायर इज 2, तो 2 वाला ग्राफ होगा, एंड सो ऑन दिस विल कंटिन्यू। और हर एक पॉइंट पे दीज आर द पॉइंट्स ऑफ डिसकंटिन्यूटी, दीज आर द पॉइंट्स ऑफ डिसकंटिन्यूटी। ये एक पॉइंट हो गया, दिस इज वन पॉइंट ऑफ डिसकंटिन्यूटी, है ना, दिस इज वन पॉइंट ऑफ डिसकंटिन्यूटी एंड सो ऑन। तो हाउ मेनी सच पॉइंट्स विल बी देयर। देखो, मेनी ऑफ यू विल से कि सर देर आर 9 पॉइंट्स ऑफ डिसकंटिन्यूटी। ना भाई, 9 पॉइंट्स नहीं है, दीज आर नॉट 9 पॉइंट्स। ओके, हर एक पॉइंट पे डिसकंटिन्यूटी कहां से स्टार्ट हो रहा है, यहां से स्टार्ट हो रहा है, 1 से स्टार्ट हो रहा है ना, यहां से स्टार्ट हो रहा है, फ्रॉम दिस पॉइंट द डिसकंटिन्यूटी स्टार्ट्स, ठीक है। 0 to 1 में देयर इज नो डिसकंटिन्यूटी। इस वाले पॉइंट पे व्हेन एक्स स्क्वायर इज इक्वल टू 0, यहां पे डिसकंटिन्यूटी है ही नहीं, यहां से स्टार्ट हो रहा है, ठीक है, यहां से 1 से लेके √2, तो शुरू ही हो रहा है 1 से। तो हर एक पॉइंट पे सोच लो 1 के बाद में, आफ्टर 1, ठीक है, व्हेन बॉक्स ऑफ एक्स स्क्वायर बिकम्स 1, फॉर ईच पॉइंट्स विल फाइंड different points of discontinuity. For each of these points, we'll find different points of discontinuity. So how many such points will be there? 8 points are there. ठीक है, starting from 1। तो हर एक जंप में for all of these jumps we'll be having 8 jumps over here, 8 jumps on this side and 8 jumps on this side। count करोगे, if you count all the points here, total 8 points of discontinuity will be there on this side। हर एक जंप पे एक कंटिन्यूटी आएगा, डिसकंटिन्यूटी आएगा हर एक जंप पे। तो 8 jumps will be there over here, we will be having total 8 such jumps over here on this positive side, and similarly 8 such jumps will be there on the negative side as well। same jump, same graph यहां पर भी होगा on this side, left hand side। so total 8 jumps over here, 8 points over here and 8 points over here, so total 16 points of discontinuity will be there। option D is correct। okay, here we have this question from differential equations, we have to prove the family of curves। this is the family of curves given satisfies this differential equation given। okay, just to save some time I've given the solutions here। तो ये जो है लॉजिक क्या होता है फॉर दिस काइंड ऑफ क्वेश्चंस, यू मस्ट हैव नोन कि whenever we have to form some differential equation from some given condition, we have to form some differential equation। in that case our target will be to eliminate any kind of parameter or any kind of arbitrary constants, right। a square and b square are basically what, these are fixed constant, ये arbitrary constant नहीं है, हालांकि यहाँ पे mention नहीं है। lambda is basically a parameter। how do we know, sir, how do we know this thing कि a square and b square are fixed constants, कि a square and b square is given in the differential equation whatever they have asked to prove। मतलब whatever they have asked to prove वहां पे lambda नहीं है। तो lambda क्या है भाई, lambda is the parameter present over there, and whatever parameters या फिर arbitrary constants whatever are there, you need to eliminate them anyhow, and the number of parameters will decide the number of times you will differentiate। कि यहाँ पे देखो एक ही पैरामीटर है, ओनली वन पैरामीटर इज देयर, सो विच मींस वी हैव टू डिफरेंशिएट दिस वंस, एंड व्हाटएवर दे हैव आस्क्ड टू प्रूफ यू कैन क्लियरली सी ओवर देयर dy by dx is given, which means we have to differentiate once only। ठीक है, so what I have done is I have differentiated this once। so our first target is to what, eliminate this lambda, eliminate, remove this lambda। so see I'm differentiating this first, so 2x upon a square plus lambda plus 2y y dash upon b square plus lambda is equal to 0। बेसिक डिफरेंशिएशन, नीचे वाला पार्ट कांस्टेंट। so we get y y dash, if you separate this thing we get y y dash। ये पूरा अगर सेपरेट कर लोगे so फाइनल में we will get something like this। ये रेशियो आएगा b स्क्वायर प्लस लैम्डा डिवाइडेड बाई a स्क्वायर प्लस लैम्डा, लैम्डा इज स्टिल नॉट गॉन। अभी तो लैम्डा निकालना है, बेसिकली लैम्डा वी हैव टू एलिमिनेट। ठीक है, तो लैम्डा आफ्टर रीअरेंजिंग द टर्म्स वी आर गेटिंग b स्क्वायर प्लस लैम्डा अपॉन a स्क्वायर प्लस लैम्डा इज माइनस y y डैश डिवाइडेड बाई x। Now lambda is stuck in the numerator as well as in the denominator. So what I'm doing is I'm subtracting 1 on both the sides just to remove this lambda. तो अगर 1 से अगर subtract करोगे तो what will happen? This will become b square plus lambda minus a square minus lambda. तो this lambda lambda will cancel out. तो b square minus a square is remaining. ऊपर क्या बचेगा? b square minus a square. ठीक है. And right hand side will be minus of y dash minus of x divided by x. ठीक है. तो माइनस साइन कैन बी टेकन आउट. तो माइनस कॉमन ले लो, प्लस बना दो. एंड दिस माइनस साइन कैन बी एडजस्टेड विद दिस. नीचे क्या हो जाएगा? यहाँ पे लेफ्ट हैंड साइड में ए स्क्वायर प्लस लैम्डा, राइट हैंड साइड में दिस. तो माइनस साइन कैन बी कैंसिल फ्रॉम बोथ द साइड्स एंड यू कैन मेक दिस एज ए स्क्वायर माइनस बी स्क्वायर डिवाइडेड बाई ए स्क्वायर प्लस लैम्डा. और लेके ये माइनस साइन कैंसिल कर देना. एंड आफ्टर रीअरेंजिंग द टर्म्स क्या बचेगा? दिस विल रिमेन टू बी ए स्क्वायर प्लस लैम्डा. के लिए सॉल्व कर लो बिकॉज चाहिए तो वही लैम्डा चाहिए ना. सो आई एम सॉल्विंग फॉर ए स्क्वायर प्लस लैम्डा. To rearrange and simply solve for a square plus lambda. A square plus lambda is what? A square minus b square. Cross multiply a square minus b square x divided by x plus y dash, y dash. ठीक है. तो once we are finding the value of a square plus lambda, तो we can actually find the value of b square plus lambda as well. कहाँ से? यहाँ से, from here. तो we can find the value of b square plus lambda as minus y dash divided by x. This into a square minus b square. माने into the value of a square plus lambda. वो क्या है? This ना. Into the value of, once you cross multiply, ये क्या बन जाएगा? This quantity into a square plus lambda. तो क्रॉस मल्टीप्लाई दिस थिंग, तो क्या बनेगा? ए स्क्वायर माइनस बी स्क्वायर डिवाइडेड बाई एक्स प्लस वाई डैश इंटू एक्स. एक्स एक्स विल कैंसिल आउट. बेनिफिट है. तो वाई डैश इंटू ए स्क्वायर माइनस बी स्क्वायर डिवाइडेड बाई एक्स प्लस वाई डैश. तो एक्सप्लिसिटली वी आर फाइंडिंग द वैल्यू ऑफ ए स्क्वायर प्लस लैम्डा एंड बी स्क्वायर प्लस लैम्डा. और ये लेके क्या करो? यू सिंपली प्लग इन दिस थिंग इन द गिवन डिफरेंशियल इक्वेशन, मतलब गिवन इक्वेशन. ये लेके वंस वी हैव फाउंड आउट दीज वैल्यूज, क्योंकि ये क्या है ना, नाउ वाई कैन यू प्लग इन दिस वैल्यू ओवर हियर? द रीजन बीइंग, देखो लैम्डा इज कंप्लीटली गॉन. ये डाल दोगे ना. वंस यू फिगर्ड आउट द वैल्यू ऑफ ए स्क्वायर प्लस लैम्डा, खुद सोचो. ए स्क्वायर प्लस लैम्डा वी हैव गॉट, बी स्क्वायर प्लस लैम्डा वी हैव गॉट. वी कैन जस्ट सिंपली टेक दिस एंड प्लग इन ओवर हियर, है ना. और हर एक टर्म में देखो राइट हैंड साइड में लैम्डा है ही नहीं. लैम्डा इज नॉट प्रेजेंट ऑन द राइट हैंड साइड. सो यू कैन सिंपली टेक दिस एंड प्लेस इट ओवर हियर. तो क्या बचेगा? एक्स स्क्वायर अपॉन दिस क्वांटिटी प्लस वाई स्क्वायर अपॉन दिस क्वांटिटी. जस्ट प्लग इन ऑल दीज वैल्यूज and simplify. You will get some cancellations. देखो x square and this x is cancelling out, y square and this y is cancelling out. ठीक है. तो बचेगा क्या? this quantity is remaining. तो x अपॉन, so once you cross multiply, ये लेके cross multiply भी कर दो. ठीक है. cross multiply काट छाट करके there are so many cancellations getting generated. और फिर cross multiply करोगे तो क्या आएगा? x minus y upon y dash. And right hand side में this will become a square minus b square upon x plus y dash. And once you rearrange and simplify, you will get this form. ये चीज आ जाएगा. ठीक है. You will get this form and this is exactly what they have asked to prove. See, x plus y dy by dx into x y dash माने x dy by dx minus of y माने ये, and right hand side we are getting a square minus b square into y dash माने a square minus b square into dy by dx. तो you will get the form. ठीक है. Okay, next we move on to 2019 PYQs. Okay, so here we have the first question. This is a quite easy question given. The function is y is e raised to the power of kx given, and this satisfies this given differential equation. For you have to comment, we have to find the values of k basically. We need to find the how many values of k for which this function will satisfy this given differential equation. तो कुछ नहीं भाई. तो you find what is y is equal to kx is given, so you find dy by dx, find d2y by dx2, and simply plug in the value over here. I have given the solution over here just to save some time. ठीक है. जो complicated questions है, those questions I'm solving, and जो some of the very basic questions I have simply given the solutions over here. तो ये डिफरेंशिएट करो dy by dx, d2y by dx2, you will get this over here. Basic differentiation है, सबको आता है. And simply place the values over here. तो this will become this. ये चीज मिल जाएगा यहाँ से. k square e raised to the power of kx plus k into e raised to the power of kx. Similarly, k into kx e raised to the power of kx minus e raised to the power of kx. इन राइट हैंड साइड में ऑल्सो यू विल गेट समथिंग ई रेस टू द पावर ऑफ के एक्स इंटू के टाइम्स ई रेस टू द पावर ऑफ के एक्स. तो यहाँ से क्या करो? के कॉमन लो, ई रेस टू द पावर ऑफ के एक्स भी कॉमन लो, के एक्स होल स्क्वायर कॉमन लो. बेसिकली ई रेस टू द पावर ऑफ के एक्स फ्रॉम हियर एंड ई रेस टू द पावर ऑफ के एक्स फ्रॉम हियर. लेफ्ट हैंड साइड में होल स्क्वायर कॉमन जा रहा है and this can be cancelled out. Left hand side, right hand side, both sides we are having e raised to the power of kx whole square. So both of these can be cancelled out because e raised to the power of kx is what? Not equal to 0. ठीक है, तो आप लोग कैंसिल आउट कर लो। ठीक है, तो ओनली दिस मच विल बी रिमेनिंग, के स्क्वायर प्लस के इंटू के माइनस वन विल बी के। और ये तो सॉल्व करना इजी है, सो यू विल गेट सम क्वाड्रेटिक हियर, के इंटू के स्क्वायर माइनस के। तो इफ यू सिंप्लीफाई दिस थिंग, दिस इज नथिंग बट के माइनस के कॉमन ले लो, के स्क्वायर माइनस वन इज जीरो। तो क्या आ जाएगा, के इज बेसिकली के स्क्वायर माइनस टू विल बी जीरो, तो के विल बी जीरो। और के विल बी के स्क्वायर माइनस टू इज जीरो, माने के इज वॉट, प्लस माइनस टू। तो के इज जीरो नहीं तो प्लस माइनस टू। सो टोटल थ्री वैल्यूज ऑफ के आर पॉसिबल, सो ऑप्शन सी मस्ट बी करेक्ट, थ्री डिस्टिंक्ट वैल्यूज ऑफ के। वेरी सिंपल क्वेश्चन, दिस इज वन ऑफ द इजीएस्ट क्वेश्चंस। डिफरेंशिएट कर लो, वैल्यूज डालो और सॉल्व कर लो के लिए। इट्स अ यूजीबी क्वेश्चन। देखो क्वेश्चन क्या बोल रहा है, लेट एफ सच दैट जीरो टू इन्फिनिटी टू आर बी डिफाइंड बाय एफ एक्स टू बी दिस फंक्शन। तो ये इनबिल्ट लिमिट्स है। व्हाट इज दिस, इनबिल्ट लिमिट्स माने फंक्शन इज इटसेल्फ डिफाइंड इन टर्म्स ऑफ लिमिट्स। ठीक है, तो show that f has exactly one point of discontinuity and b says evaluate f at its points of discontinuity. तो very first thing what you need to do is you need to define the function properly. तो fx को ठीक से लिखते हैं, fx is limit n tends to infinity, this is cos of 1 upon n to the power of x whole raised to the power of n. Now if you see the form here, as n tends to infinity, 1 by n raised to the power of x will tend to 0, माने cos 0 is what, 1। तो ये 1 raised to the power of infinity वाला फॉर्म है। ठीक है, तो स्टैंडर्ड फॉर्म है, यू नो हाउ टू डील विद दिस फॉर्म्स। ठीक है, तो फॉर्मूला क्या होता है, फॉर्मूला इज ई रेस टू द पावर ऑफ लिमिट, याद है ना, ई रेस टू द पावर ऑफ लिमिट एन टेंस टू इन्फिनिटी, दिस एन विल कम डाउन एन इंटू कॉस वन बाई एक्स एन इंटू एफ एक्स माइनस वन, माने कॉस ऑफ वन अपॉन एन रेस टू द पावर ऑफ एक्स माइनस वन। यही तो होता है ना, दैट्स व्हाट वी डू। एंड आई एम सेइंग दिस थिंग अगेन, दिस इज यूजीबी क्वेश्चन। I'll recommend you to also give the proof of this form. You're directly using this formula, that's fine. I'll also recommend you to give the proof of this form। ठीक है, तो प्रूफ तो कोई भी बुक में मिल जाएगा, बेसिकली द प्रूफ फॉर दिस वन रेज टू द पावर ऑफ इन्फिनिटी वाला फॉर्म। एक क्लेम डाल के साइड में, वंस यू आर डन विद दिस क्वेश्चन, लास्ट में क्लेम डाल के वो चीज दे देना कि सीधा प्रूफ की क्लेम डाल के, वट एवर यू आर क्लेमिंग, आई मीन यू आर क्लेमिंग दैट दिस वन रेज टू द पावर ऑफ इन्फिनिटी, दिस फॉर्मूला वी आर यूजिंग, दिस फॉर्मूला, जस्ट स्टेट द फॉर्मूला एंड जस्ट प्रोसीड। देन आई हैव सेड द सेम थिंग फॉर माई लिमिट सेशन एज वेल। ठीक है, वो किसी एक क्वेश्चन में यही वाला फॉर्म, किसी एक क्वेश्चन नहीं, आई मीन इन वेरियस क्वेश्चंस आई गेस वी हैव डिस्कस दिस थिंग एंड आई हैव सेड दिस ओवर देयर कि यूजीबी है, बी सेफ फ्रॉम योर साइड एंड प्लीज मेंशन द फॉर्म्स। तो ई रेज टू द पावर ऑफ लिमिट एन टेंड्स टू इन्फिनिटी, देखो वी आर गेटिंग दिस थिंग, सो वी नीड टू सॉल्व दिस लिमिट। तो ये तो आप लोग नॉर्मली सॉल्व कर सकते हो कि कॉस ऑफ वन अपॉन एन रेज टू द पावर ऑफ एक्स माइनस वन डिवाइडेड बाई, ब्रिंग दिस एन डाउन, सो वी आर वन बाई एक्स। ठीक है ना, तो वन बाई एक्स कर लो। तो एक और काम कर लो, क्योंकि वन बाई, देखो सेम बाई सेम फॉर्म चाहिए, याद है ना, वन माइनस कॉस एक्स डिवाइडेड बाई एक्स एक्स स्क्वायर, वन माइनस कॉस एक्स डिवाइडेड बाई एक्स स्क्वायर वाला फॉर्म, तो वो सेम बाई सेम वाला फॉर्म चाहिए, देन ओनली वी कैन से दैट टू बी एस हाफ, है ना। लिमिट एक्सटेंडिंग टू जीरो, वन माइनस कॉस एक्स अपॉन एक्स स्क्वायर लिमिट फॉर्म है। इफ यू हैव डन द लिमिट सेशन बिफोर, देन यू विल नो ऑल दीस फॉर्म्स। तो वन बाई एन रेज टू द पावर ऑफ एक्स फोर्सफुली ले लो। ठीक है, तो यहां से तो माइनस कॉमन ले सकते हो, सो वन बाई एन रेज टू द पावर ऑफ एक्स फोर्सफुली ले लो, वन बाई एन रेज टू द पावर ऑफ एक्स होल स्क्वायर ले लो, मल्टीप्लाई एंड डिवाइड बाई वन बाई एन रेज टू द पावर ऑफ एक्स होल स्क्वायर, राइट, डिवाइडेड बाई ये जो वन बाई एन था यहाँ पे, सो यू ब्रिंग दिस वन बाई एन हियर। सो व्हाट इज द लॉजिक, बेसिकली ये जो चीज है, दिस पार्ट विल टेंड टू माइनस हाफ। अभी एक माइनस कॉमन लोगे तो दिस विल बिकम हाफ ना, सो दिस पार्ट विल टेंड टू माइनस हाफ वंस यू डिस्ट्रीब्यूट द लिमिट्स, तो दिस पार्ट विल टेंड टू माइनस हाफ। ठीक है, अब आप बोलोगे सर यहाँ पे तो वो तो फॉर्म तो यहाँ पे एक्स टेंड्स टू जीरो था, अरे भाई लिमिट एक्सटेंडिंग टू जीरो बोलो कि लिमिट एन टेंड्स टू इन्फिनिटी, फॉर्म क्या था, वन माइनस कॉस सेम डिवाइडेड बाई सेम का होल स्क्वायर। तो कॉस वन बाई सेम, देखो सेम तो है ही, वन माइनस कॉस सेम डिवाइडेड बाई सेम का होल स्क्वायर, एंड द सेम क्वांटिटी शुड टेंड टू जीरो एज एक्स टेंड्स टू जीरो, तो यहाँ पे तो एन टेंड्स टू इन्फिनिटी है, तो इन दैट केस वन बाई एन रेज टू द पावर ऑफ एक्स विल टेंड टू जीरो, सो विच मीन्स दिस फॉर्म विल होल्ड। तो व्हाट इज रिमेनिंग, दिस क्वांटिटी इज रिमेनिंग, तो योर लिमिट गेट्स रिड्यूस टू e raised to the power of limit n tends to infinity माइनस हाफ इंटू, ये तो सेपरेट हो गया माइनस हाफ, एंड द रिमेनिंग पार्ट इज व्हाट, n रेज टू द पावर ऑफ, ये कितना होगा, दिस विल बिकम n रेज टू द पावर ऑफ 2x डिवाइडेड बाई n, 1 बाई n, So this will become n raised to the power of 1 minus 2x. Simplify, okay, this will become n raised to the power of 1 minus 2x. Now, this 1 minus 2x, now we'll define this limit. This limit will be completely dependent on this 1 minus 2x. So ये definition देख लो भाई. This is the main part. You need to define this properly. तो ये जो n minus n raised to the power of 1 minus 2x, I'm dealing with this first, ठीक है? Limit n tends to infinity. Look at this part carefully. n raised to the power of 1 minus 2x. और फिर बाकी वो limit part आएगा. ठीक है? This is your fx. तो वो define भी करना है ठीक से. तो I'm defining this first. ध्यान से देखो. तो when 1 minus x, 1 minus 2x, 1 minus 2x is negative. सोच लो. When the upper part is negative, ठीक है, upper part is less than 0. तो upper part is less than 0 माने क्या? n raised to the power of negative quantity सोच लो. n raised to the power of negative माने क्या? 1 by n raised to the power of positive सोच लो. सॉरी, 1 by n raised to the power of positive सोच लो, है ना? n negative माने 1 by raised to the power of n positive. So as n tends to infinity, this will tend to 0. So in this case, this limit will become 0. सोच लो, in this case, this limit will become 0. माने ये जो limit है, this will become 0. So when 1 minus 2x is less than 0, मतलब क्या होगा? 1 is less than 2x. मतलब क्या होगा कि half less than x, माने x is more than half. समझ पा रहे हो ना? इतना बेसिक्स तो क्लियर है, ठीक है? अच्छा, now when 1 minus 2x is greater than 0, what happens then? When 1 minus 2x is greater than 0, this part is positive in that case. So infinity raised to the power of positive सोच लो, या फिर n raised to the power of positive quantity. n raised to the power of positive quantity. तो infinity raised to the power of positive quantity, infinity whole square मान लो. तो infinity whole square is positive only, infinity only. So in that case, this will be infinity. In that case, this will be infinity only. This limit will tend to infinity only. ठीक है ना? मतलब when 1 minus 2x is greater than 0, x will be what? X will be less than half. And lastly, when 1 minus 2x is equal to 0, x will be what? X will be half. X will be half. So in that case क्या होगा? n raised to the power of 0, anything raised to the power of 0, large quantity raised to the power of 0, क्या होगा? Will become 1. Anything raised to the power of 0 is what? 1. So this is the limit actually. Now based on this limit, now see. So now we clearly have the idea of the function. The function is dependent on three things. What happens when x is more than half? What happens when x is less than half? And what happens when x is equal to half? So when x is more than half, this quantity becomes 0. This limit becomes 0. So minus half times of 0, मतलब 0 होगा. This will become 0. मानते हो ना? When x is more than half, this will become 0. तो e raised to the power of 0 क्या हो जाएगा? Limit quantity is completely 0. तो e raised to the power of 0 is 1. And when x is less than half, this will be infinity. Limit will be infinity. And सामने minus है. तो e raised to the power of minus infinity will tend to 0. And when x is equal to 0, this quantity will become what? Sorry, when x is equal to half, ये half होगा, sorry. And when x is equal to half, this quantity will be equal to 1. ये 1 हो जाएगा, and this will become minus half. है ना? This will completely become minus half. तो e raised to the power of minus half ही बचेगा. ठीक है? And clearly we can see there is exactly one point of discontinuity. दोनों ही proof हो गया देखो. Show that f has exactly one point of discontinuity. This is exactly one point of discontinuity, which is half. ठीक है? X is equal to half is the only point of discontinuity. लिख लेना. Is the only point of discontinuity. Properly लिख लेना ठीक से. And part B says evaluate f at its points of discontinuity. तो f of half देख लो क्या होगा? f of half will be what? Half is the only point of discontinuity ना, तो f of half is what? E raised to the power of minus half. बस हो गया. E raised to the power of minus half. खत्म है. f at its points of discontinuity they have said. तो half is the only point of discontinuity. ठीक है? तो ये प्रॉपरली क्लियरली आपको दिखाना है ऑल दीज थिंग्स व्हाट एवर आई हैव सेड, और लास्ट में जाके क्लेम डाल देना. क्लेम डाल के बोल देना कि ये प्रूफ, just state the proof of this particular thing, of this formula. ठीक है? This was once again a moderate question, not that too difficult. Okay, next we move on to 2018 PYQs. Okay, here we have the first question which says that f such that R to R and G such that R to R be two functions, two real functions are given, and we have two statements. First statement says that if limit extends to 0, fx exists, and limit extends to 0, fx into gx exists, the product of the two functions exist, then limit extending to 0 extends to 0, g of x will definitely exist. And statement 2 says if f and g are differentiable with fx is less than gx for every real number x, then f dash of x is less than g dash of x for all x. So we have to say that which of the following is a correct statement. Okay, so let's look at the first one. If limit extends to 0 exist and fx into gx will also exist, then gx बोल रहा है कि gx उल्टा gx must exist. अब ये तो गारंटी है नहीं. The reason being this you can prove using a counter example. कि suppose देखो limit extending to 0 fx exists माने this is basically suppose ये limiting value is 0 let's say. This limiting value is 0. ठीक है, 0 प्लस में भी 0 दे रहा है, 0 माइनस में भी this is giving 0. ठीक है. Now gx, now whatever you choose gx, suppose gx is not existing only. ठीक है, gx is not existing only, वो कुछ भी हो जाए, but this is तो once you distribute the limits this is तो 0. तो 0 इंटू लेफ्ट हैंड लिमिट मान लो सपोज l है, राइट हैंड लिमिट मान लो सपोज r है. तो 0 इंटू l बोलो कि 0 इंटू r बोलो, तो दैट विल ऑलवेज गिव यू 0 ना. तो लिमिट तो एग्जिस्ट तब भी करेगा. डेफिनेटली द लिमिट विल एग्जिस्ट इन दैट केस if this becomes 0. तो gx must exist is a wrong statement. ठीक है, तो gx may or may not exist. Let's say what I'm trying to say is if limit extending to, सोच लो, if limit extending to 0 plus पे gx is the right hand limit is r, let's say some different limit, और 0 minus पे कुछ different limit आ रहा है l let's say. ठीक है, तो 0 इंटू एल बोलो कि 0 इंटू आर बोलो, कुछ भी ले लो, फंक्शन वैल्यू तो 0 ही दे. लिमिट एक्सटेंडिंग टू 0 एफ एक्स इंटू जी एक्स विल बी 0 ओनली. तो इन दैट केस जी एक्स मे नॉट एग्जिस्ट. ठीक है, तो ये P1 ट्रू, P1 तो हमेशा ट्रू होगा नहीं. ठीक है, तो P1 फॉल्स ही होगा, P1 इज फॉल्स. अब देखो P1 इज ट्रू, जहां जहां P1 इज ट्रू है ना वो उसको हटाओ. बोथ P1 P2 आर ट्रू, नॉट P1 इज फॉल्स. ठीक है, ये P1 फॉल्स ऑप्शन डी में दिख रहा है, सो डी कैन बी वन पॉसिबिलिटी एंड बी कैन बी वन पॉसिबिलिटी. सी भी रॉन्ग है, P1 कैन नॉट बी ट्रू, P1 इज नॉट ट्रू. ठीक है, अब देखो स्टेटमेंट 2 चेक ही करना है, तो बी और डी में होगा. तो बी और देखो P of 2 says if f and g are differentiable with fx is less than gx for every real number x, then f dash of x is always less than g dash of x. So this we can take the help of a counter example. What we do is we simply take two functions where fx is less than gx, two standard functions I am taking where fx is less than gx, but f dash of x may not be less than g dash of x. ठीक है, तो वो उसके लिए क्या करो, आप लोग एक स्टैंडर्ड फंक्शन ले लो. तो द बेस्ट थिंग इज बेसिकली सी आई हैव कंसिडर द एग्जांपल ऑफ e raised to the power of minus x. ये डिक्रीजिंग फंक्शन है, and e raised to the power of minus of e raised to the power of minus x will be something like this. ये इंक्रीजिंग फंक्शन है. ठीक है, खाली ये नीचे फ्लिप हो जाएगा ना, ट्रांसफॉर्मेशन लग रहा है, इसी पे ट्रांसफॉर्मेशन लगेगा. इन दिस ग्राफ वी आर यूजिंग ट्रांसफॉर्मेशन, सो दिस ग्राफ विल कम डाउन and gx will be minus of e raised to the power of minus x, right? So this simply flips above the x-axis. You can see here, इसको fx मान लो, ये f है, ये g मान लो. ठीक है, ये उल्टा दे के रखा है, this will be f and this will be g. So you take this as f and take this as g. You can see here that fx is what, less than gx. Fx is less than gx. But if you find out f dash of x, what will you get from here is ये हो जाएगा e raised to the power of minus x. f dash of x is what, minus e raised to the power of minus x का माइनस, फिर माइनस माइनस प्लस हो रहा है, तो e raised to the power of minus x हो जाएगा. एंड g dash of x is what, g dash of x is minus of e raised to the power of minus x. ठीक है, माइनस ऑफ e raised to the power of minus x. तो ये तो फेल हो गया, यहीं पे फेल हो रहा है, यहीं पे फेल हो गया. क्यों? बिकॉज e raised to the power of minus x, मतलब ये तो gx आ गया, यही तो gx है. एंड माइनस ऑफ e raised to the power of minus x माने ये तो fx आ गया. ठीक है, और हमें तो मालूम है कि fx इज लेस देन gx. fx इज लेस देन gx मतलब क्या हो जाएगा, g dash of x इज व्हाट, लेस देन f dash of x, है ना, यही पे फेल हो रहा है. सो f dash of x इज नॉट लेस देन g dash of x. तो इन जनरल ये भी ट्रू नहीं होगा. ठीक है, ये भी ट्रू नहीं होगा. सो both P1 and P2 are false. Option B must be correct. Okay, next we have this question which says that f such that R2R be a continuous function such that for all x belongs to R and for all t greater than or equal to 0, fx is equal to f of e raised to the power of tx. So some functional equation or functional relation kind of thing is given. So we have to show that f is a constant function. Okay. Okay, just to save some time, I've given the solution here. This one was quite an easy question. You can see here that what I do is I'll simply take this function as e raised to the power of tx as y. So once I take this as y, so x will be e raised to the power of minus t times of y. Okay. So you get x, I mean x in terms of y itself. Explicitly you are getting in terms of y. So once you plug in all these values over here, so this becomes what? This becomes y, f of y, and this one will become f of e raised to the power of minus t times of y. Okay. This is how the function is changing actually. So now if we take t tends to infinity on both the sides, okay, why do we take t tends to infinity? Because we need to take the we need to apply this condition. We need to take the help of this information what they have given actually, that f is a continuous function. We'll take the help of this thing. So for larger values of t, what we do is we take t tends to infinity, which means for larger values of t, taking t tends to infinity on both the sides. Now left hand side is independent of t, so that's straight away f of y only. And right hand side we are having, राइट हैंड साइड में ये थोड़ा ज्यादा लिख के रखा है. बेसिकली आई हैव टेकन सम एज एंड देन आई हैव शोड ओवर हियर. लेकिन लॉजिकली यू कैन टेक दिस लिमिट इनसाइड. कैन वी? डेफिनेटली यस, वी कैन टेक दिस लिमिट इनसाइड. ठीक है, टी टेंड्स टू इन्फिनिटी. नेक्स्ट स्टेप में यू कैन टेक दिस लिमिट इनसाइड दिस फंक्शन. लिमिट टी टेंड्स टू इन्फिनिटी e raised to the power of minus of t times of y. Why can we do this thing? Because f is continuous. You can take inside limit inside the function only if the outermost function is continuous function. Composite function mein you can take limits inside only if the outermost function is continuous. So one extra step I've taken over here ki suppose if what if this is h, ये अगर h हो जाए तो h is e raised to the power of minus t h. As h tends to 0, t also tends to h tends to 0 if t tends to infinity over here. ठीक है, तो h वगैरह लेके यहाँ पे देख के रखा है. तो इतना सब कुछ करना नहीं है, डायरेक्टली यही से देख पा रहे हो. यू कैन सिंपली टेक द लिमिट्स इनसाइड. इफ यू टेक द लिमिट्स इनसाइड दिस विल बिकम दिस टेंड्स टू 0. ये लिख के रखना, दिस वी कैन टेक दिस इनसाइड ओनली इफ f इज अ कंटिन्यूअस. ठीक है, वरना नहीं होगा भाई. वी कैन नॉट जस्ट सिंपली रैंडमली टेक इट इनसाइड. लिमिट्स कैन बी टेकन इनसाइड ओनली इफ द आउटर मोस्ट फंक्शन इज कंटिन्यूअस फंक्शन. ठीक है. तो आप में से बहुत लोगों ने ये भी क्वेश्चन किया है, एक टाइम पे किसी ने ये भी क्वेश्चन किया था कि सपोज सर इन विच केसेस वी कैन टेक लिमिट्स इनसाइड दिस इंटीग्रल. मतलब ये सपोज कल को कुछ ऐसा वगैरह दिया हो, ठीक है, तो लिमिट n टेंड्स टू इन्फिनिटी ऐसा वगैरह कुछ दिया हो, तो इन विच केसेस वी कैन डू दिस एक्चुअली. ठीक है, देखो ये हमेशा ट्रू नहीं होता है. दिस इज यू कैन नॉट जस्ट सिंपली रैंडमली टेक दिस इनसाइड. This is true only in some specific cases. When, अब देखो शॉर्ट में बोले तो you can do this in case if the innermost sequence function is basically uniform convergent. अगर ये uniform convergent होता है, in only in that case you can take this limit inside this integral. वरना हमेशा नहीं जाएगा. ठीक है, तो uniform convergent देख लेना, पढ़ लेना if you want to. ठीक है, तो ये सीक्वेंस फंक्शन को यूनिफॉर्म कन्वर्जेंट होना है. एनीवेज, कमिंग बैक टू दिस क्वेश्चन, there is also something called Lebesgue dominated convergence theorem. Using that also we can do this thing, but वो syllabus में है नहीं, वो काफी advanced चीजें हैं. So those things are taught under in degree level classes. Anyways, coming back to this, if you take this limit inside, now here we are taking limit inside the function. Composite function में limit is you can take inside only if the outermost function is continuous. So once you take this limit inside, this will become what? This will tend to 0. This will tend to 0 as t tends to infinity. T e raised to the power of minus t will tend to 0. तो 0 into y will become 0 only. मतलब क्या हो जाएगा? f of y will be 0. f of y will be 0. ठीक है, तो f of y 0 आपने प्रूफ किया लिए. f of y is 0 for all y, which means what? f is a constant function. f of 0 तो constant ही है, तो constant function है. ठीक है, so this way we are proving. Next we move on to 2017 PYQs. Here we have the first question which says that let f such that R2R be a continuous function such that for any two real numbers x and y, we have this condition given, then which of the following options are correct? Now this is a very common format given, fx minus fy is less than or equal to mod of x minus mod of y. ये जो format होता है इस पे बहुत सारे questions. I mean I can say that there are infinitely many questions which can be generated from this particular format. It's a very well known format and you are दोज हु आर प्रिपेयरिंग फॉर जेई ऑल्सो नोज दिस थिंग। ठीक है, ये तो जेई में भी काफी बार दे चुके हैं। ठीक है, तो व्हाट इज द लॉजिक? बेसिकली लॉजिक इज कि mod of fx minus mod of fy is given, and right hand side we are having mod of f x minus y, so in that case you divide by mod of x minus y on both the sides। ठीक है, एक लेके यहाँ पे ले आओ, एक लेके यहाँ पे ले आओ, लेफ्ट हैंड साइड में ले आओ, एंड राइट हैंड साइड बिकम्स 7 टाइम्स ऑफ mod of x minus y raised to the power of 200। and then next what you do, you simply take limits on both the sides, that's all। simply take limits on both the sides। अब लिमिट किस पे, लिमिट किस पे लेना है? लिमिट y टेंडिंग टू x ले लो कि x टेंडिंग टू y ले लो, कुछ भी चलेगा। लिमिट y टेंडिंग टू x ले लो कि x टेंडिंग टू y ले लो। नॉर्मली क्या होता है ना, ये भी एक कंफ्यूजन होता है स्टूडेंट्स को। दिस इज ऑल्सो अ बिग पॉइंट ऑफ कंफ्यूजन विच मोस्ट ऑफ यू फेस, दैट whenever limit, suppose if limit whenever we are writing the definition of differentiability, है ना, f dash of 0 प्लस बोलते हो, है ना, या फिर 0 बोलते हो, तो what is it? लिमिट h टेंड्स टू 0, राइट, f of h माइनस ऑफ f of 0, ठीक है, डिवाइडेड बाई h माइनस 0। तो वो जो भी कांस्टेंट होता है ना, यू विल राइट दिस ओवर हियर, f of a डिवाइडेड बाई h माइनस ए, ऐसे लिखते हो ना, समझ पा रहे हो ना? तो वो कांस्टेंट यहाँ पे होता है, कांस्टेंट f डैश ऑफ a, तो वो कांस्टेंट यहाँ पे होता है, सोच लो। ठीक है, तो कांस्टेंट यहाँ पे होता है। तो अगर सपोज मान लो यू आर टेकिंग x टेंडिंग टू y, x इज गोइंग टू y, है ना, इफ यू आर टेकिंग दिस थिंग, सपोज x इज गोइंग टू y, देन व्हाट इज द मीनिंग ऑफ दिस थिंग? दिस मीन्स कि ये आज के दिन ये कांस्टेंट है, सोच लो भाई, ये कांस्टेंट है। ठीक है, ये कांस्टेंट नहीं है, मतलब बेसिकली दिस विल बिहेव एज द कांस्टेंट, मींस ये था f डैश ऑफ a, माने जो यहाँ पे यू आर राइटिंग द सेम थिंग हियर, f डैश ऑफ a, सो दिस विल बिकम f डैश ऑफ y। समझ पा रहे हो? दिस विल बिकम f डैश ऑफ y इफ यू आर टेकिंग एक्सटेंडिंग टू y, लिमिट एक्सटेंडिंग टू y, दिस विल बिकम f डैश ऑफ y, mod of f डैश ऑफ y। चलेगा, दिस विल बिकम mod of f डैश ऑफ y। this you can take this inside, limits can be taken inside, so this will become mod of f dash of y। ठीक है, and right hand side we will be getting as x tends to y, this will become 0, and mod of f dash of y cannot be less than 0, so now mod of this quantity cannot be less than 0, so which means mod of f dash of y will be equal to 0। ठीक है, which means mod of f dash of y will be equal to 0, which means f of y will be equal to c। If you integrate both the sides, f of y will be equal to c, a constant function। So for any output, any input, output will be always a constant function, right? तो कुछ भी डाल दो भाई, f of यहाँ पे if you carefully see the options, they haven't given anything else। if you see the options, f of 101, f of 101 बोलो कि f of 202 बोलो, all these will be the same। ठीक है, 201, 101, 201, ये सब के सब c देगा। ठीक है, तो डेफिनेटली ऑप्शन डी मस्ट बी करेक्ट, बिकॉज देखो 101 इज बेसिकली एफ ऑफ 201, दीज टू मस्ट बी द सेम। हर एक में +8 +1 +2 सम कॉन्स्टेंट्स दे आर एडिंग। ठीक है, इफ यू आर एडिंग कॉन्स्टेंट्स आउटसाइड, द फंक्शन विल चेंज, सेम तो देगा नहीं, तो ऑप्शन डी मस्ट बी करेक्ट। ओके, वी हैव दिस नेक्स्ट क्वेश्चन विच सेज दैट consider the function f such that R2 R be defined as follows: fx is x minus 1 minimum of x comma x square when x is positive, and x into minimum of x comma 1 by x when x is negative। So we need to comment on the differentiability of this function। ठीक है, हर एक में देखो differentiability they have said, differentiable। तो let us define this function। तो देखो भाई, minimum of x and x square has been given, तो minimum of x and x square ड्रॉ कर लेते हैं। तो y is equal to x will be something like this। ठीक है, किसमें बोला है, x इज पॉजिटिव है ना, सो व्हेन x इज पॉजिटिव देन मिनिमम ऑफ x कॉमा x स्क्वायर वाला ब्रांच लेंगे। ठीक है, एंड y इज इक्वल टू x स्क्वायर विल बी समथिंग लाइक दिस, दिस इज y इज इक्वल टू x स्क्वायर, एंड दिस इज y इज इक्वल टू x। ठीक है, एंड दिस इज द कॉमन पॉइंट ऑफ इंटरसेक्शन 1, ये तो 1 है। ठीक है ना भाई? अच्छा, सो इन दिस केस अब देखो, मिनिमम ऑफ x कॉमा x स्क्वायर, तो इन फ्रॉम 0 टू 1 में, 0 टू 1 में दिस इज द मिनिमम, 0 टू 1 में दिस इज द मिनिमम, एंड मोर देन 1 में दिस इज द मिनिमम, दिस इज द मिनिमम, है ना? तो इफ आई डिफाइन द फंक्शन, इफ आई डिफाइन द फंक्शन दिस मच पोर्शन, ठीक है, ये जो पार्ट है फ्रॉम 0 टू 1, 0 और 1 के बीच में, व्हेन x इज लाइंग इन बिटवीन 0 एंड 1, तो y इज इक्वल टू x स्क्वायर इज द मिनिमम। तो x स्क्वायर मिनिमम है, तो नीचे वाला पार्ट मिनिमम है ना, द लोअर वन इज द मिनिमम वन। तो ये लोअर वन अगर मिनिमम है तो दिस विल बिकम एक्स स्क्वायर, दिस विल बिकम एक्स स्क्वायर, राइट? ये एक्स स्क्वायर है ना, तो दिस विल बिकम एक्स स्क्वायर, तो एक्स माइनस वन इंटू एक्स स्क्वायर। अच्छा, व्हेन it is more than 1, when this is more than 1, when x is more than 1, when x is more than 1, this is, this branch is considered, which is y is equal to f, this will be x only, so minimum of x and x square will be x, so x into x minus 1 हो जाएगा तब, ठीक है? Now we come down to this branch, when x is less than 0, when this side, when x is less than 0, minimum of x and 1 by x is considered, so x will be like this and 1 by x will be something like this, the rectangular hyperbola, है ना? Hopefully you people know the graphs. Graph sketch I'm drawing over here. Free hand diagram में काम चला लो, ठीक है? ये भी जीरो है. This is their point of intersection. ठीक है? तो ये कौन सा पॉइंट है भाई? ये -1 होगा. This point is what? -1. ठीक है? अच्छा, तो this is y is equal to x and this is y is equal to 1 upon x. For x less than 0 they have said. अच्छा, तो यहाँ पे देख पा रहे हो कि फ्रॉम 0 to -1, 0 to -1 में दिस पार्ट इज मिनिमम, राइट? चलेगा? और -1 से लेके माइनस इंफिनिटी में दिस पार्ट इज मिनिमम, दिस पार्ट इज मिनिमम. तो 0 और -1 में इफ आई डिफाइन द फंक्शन फ्रॉम -1 to 0, फ्रॉम -1 to 0, दिस इज, दिस पार्ट इज मिनिमम. तो व्हाट, विच पार्ट इज दिस थिंग? 1/x, ये 1/x वाला ग्राफ इज मिनिमम. तो x इंटू 1/x माने 1 हो जाएगा, दिस विल बिकम 1, ठीक है? एंड व्हेन x इज लेस देन -1, व्हेन x इज लेस देन -1, this part is minimum, माने y is equal to x is minimum. तो y is equal to x is minimum माने this minimum of this will be x. So x into x will become x square. So this is our function. ठीक है? So next we can check the differentiability at all these points. ठीक है? कौन से points है देखो. What are the points there? ठीक है? What are the points? Points are 0. Concerned points are 0, -1, 0 and 1. यही points है. -1, 0 and 1. तो एक बार लिमिट्स देख लेते हैं, हल्का सा लिमिट देख लेते हैं, है ना? लिमिट्स देख लेते हैं. अगर जीरो पे लिमिट्स देखोगे ना, देखो जीरो पे, एट 0 प्लस, 0 प्लस माने दिस ब्रांच, 0 प्लस पे दिस विल बिकम 0 इंटू 0 -1 माने 0 ओनली, ठीक है? तो 0 प्लस पे लिमिटिंग वैल्यू इज 0 और 0 माइनस पे लिमिटिंग वैल्यू इज 1, 0 माइनस पे लिमिटिंग वैल्यू इज 1, ठीक है? तो क्लियरली दिस इज नॉट कंटिन्यूअस एट 0. 0 पे तो कंटिन्यूअस ही नहीं है, तो 0 पे, 0 इज अ पॉइंट ऑफ नॉन डिफरेंशिएबिलिटी, 0 पे डिफरेंशिएबल भी नहीं होगा, ठीक है? तो ऑप्शन ए तो वैसे ही रॉन्ग हो गया कि इट इज नॉट डिफरेंशिएबल एवरीवेयर. 0 पे डिसकंटिन्यूअस हो रहा है, डिसकंटिन्यूअस मींस दिस विल बी नॉट डिफरेंशिएबल. अच्छा, 1 पे चेक कर लो. 1 पे, 1 पे आई थिंक 1 पे कंटिन्यूअस होगा. 1 पे व्हेन x इज मोर देन 1, 1 पे दिस विल बी व्हाट 0, एंड व्हेन x इज लेस देन 1, लेस देन 1 माने दिस ब्रांच विल कंसीडर, यहां पर भी 0. 1 पे कंटिन्यूअस तो हो रहा है, व्हिच मींस वी हैव टू चेक द डिफरेंशिएबिलिटी एट 1. तो उसके लिए क्या करो, आई हैव सेड दिस थिंग, यू कैन यूज द शॉर्टकट trick, which is you can differentiate this thing branch wise if piecewise function is given. So once you differentiate this thing, this will become what? This will become 2x minus 1 when x is more than 1, and this is 3x square minus 2x when x is lying in between 0 and 1. This will be 0 when x is lying in between -1 and 0, and 2x when x is less than -1. तो क्या हो जाएगा? दिस विल बिकम, नाउ लुक एट दिस थिंग, फॉर 1 प्लस, देखो 1 प्लस में दिस विल बिकम व्हाट? 1 प्लस माने ये वाला ब्रांच लेंगे. 1 प्लस में विल टेक दिस ब्रांच, सो f dash of 1 plus will be, f dash of 1 plus will be 2 into 1 minus 1 माने 1, and f dash of 1 minus will be, will take this branch माने 3 into 1 minus of 2 into 1 माने 3 minus 2 माने 1, माने 1 पे डिफरेंशिएबल है. 1 is a point of differentiability. अच्छा, फिर -1 पे देख लो. -1 पे व्हेन x इज लेस देन -1 विल टेक दिस ब्रांच, तो क्या हो जाएगा? -2, है ना? यू कैन वर्बली सॉल्व, When x is less than -1, this will become what? -2. ये वाला ब्रांच लेके ना मैंने -2 बनेगा, 2 into -1 मैंने -2. And when x is more than -1, we'll take this branch, है ना? When x is more than -1, we'll take this branch, which is 0. तो एक में -2 है, दूसरे में 0 है, मैंने नॉट डिफरेंशिएबल. So -1 is a point of not differentiability. ठीक है, so not differentiable at exactly 2 points. Option C is correct. Okay, so here we have another question which says that fx is x upon e raised to the power of x minus 1 when x is not 0 and 1 when x is equal to 0 function is given. So we have to comment on the continuity and differentiability. ठीक है, वही देखना है बस, कंटिन्यूटी एंड डिफरेंशिएबिलिटी. वेरी सिंपल क्वेश्चन इज गिवन. तो फंक्शन तो कंटिन्यूअस वैसे ही दिख रहा है, कंटिन्यूअस है, स्टैंडर्ड फंक्शन है ना? कि लिमिट एक्सटेंडिंग टू जीरो करोगे, लिमिट एक्सटेंडिंग टू जीरो एक्स अपॉन ई रेज़ टू द पावर ऑफ एक्स माइनस 1, तो क्या होता है? 1 ही तो होगा. ये डिवाइड बाई एक्स क्या हो जाएगा? दिस विल बिकम 1 एंड डिवाइड बाई एक्स ओवर हियर. तो ये 1/1 है तो स्टैंडर्ड फॉर्म है, तो 1/1 माने 1 ओनली. स्टैंडर्ड फॉर्म ऑफ लिमिट ई रेज़ टू द पावर ऑफ एक्स माइनस 1 डिवाइडेड बाई एक्स. और फंक्शन वैल्यू एट जीरो विच इज द सेम एज एफ ऑफ जीरो. ठीक है, मतलब कंटिन्यूअस तो है, तो नॉट कंटिन्यूअस इज रॉन्ग, कंटिन्यूअस फंक्शन है. ठीक है, अब डिफरेंशिएबिलिटी, फॉर डिफरेंशिएबिलिटी क्या करो? डेफिनेशन यूज कर लो. ठीक है, डेफिनेशन यूज कर लो यहाँ से. सो इफ यू फाइंड आउट एफ डैश ऑफ जीरो, देखो मैंने यहाँ पे दे के रखा है. सो एफ डैश ऑफ जीरो इज फॉर लिमिट एच टेंस टू जीरो एफ एच माइनस एफ जीरो डिवाइडेड बाई एच माइनस जीरो. डेफिनेशन यूज करो. तो बस वैल्यूज डालो यहाँ पे, वैल्यू डालो और सिंप्लीफाई करो. इफ यू सिंप्लीफाई फ्रॉम हियर, इफ यू टेक दिस एलसीएम, सो दिस बिकम्स एच minus e raised to the power of h plus 1 divided by h into e raised to the power of h plus 1 minus 1. अब देखो ये तो फॉर्म है, ये फॉर्म के लिए यू कैन सिंपली डिवाइड बाई एच एंड मल्टीप्लाई बाई एच ओवर हियर सो दैट दिस विल बिकम 1. तो फाइनल में क्या बचेगा? h माइनस ई रेज टू द पावर ऑफ h प्लस 1 डिवाइडेड बाई एच स्क्वायर. दैट्स व्हाट इज गिवन, है ना? चलेगा. अब क्या करो? लॉपिताल्स रूल यूज कर लो. यू कैन यूज लॉपिताल्स रूल, यू कैन यूज एक्सपेंशंस, व्हाटएवर यू वांट टू यूज. तो लॉपिताल्स रूल सिंपल रहेगा, तो 1 माइनस ई रेज टू द पावर ऑफ एच, क्योंकि फॉर्म तो है ना, वो फॉर्म तो ये 0/0 फॉर्म. आफ्टर प्लग इन द लिमिट फॉर्म इज स्टिल देयर. तो 1 माइनस ई रेज टू द पावर ऑफ एच डिवाइडेड बाई 2h. फिर से यूज करो, तो 1 माइनस ई एच माने माइनस ऑफ ई रेज टू द पावर ऑफ एच डिवाइडेड बाई 2. ठीक है, नाउ द फॉर्म इज गॉन, प्लग इन द लिमिट्स. सो ई रेज टू द पावर ऑफ जीरो माने 1 हो जाएगा, माने माइनस हाफ हो जाएगा. सो एफ डैश ऑफ जीरो विल एग्जिस्ट, इट इज डिफरेंशिएबल एंड एफ डैश ऑफ जीरो विल बी माइनस हाफ. ऑप्शन सी इज करेक्ट. Okay, so here we have the last question from 2017's UGB paper. So fx is given. Fx is function given, which is defined from R to R. We have to find f dash of 1. And then thereafter, we have to evaluate this limit. Okay. So whenever you will understand that whenever two parts are given in a specific question, whenever two parts are given, definitely the second part is connected with the first one. नहीं तो वो देते नहीं. The second part is not something, I mean, you will just randomly solve. ठीक है, तो सेकेंड पार्ट इज डेफिनेटली कनेक्टेड विद द क्वेश्चन मतलब फर्स्ट पार्ट से. ठीक है, तो चलो लेट्स फाइंड आउट व्हाट इज एफ डैश ऑफ 1. वेरी सिंपल है. सो आई हैव गिवन द सॉल्यूशन ओवर हियर जस्ट टू सेव सम टाइम. So f dash of we just simply find the right hand derivative and the left hand derivative. I have found both of them. You can see here right hand derivative and the left hand derivative. देखो right hand derivative at x is equal to 1 which is limit h tends to 0. ये तो होता है ना, लिमिट h टेंस टू 0 क्या होता है? f ऑफ a प्लस h माने 1 प्लस h माइनस ऑफ f ऑफ 1 डिवाइडेड बाई क्या? h. ये क्या होता है? दिस इज बेसिकली f डैश ऑफ 1 प्लस दिस इज बेसिकली योर राइट हैंड डेरिवेटिव. इसका डेफिनेशन यूज किया है, बस वैल्यूज डालो यहाँ पे, सॉल्व करो. सो वंस यू प्लग इन द वैल्यूज ओवर हियर, सो दिस इज द फंक्शन ई रेज टू द पावर ऑफ 1 प्लस h होल टू द पावर ऑफ 10 माइनस 1 प्लस h स्क्वायर. ठीक है ना, ये बन जाएगा h स्क्वायर इंटू साइन ऑफ 1 बाई h. सिंपल है. ठीक है ना, खाली इन द प्लेस ऑफ, अरे भाई इन द प्लेस ऑफ x वी आर रिप्लेसिंग बाई 1 प्लस h, बस और कुछ नहीं किया है. तो 1 1 कैंसिल जाओ तो ये चीज बचेगा. तो फिर क्या करोगे? देन वी आर ट्राइंग टू ब्रिंग इन टू सम फॉर्म. तो क्या करो? कंबाइन दिस टर्म एंड दिस टर्म. ठीक है, दिस माइनस 1 याद है ना, ई रेज टू द पावर ऑफ x माइनस जस्ट नाउ वी हैव डन माइनस 1 डिवाइडेड बाई x वाला फॉर्म. देखो एज h टेंस टू 0 दिस विल टेंड टू 0, 1 प्लस h टू द पावर ऑफ 10 माइनस 1 विल टेंड टू 0. ठीक है, तो वो कर लो, माइनस 1 डिवाइडेड बाई 1 प्लस h होल टू द पावर ऑफ 10 माइनस 1. ठीक है, लेकिन ये टर्म तो था नहीं, सो वी आर फोर्सफुली ट्राइंग टू ब्रिंग दिस थिंग. सो 1 प्लस h टू द पावर ऑफ 10 माइनस 1 डिवाइडेड बाई h. ये और ये सो दैट कैंसिल आउट हो रहा है, मीन्स बेसिकली वी आर फोर्सफुली ब्रिंगिंग दिस टर्म्स so that this term will tend to 1. और बचेगा खाली ये टर्म, और बाकी लिमिट्स भी सेपरेट कर दो. दिस लिमिट इज व्हाट, वंस यू डिवाइड दिस थिंग h and this h will cancel out. तो व्हाट इज रिमेनिंग, h into sin 1/h. तो h into sin 1/h माने वही फिर 0 into some oscillating function will be 0 only, इसीलिए 0 डाला है. तो बचेगा खाली यही वाला लिमिट. So once you solve this thing, what is this? Limit h tends to 0, 1 plus h to the power of 10 minus 1 divided by h. And once you plug in the limits, don't plug in the limits, you have to solve this thing. ठीक है, तो ये तो वैसे ही सॉल्व हो जाएगा. सो 1 प्लस एच टू द पावर ऑफ 10, यू कैन यूज बाइनोमियल अप्रोक्सीमेशन 1 प्लस 10h, है ना, 1 प्लस 10h और माइनस ऑफ 1 डिवाइडेड बाई h. 1 कैंसल्स आउट. या तो डिफरेंशिएट करो, नहीं तो यू पीपल कैन यूज दिस बाइनोमियल अप्रोक्सीमेशन. से दिख रहा है 1 cancels out, 10h by h is remaining, h is cancels out, what is remaining, 10. Khatam. And in a similar way, you will find out what is the left hand derivative. So for left hand derivative, I've used the definition f of 1 minus h minus of f of 1 divided by h. ठीक है, f of 1 divided by h. Again you do the same thing. फिर वही चीज लाना है. ठीक है, definition is what? Definition is this, f dash of, hopefully you remember, recall करवा देते. This is f of limit h tends to 0, f of 1 minus h minus of f of 1 divided by minus h. This is the definition for the left hand derivative. तो लेफ्ट हैंड डेरिवेटिव निकालो यहाँ से. इन द प्लेस ऑफ h विल सिंपली रिप्लेस बाय, इन द प्लेस ऑफ x विल रिप्लेस बाय 1 माइनस h. बस उतना ही है. तो 1 माइनस h होल टू द पावर ऑफ 10 माइनस 1 प्लस h स्क्वायर इंटू साइन ऑफ माइनस 1 बाई h माइनस 1 अपॉन h. ठीक है, फिर से वही सेम लॉजिक, 1 प्लस h होल टू द पावर ऑफ, ये चीज था नहीं तो 1 माइनस h माइनस होगा, प्रिंटिंग मिस्टेक. तो 1 माइनस h होगा. तो 1 माइनस h होल टू द पावर ऑफ 10 फोर्सफुली लाओ यहाँ पे. ठीक है, combine this term just like the previous one, combine this term and this term, and then you forcefully bring this term over here just to bring into the format. अब ये देखो, this will become 1, this will become 1 as h tends to 0, this will become 1, this will be a limit, and the remaining part is just an oscillating function, है ना. साइन ऑफ माइनस 1 बाई एच बोलो तो माइनस विल सिंपली कम आउट, ये भी कर सकते हो, तो माइनस ऑफ 0 कर लो. एंड वंस यू डिवाइड दिस थिंग, दिस विल बिकम ऑक्सीलेटिंग फंक्शन, तो वो 0 ही है. तो ओनली दिस पार्ट विल बी रिमेनिंग. फिर से वही सेम लॉजिक, 1 माइनस एच होल टू द पावर ऑफ 10 है, तो 1 माइनस 10h कर लो बाय बाइनोमियल अप्रोक्सीमेशन. 1 माइनस 10h माइनस ऑफ 1 डिवाइडेड बाई माइनस एच. तो 1 कैंसल आउट, माइनस माइनस विल कैंसल ओवर हियर, एच विल कैंसल, फिर से 10 ही बचेगा. तो लेफ्ट हैंड डेरिवेटिव एंड राइट हैंड डेरिवेटिव आर इक्वल, सो एफ डैश ऑफ 1 विल बी इक्वल टू 10 अगेन. सो एफ डैश ऑफ 1 प्लस भी 10 है, 1 माइनस भी 10 है, तो एफ डैश ऑफ 1 भी 10 होगा. बस इतना ही है बेसिक डेफिनेशन से. Second part of the problem says find what is limit u tends to infinity 100u minus u into summation this. तो उसके लिए क्या करो, what I have done is first I have taken out this summation. So when this summation completely comes outside, this becomes summation k is equal to 1 to 100 u into 1. अब ये u into 1 कहाँ से आया, ये 100u को कैसे लिख दिया इसको. 100u बेसिकली, ये जो 100u है ना, this 100u is basically summation of, इसको ध्यान से देखो, this is the nothing but summation k is equal to 1 to 100. ये u है. summation is dependent on k and not u, तो u is a constant with respect to this summation, है ना. तो ये u बाहर करके ऐसे लिख सकते हो, summation of k is equal to 1 to 100. तो this is basically k raised to the power of, or rather basically you can write this 1 raised to the power of k, ऐसे लिख सकते हो. ठीक है, 1 raised to the power of k लिख सकते हो, ऐसे लिख सकते हो. ये चीज है यहाँ पे 1 raised to the power of k. So what is this? Basically 1 raised to the power of 1 plus 1 raised to the power of 2 plus 1 raised to the power of 3 and so on till 1 raised to the power of 100, which is 1 only. तो u into 1 है ना, u into 1 plus 1 plus 1 plus 1 माने 100 टाइम्स, 100 टाइम्स 1, तो क्या हो जाएगा, 100u हो जाएगा ना. तो बस वही है, उल्टा लिखा है बस. 100u को आई एम राइटिंग दिस, 100u को आई एम राइटिंग दिस एंड देन आई एम टेकिंग समेशन कॉमन. तो समेशन k इज इक्वल टू 1 टू 100 u इंटू 1 माइनस एफ ऑफ 1 प्लस के यू. क्या बेनिफिट होगा, दिस विल कम इनटू सम डिफरेंशिएशन फॉर्मेट. ध्यान से देखो, तो समेशन k इज इक्वल टू 1 टू 100 लिमिट u टेंड्स टू इन्फिनिटी u इंटू 1 माइनस एफ यू, ये बन जाएगा. यू कैन टेक दिस समेशन इन लिमिट्स इनसाइड, समेशन इज डिपेंडेंट ऑन k नॉट u, तो u कैन बी टेकन इनसाइड. ठीक है, ये कर सकते हो, समेशन इज डिपेंडेंट ऑन के, यू तो है नहीं. ठीक है, तो ये अगर इनसाइड ले जाओगे तो ये चीज बचेगा. अब ध्यान से देखो, व्हाट आर वी ट्राइंग टू डू ओवर हियर. तो लिमिट यू टेंड्स टू इन्फिनिटी, वी आर गेटिंग दिस. अब ध्यान से देखो, 1 माइनस एफ ऑफ 1 प्लस के बाई यू, We are forcefully bringing k by u down over here because as u tends to infinity, k by u will tend to 0. देखो k by u को h ले लिया तो h is tending to 0. क्यों किया इसको? Why we are changing the limit? क्योंकि as h tends to 0, this will become f of 1 plus h. समझ पा रहे हो ना? k फोर्सफुली यहाँ पे लेके k by u कर लिया यहाँ पे, तो f of 1 plus h divided by h, और ये जो 1 है, 1 is nothing but given in the question which is f of 1, तो I'm writing this as f of 1. ठीक है, तो लिमिट h टेंस टू 0, f of 1 माइनस f of 1 प्लस h, तो ये देखो डिफरेंशिएशन फॉर्मेट आ गया ना. व्हाट इज दिस? माइनस ऑफ f डैश ऑफ 1. माइनस कॉमन ले लो, पूरा डिफरेंशिएशन फॉर्मेट है, तो k इंटू माइनस ऑफ f डैश ऑफ 1. ठीक है, तो ये पार्ट तो खाली कांस्टेंट है, सो यू कैन सिंपली टेक दिस आउटसाइड. सो माइनस ऑफ f डैश ऑफ 1 इंटू समेशन k बचेगा बस. समेशन k इज गोइंग फ्रॉम 1 टू 100, मैंने सम ऑफ द फर्स्ट 100 नेचुरल नंबर्स, क्या होगा 100 इंटू 101 डिवाइडेड बाई 2. और ये तो याद होना चाहिए, दिस इज बेसिकली 5050, ये होता है ना 5050 5050 और फिर इंटू माइनस f डैश ऑफ 1. f डैश ऑफ 1 याद है प्रीवियस क्वेश्चन से, f आई मीन प्रीवियस पार्ट से, व्हाट इज f डैश 1? 10, तो इंटू 10. ठीक है, सामने माइनस भी है, तो क्या हो जाएगा? दिस विल बिकम माइनस ऑफ 50500. सो दिस इज योर आंसर. ठीक है, तो द ओनली थिंग फॉर दिस क्वेश्चन वॉज, ये केयरफुली ये जो 100u है, ये 100u को समहाउ वी हैव टू टेक दिस आउटसाइड, फिर क्वेश्चन क्लियरली हो जाएगा, फिर फ्लो में आ जाएगा क्वेश्चन पूरा. सो ओनली थिंग वाज टू टेक दिस 100u आउटसाइड एंड देन सॉल्व इट. ठीक है, okay, next we move on to 2016 PYQs. Here we have the first question which says that let fx be max of cos x comma x square, x lies in between 0 and pi by 2. If x naught is the solution of this equation cos x is equal to x square in the 0 to pi by 2, then we have to comment on the continuity and differentiability of f at x naught. Okay, so x naught is what? Is the point of intersection of these two graphs. Cos x is equal to x square, cos x and x square. Okay, because this equation is not solvable and we need to find out x naught. Right, so x naught is basically the point of intersection of the graph of cos x and x square. Why we cannot solve this thing? We can solve this thing. We cannot solve this thing in general, but we can definitely have some sort of numerical solution. But we don't need the solution over here. The solution is given to be x naught. So what I do, I consider the graph of y is equal to cos x. Likewise, I have considered here y is equal to cos x and y is equal to x square in this interval 0 to pi by 2. This is 0 and this is pi by 2, let's say. So from 0 to pi by 2, I'm considering the graph of both of these functions. Okay, so that we can clearly plot this max of cos x comma x square. So x naught is what? The solution between these two graphs, their solution. So this is somewhere over here. This is basically your x naught. Okay, again I'm saying this equation is not solvable in general. You can have some sort of numerical solution. So you don't have this in syllabus right now, so but still you can, if you know numerical analysis or something, then definitely you can think of solving this thing by some different method. Right now you don't need the solution. Okay, so if we try to draw the graph of y is equal to max of cos x comma x square, so from 0 to x naught, this is your max function. Cos x will be maximum, this will be your max function, and from x naught to pi by 2, this is your maximum function because this graph lies above. है ना? ये जान लो, whenever max function is given, in that case you have to use the graph. Whenever max function is given, max or min function is given, तो graph तो use करना ही है. So from 0 to x naught, we have cos x to be maximum, and from x naught to pi by 2, x square is maximum. Okay, so your graph is something like this. This is your graph. ये ऐसे जा रहा है graph. ठीक है. Now the question is, ये जो point है, this point is x naught. Question is whether function is continuous or differentiable at x naught or not. So clearly the function is continuous at x naught. Break point तो है नहीं. Function is clearly continuous at x naught. F पे बारे में बोलना है ना, F के बारे में. We need to comment on F. Function is clearly continuous at f naught. So graph is not having a breakpoint. मतलब क्या है? Continuous है. Simple definition. And function is not differentiable. क्यों? Because here we are having a sharp corner. तो turn ऐसा हो रहा है ना. Turn is something like this. So definitely this is a sharp point. Sharp corner. Sharp corner पे function is not differentiable. So this is function is differentiable everywhere except at x naught, which means option D is correct. Okay, next we have this question which says that let alpha greater than 0 and beta also greater than or equal to 0, and f is a continuous function at 0, with f of 0 is beta. Now f is a continuous function at 0, which means f of 0 is beta. So as you can decode these things as well, like f of 0 plus, 0 minus, all these are beta और f of 0 है ना. तो देखना है कि क्या क्या जनरेट किया जा सकता है, व्हाट वी कैन जनरेट लाइन बाय लाइन. सो इफ g of x is mod x to the power of alpha into fx is differentiable at 0, then which of the following options are correct? So we need to find the value of alpha and beta for which this is differentiable at 0. gx is differentiable. ठीक है ना. So these things can be generated. Apart from this thing, अभी differentiability पे comment करना है, तो we can start with the definition g dash of x 0 plus g dash of 0 plus, what is this? Limit h tends to 0, g of 0 plus h minus g of 0 divided by h. तो g of 0 plus h क्या होगा? g of 0 plus h will be h to the power of alpha, है ना. यहाँ पे 0 plus h माने h only. So h to the power of alpha mod of h to the power of alpha. अभी देखो 0 plus है माने we'll take the positive side of the mod, है ना. mod है ना, तो we'll take the positive side of the mod. तो this will become h to the power of alpha, क्योंकि हमने 0 plus लिया. ध्यान रखो, हमने 0 plus लिया है, तो this will be positive side of mod x. So h to the power of alpha into fx, f of h, है ना. f of 0 plus h लिख लेते हैं. 0 plus h, 0 plus h भी लिख सकते हो, h भी लिख सकते हो, सेम चीज है. माइनस ऑफ g of 0. So minus of g of 0 means 0. g of 0 क्या होगा? 0 ही only. तो this will be 0 and divided by h. ये चीज बनेगा. तो this will get simplified to limit h tends to 0, h raised to the power of alpha minus 1 into f of 0 plus h. This will get simplified into this form. Okay. Now f of 0 plus h माने f of 0 plus, है ना. ये 0 plus है, f of 0 plus है, f of 0 plus, और ये तो बीटा ही है. This is beta only because f is continuous. f of 0 plus h बोलो कि f of 0 plus बोलो, है ना, slightly more than h, मतलब वो तो बीटा ही है. तो this part is beta only. So once you distribute the limits, तो ये जो part है limit h tends to 0, this part will be beta, h to the power of alpha into beta, ये बनेगा. अब बोला है कि फंक्शन इज डिफरेंशिएबल. फंक्शन gx है, gx डिफरेंशिएबल है फॉर व्हाट कंडीशंस ऑफ अल्फा एंड बीटा. तो अल्फा एंड बीटा खुद सोचो, दिस विल बी आई मीन दिस लिमिट विल बी अ फाइनाइट वैल्यू, दिस विल बी अ फाइनाइट वैल्यू, this will be a finite value. So for if this is a finite value, so we'll decide now accordingly which of the values, for what values this limit will obtain a finite value. अब ये तो constant है, this will not matter, तो whatever is dependent on will be dependent on this thing. अब ये अगर फाइनाइट वैल्यू होना है तो अल्फा माइनस 1 डेफिनेटली हैज टू बी पॉजिटिव, क्योंकि अगर नेगेटिव हो जाए तो वो तो 1 बाई समथिंग हो जाएगा. 1 बाई समथिंग टेंड्स टू 0 विल बिकम अनडिफाइंड. तो अल्फा माइनस 1 will definitely has to be, can be 0 as well. This can be 0 or this can be positive, which means alpha must be definitely greater than or equal to 1. And from here only you can say option C is correct, where alpha is greater than or equal to 1. But beta can be 0. ये वाला condition भी देख लो. When beta can be 0, because if alpha is equal to 1, what happens is, if alpha is equal to 1, then beta will only exist. Then limit will be only dependent on beta. ठीक है, बाकी तो सब 0 हो जाएगा, तो सिर्फ बीटा बचेगा, है ना. तो ओनली बीटा विल बी रिमेनिंग इन दैट केस. माने g dash of 0 will be beta, g dash of 0 will be beta, 0 plus will be beta. माने g dash of 0 plus will be beta, and g dash of, similarly, if you find the left hand derivative, g dash of 0 minus will be minus beta. चेक कर लेना. Similarly, once you find out g dash of 0 minus, that will be minus beta. सेम चीज मिलेगा, h raised to the power of alpha minus 1, सामने खाली माइनस आएगा. माइनस क्यों आएगा? बिकॉज इसको माइनस से खोलोगे. फॉर g dash of 0 माइनस, mod will be 1 माइनस, इसको माइनस से खोलोगे तो वहां से माइनस बीटा आएगा. एंड माइनस बीटा, now because this is differentiable, beta will be equal to minus of beta, which means beta plus beta will be 0, which means 2 beta is 0, which means beta will be equal to 0. मतलब हर एक केस में if alpha is greater than or equal to 1 and beta is 0, then only this quantity will be a finite value and both of them will be equal. Left hand derivative and right hand derivative will be equal. इसीलिए beta is equal to 0 होना ही है. So option C must be correct. Okay, next we move on to 2015 PYQs. So here we have the first question, which says that defines signum of x to be this. It's a standard function you people know. Let f such that R to R be the function given by fx is equal to x plus 1 into signum x square minus 1, where R is a set of all real numbers. We have to find the number of discontinuities of f. So first we need to define this function. fx is x plus 1 times of signum of x square minus 1. We'll define this function first. अगर signum x ये होता है तो signum x square minus 1 क्या होगा? Signum x square minus 1. This will be the same thing, 1 minus 1 और 0. खाली ये values change होगा यहाँ पे, ये ध्यान रखना है. Okay, this was x. Signum of x there was 1 when x is more than 0. So now signum of x square minus 1 है. So x square minus 1 will be 1 when x square minus 1 is more than 0. Similarly, this is minus 1 and when x square minus 1 is less than 0. And when this will be 0 when x square minus 1 is equal to 0. So x square minus 1 is equal to 0 means x is plus minus 1. ठीक है. अच्छा, when x square minus 1 is less than 0, तब क्या होगा? x belongs to minus 1 to 1. तो यहां से वेवी का यूज कर लो. x square minus 1 है ना, x square minus 1 ये प्लस माइनस प्लस है. तो कौन सा रीजन चाहिए? वेयर x square minus 1 is नेगेटिव, माने ये रीजन चाहिए. This region what? Which region is this thing? ये minus 1 है, ये plus 1 है. Which region is this? What are the turning points? याद है ना, वेवी कर्व मेथड है, सिंपल. minus 1 है, 1 है, तो बीच में ये रीजन चाहिए where this is negative. So x belongs to where? To where? minus 1 to 1 है ना, minus 1 to 1. And this is x square पॉजिटिव कौन से रीजन पे? This is x belongs to minus infinity to minus 1 closed. Close नहीं, सारे के सारे open होंगे, because here we are having strict inequality. All these are open. All these are open intervals. Strict inequality is there. So this will be minus 1 to 1, and this is minus infinity to minus 1, union 1 to infinity. Okay. Which means if I multiply by x plus 1 over here, so your function, ultimate function fx becomes when x is less than minus 1. Socho, when x is less than minus 1 and when x is greater than 1. In all these cases, this is x plus 1 only. X plus 1 times of 1, माने x plus 1 है ना. And when x is more than 1, in this case also, this will be x plus 1 only. ठीक है, ये वाला रीजन डिफाइन हो गया. अच्छा, when x is lying in between minus 1 to 1, x is lying in between minus 1 to 1, in that case this branch will be minus 1. So x plus 1 times of minus 1 will be minus of x plus 1. ठीक है. And lastly, we are having x is equal to plus minus 1. So when x is equal to plus minus 1, plus 1 bolo ki minus 1 bolo, in that case this is 0. So x plus 1 times of 0 will be 0 only. This is your definition of the function. So now that we have the definition of the function, so we can now comment on the continuity and discontinuity. So what we do, we'll check for the continuity of this function at all these points. Which points? What are the points over here? Minus 1 and 1, where the definition changes. Minus 1 पे change हो रहा है और 1 पे change हो रहा है. So we'll check the continuity at these points. Okay, continuity, and they have asked for the continuity only. So we'll check the continuity at these points. Okay. तो manually check कर लो. Since we have the definition of the function, so you can check this manually. F dash of f of 0 plus minus 1 minus f of minus 1 minus slightly less than minus 1. कौन सा branch होगा? This branch. And now we'll consider this branch. In this case, this is what? minus 1 plus 1. This value will be what? 0. And when x is more than minus 1, minus 1 plus, when x is more than minus 1, this will be what? We'll consider this branch. In this case, this will be what? minus 1 plus 1. फिर से 0, minus of 0 तो 0 ही आएगा. And function value at minus 1 will be, function value at minus 1 क्या होगा? वो भी 0 है. तो which means this is continuous at minus 1. तो minus 1 तो गया. Now we check for f of 1 plus. देखो 1 plus पे we'll consider which branch? 1 plus पे we'll consider the branch which is where x is more than 1, माने this branch. तो 1 plus पे 1 plus 1 2 है. ठीक है. और f of 1 minus पे क्या होगा? f of 1 minus पे slightly less than 1. तो 1 minus पे this branch we'll consider, है ना. तो ये तो minus 2 आ रहा है. चलो यही से फेल हो गया. ठीक है. एंड सिमिलरली फंक्शन वैल्यू भी देख लो. f of 1 is what? f of 1 will be 0. यही पे fail हो रहा है. All of them are unequal. So there is one point of discontinuity which is x is equal to 1. ठीक है? So option B must be correct. Okay, next we have this question which says that let f such that 0 to 2 union 4 to 6 to R be a differentiable function. Suppose also that f dash of x is equal to 1 for all x belongs to 0 to 2 union 4 to 6, means for the domain values of x, which of the following is always true? F is increasing, f is 1 1, fx is equal to x. अच्छा, जो लोग ये नहीं जानते हो कि f is increasing means dy by dx is greater than 0. That means f dash of x is greater than 0. ठीक है, ये condition होता है. Hopefully you people know this thing because this is a very basic concept which is taught under applications of derivatives. So what they have given is f dash of x is equal to 1. So if f dash of x is equal to 1, which means fx is what? A linear function. If we integrate both the sides, this will be what? X plus c. Fx is what? X plus c. This will be a linear function. Now, if you carefully look at the domain is actually, distributed over two intervals. Ye 0 to 2 and then from 4 to 6. We are having the domain. The domain is distributive over two intervals. So what we can say is कि fx तो linear function ही होगा. उसमें कुछ difficulty है नहीं कि fx will be a linear function. ठीक है, there is no question. तो it may be, fx is differently defined, x plus c1 मान लो. fx may be differently defined for the first domain, माने 0 to 2, and it might be differently defined for 4 to 6. मतलब x plus c नहीं, this will be a different linear function from 0 to 2 and a different linear function from 4 to 6. मान लो x plus c2 मान लो. This might be the case. Now we see that what happens if what is the nature of this function f? So therefore, fx is equal to x is never possible. fx is equal to x for all x belongs to this thing because x plus c1 कुछ तो constant आएगा ही. ठीक है, अगर 0 भी मान लो, देखो c1 and c2 are two different things over here. c1 and c2 are not equal. तो अगर c1 0 भी हो जाए तो c2 will be still remaining. This won't be equal to x for all the domain values. Okay, so option C is definitely wrong. F is increasing, not possible because suppose f is 0 to 2 में function is suppose something like this, x plus c1. ठीक है, 0 to 2 में function is something like this, और 0 to 4 to 6 में function is something like this. Some different constants for different c1 and c2, we are getting two different branches of the functions over here, है ना? So every time you will see that the horizontal line test will fail over here. Horizontal line test will fail. किसी एक point पे तो definitely you can definitely construct some specific values of c1 and c2 for which the horizontal line test will fail. ठीक है, मतलब फंक्शन इंक्रीजिंग तो फुल्ली इंक्रीजिंग तो होगा ही नहीं, फंक्शन 1 1 भी नहीं होगा. The horizontal line test will fail over here. Function will be many to one function for some specific values of c1 and c2. So f will be a many to one function, तो 1 1 function होगा नहीं, and f cannot be increasing also. ठीक है, properly this will be an increasing function, उसमें भी कुछ गारंटी है नहीं. ठीक है, so you can choose for some values of c1, this can be decreasing also. ठीक है, so A is also wrong, so definitely D must be correct. Now D also चलो verify कर लेते हैं. D also we can verify, like f of 5.5 minus of f of 4.5. Now 5.5 is basically somewhere over here. This is 5.5. 5.5 is 5.5 will fall in this domain. So we'll consider this branch that x plus c2. So 5.5 plus c2 minus of 4.5 plus c2. So in this case, c2 and c2 will cancel out, and 5.5 minus of 4.5 will give you 1. ठीक है, अच्छा, f of 1.5 minus of f of 0.5. Now this domain falls under this section, so we'll consider this branch कि 1.5 plus c1 minus of 0.5 plus c1. तो यहां पे फिर से c1 cancels out, तो 1.5 minus of 0.5 will be 1 again. So in any case, this c2 and c2 for any choice of c2 or any choice of c1 this will always get cancelled. Hamesha this will always get cancelled and answer will be 1. So both of these are equal. Option D must be correct. Okay, next we have this question which says that let R be a set of real numbers. We have to find the functions which is defined from R to R satisfying this condition mod of fx minus fy is equal to 2 times of mod x minus y. This is once again a similar question which you have done. I hope you people remember the previous question where we just did this same format where mod of fx minus fy was given, and right hand side was some inequality was given. This was 2 times of mod of x minus y whole to the power of 201 or something. This was the format, है ना? जो previous question में हमने किया है तो ये वही है. So now they have given this equality over here. So you do the same thing. You just bring one x minus 1 down and then simply take x tends to y and this will become mod of f dash of y. So mod of f dash of y will be 2. ठीक है. अब mod of f dash of y बोलो कि mod of f dash of x बोलो. Function will be what? Mod of f dash of x will be 2, which means f dash of x is plus minus 2. So fx will be 2x plus c1 or 2x minus of 2x plus c1 if you integrate both the sides. So these are the functions which we are having, where c1 and c2 are arbitrary constants. So for different choices of c1 and c2, we'll get different functions over here. So these are your functions. Okay, so ये bracket में लिख लेना c1 and c2 are arbitrary constants. This was a straightforward question. Okay, next we move on to 2014 PYQs. Here we have the first question which says that consider the function fx, which is a cubic polynomial given. A, B, C, D are all real numbers with a greater than 0. If f is strictly increasing, then the function gx, which is f dash of x minus f double dash of x plus f triple dash of x is what? So we need to comment on this thing, whether this is 0, positive, negative, or strictly increasing. So we need to comment on this function. So what they have given a cubic polynomial fx where whose leading coefficient is positive and f is strictly increasing. So we utilize this condition. F is strictly increasing, like I have said, f is strictly increasing means dy by dx is greater than 0. So f dash of x is greater than 0. So what is f dash of x? 3ax square plus 2bx plus c. This will be what? Greater than 0. Okay, for all x belongs to R. Now f dash of x is a quadratic quantity. So this is a quadratic which is always positive, whose leading coefficient is also positive. If a is positive, 3a is also positive. Okay. So which means when a quadratic is always positive with its leading coefficient always positive, which means clearly d must be less than 0. ठीक है, ये जानते तो होंगे कि if a is positive and d is negative, which means quadratic is always positive. And if a is negative and d is also negative, then quadratic is always negative. ठीक है, a basic thing which is taught in basic mathematics also and taught under quadratic equations as well. और functions में भी ये चीजें करते हो. So these things are quite common. So a is positive, d is negative, मतलब quadratic is always positive. तो यहाँ पे उल्टा जा रहे हैं ना. So fx is positive, quadratic is positive दे के रखा है, and leading coefficient a is also positive, which means d must be negative over here. So we see what we can see generate from here. So d माने discriminant माने 4b square minus of 12ac must be negative, which means b square minus 3ac must be negative. So this is one condition which we have derived. Okay. So now we see what we can derive from this gx function. So gx is what? F dash of x. Let us write down gx. So gx is what? F dash of x, which is 3ax square plus 2bx plus c minus of f double dash of x, which means differentiation of this thing once again, which is 6ax minus of 2b. You multiply with the minus. So minus of 2b, and this is constant, which is 0, plus f triple dash of x. So f triple dash of x means differentiation of this thing. So that's 6a only. So this is your function. Okay. This is your gx function. If you rewrite this thing in a much more decent manner, so this is a quadratic 3ax square plus 2 times of, now 2bx, and here also we are having x, 6ax. So we can just simply take a 2 common and write this as b minus 3ax. And then the rest of the constants, which is c minus 2b plus 6a. This is what we are having. Now this is once again a quadratic whose leading coefficient is positive. This is leading coefficient. This leading coefficient is also positive quantity, right? 3a is once again positive. Now, if we check for the discriminant d, d will be what? B square minus 4ac, which is 4 into b minus 3a whole square, b square minus 4 into a, which is 3a, into c. C is this entire constant, 2b plus 6a. If we analyze this thing, let us see what we can get from here if we break this thing. So 4 we can take out common. So this is b square plus 9a square minus of 6ab if we break this thing. और फिर यहाँ पे minus of 3ac है and minus minus plus. Since we have taken 4 common, plus 6ab or minus of 18a square. ठीक है, तो this plus 6ab and minus 6ab, this will cancel out. So we are left out with 4 times of यहाँ पे देखो b square minus 3ac we are getting. So we can come in, b square minus 3ac was given to us. So we can write this as b square minus 3ac, combine this term b square minus 3ac and plus 9a square minus 18a square. So this will become minus of 9a square. So b square minus 3ac is negative and 9a square is also negative, right? Minus 9a square. A square is positive, minus 9a square is what? Negative. So b square minus 3ac is negative. This is also negative. So entire quantity is negative quantity. So this is also less than 0. So coefficient is positive. D is less than 0, which means this is always positive. Okay, this is always positive. So gx is always positive. So option B must be correct. Okay, next we have this question, which is a UGB question. Let f and g be two non-decreasing twice differentiable functions defined on an interval AB such that for each x belongs to AB, f double dash of x is equal to gx and g double dash of x is equal to fx. So these two relations are given. Suppose that also fx into gx is linear on x, so product is linear. We must show that fx and gx is equal to 0 for all x belongs to AB. Okay, so what is given? This thing is given. F double dash of x is equal to gx, g double dash of x is equal to fx. F and g are all non-decreasing twice differentiable functions. Okay, and fx into gx is linear. This third information, fx into gx is linear. So suppose I consider one function hx, which is fx into gx, and this is a linear function, which must be definitely of the form ax plus b, where a and b belongs to all real numbers. है ना? So if you see over here कि f double dash of x is given to be gx and g double dash of x is given to be fx, which means we have to differentiate this thing twice. Minimum ये twice differentiate तो करना ही है. That's why they have given this thing. ठीक है. So let's differentiate this. So h dash of x. So by the product rule, we have f dash of x into gx plus g dash of x into fx. है ना? And right hand side we will be having a. एक और बार कर लेते differentiation. So h double dash of x will be f dash of x into g dash of x plus gx into f double dash of x plus g dash of x into f dash of x plus product rule से fx into g double dash of x. Okay, and the right hand side will be 0 now completely. ठीक. So now if we utilize these conditions, f double dash of x is what? Gx. So this is basically f dash into g dash plus g of x into f double dash of x. F double dash of x is gx. G of x. Now f double dash of x is what? Gx. So this will be g square x, right? So I'll write this as g square for simplicity, g square. Similarly, plus g dash of x, so g dash into f dash, okay, plus fx into g double dash of x. G double dash of x is once again fx, so that's simply f square. है ना? So if I simplify this thing, this is nothing but f dash into g dash plus g dash into f dash, which is f square plus g square plus 2 times of f dash of x into g dash of x is equal to 0. This is what they have given. ठीक है, this is what they have given कि f square plus g square plus 2 times of f dash into g dash is equal to 0. ठीक है, तो now what we can conclude from here? So we have generated this. अब यहां से क्या करें? अब देखो, बेसिकली दीज आर ऑल पॉजिटिव क्वांटिटीज. हाउ डू वी नो? भाई एफ स्क्वायर तो पॉजिटिव है ही, एफ स्क्वायर इज पॉजिटिव, दिस इज ऑल्सो पॉजिटिव क्वांटिटी, जी स्क्वायर ये भी पॉजिटिव है. एफ डैश ऑफ f dash into g dash माने f dash of x into g dash of x, this is also positive quantity. In what sense? f and g are non decreasing functions. मतलब क्या होगा? These are all increasing function. Increasing function है तो dy by dx, f dash of x is greater than 0, g dash of x is also greater than 0, है ना? In fact greater than or equal to 0. Non decreasing है, so this can be increasing or strictly increasing as well. So both are possible, मतलब increasing भी हो सकता है. So g dash of x must be minimum, this must be g dash of x will be greater than or equal to 0. Equality hold as well. मतलब सारे के सारे जो है, these are all positive quantities. So these are also all positive quantities. So definitely all three positive quantities are equal to 0. और जानते तो हो ही, a square plus b square plus c square is equal to 0, which means what? All sum of all positive quantities, squares of the all positive quantities is 0, है ना? सारे के सारे positive quantities है. If their sum is 0, this is only possible when individually all of them are equal to 0. तो if this is all positive, all these are positive, तो यही से ही बोल सकते हो कि हर एक जो टर्म्स है, all these terms will be what? Equal to 0. Individually these all will be equal to 0, which means fx is equal to gx from here is equal to 0. ये तो होना ही है. f dash into g dash will be also 0. लेकिन ये प्रूफ करने बोला कि prove that fx into gx is equal to 0. ठीक है, बस प्रूव हो गया. So fx is equal to gx is equal to 0. Okay, next we move on to 2012 PYQs. Here we have the first question, which says that a function f that R2R be defined by this. So we have to comment on the continuity and differentiability of the function. And also we have to find out whether f dash is continuous or not. Okay. It's a similar problem which we have done before. Okay, so first, clearly some things are visible from here, that f of 0 minus क्या होगा? 0 only. We'll consider this branch for 0 minus, which is 0 only. And f of 0 plus के लिए we'll consider the upper branch, ये वाला e raised to the power of minus 1 upon x. तो e raised to the power of minus 1 upon x, this will be e raised to the power of minus 1 upon 0 plus. तो 1 upon 0 plus will tend to infinity. सामने minus है तो this will tend to minus infinity. So e raised to the power of minus infinity will tend to 0. And f of 0 के लिए भी we'll consider this branch which is 0 only. So the function is continuous at 0. ठीक है, तो not continuous तो cancel out हो गया. Function is continuous. ठीक है, now for differentiability what we do? We check for f dash of 0 plus and f dash of 0 minus, piecewise function. So left hand derivative, which is f dash of 0 minus, will be limit h tends to 0, f of 0 minus h minus of f of 0 divided by minus of h. Okay. So in this case, limit h tends to 0. So f of 0 minus h will be what? This function only, which is 0. For 0 minus h माने वो this function which is 0. 0 minus of f0 which is 0 divided by minus h. अब तो ये तो 0 ही है, तो 0. f dash of 0 plus will be what? Which is limit h tends to 0, f of 0 plus h minus f of 0 divided by h. तो f of 0 plus h क्या होगा? This will be e raised to the power of minus 1 upon h minus of f of 0 which is 0 only divided by h. This is what we are having. Now as h tends to 0, this is of the 0 by 0 form. You can check. If you try to solve this using the L'Hopital's rule, then what happens is the powers will keep on getting increasing. If you differentiate this thing, which is minus 1 by h, e raised to the power of minus 1 by h का differentiation is e raised to the power of minus 1 by h into differentiation of minus 1 by h, which is 1 by h square, है ना? और फिर नीचे divided by h है, मतलब 1, तो नीचे 1 हो जाएगा. ये देखो नीचे डिफरेंशिएशन, वंस यू डिफरेंशिएट दिस थिंग, दिस 1/h² विल कम डाउन, तो फिर से वो h² का डिफरेंशिएशन करोगे, h² विल बिकम 2h, लेकिन फिर से दिस टर्म विल बी रिमेनिंग, सो वन एक्स्ट्रा टर्म्स विल कीप ऑन गेटिंग जनरेटेड, है ना। तो आप इसको ऐसे काम कर लो, ये ना करके वी मॉडिफाई दिस थिंग एंड सॉल्व। e raised to the power of minus 1/h था ना, so what we do is we change this into 1/h form। था क्या, e raised to the power of minus 1/h divided by h, ये था। so I am changing this into 1/h, I am dividing by 1/h, हर एक में 1/h format I am bringing, and I am writing this as e raised to the power of 1/h, so that as h tends to 0 this becomes infinite divided by infinite form। what happens then, so now if you use the L'Hopital's rule, so now this becomes minus 1 upon h square, और नीचे बनेगा e raised to the power of 1/h into differentiation of 1/h, which is minus 1 upon h square। सीधा कटेगा, this will cancel out। okay, so as limit h tends to 0, this 1 upon 0, this quantity will tend to infinity, and 1 by infinity will tend to 0, so this will tend to a finite limit, this will become finite। ठीक है, यहाँ पे लिमिट था, लिमिट h tends to 0, so this h tends to 0, as h tends to 0 this will become 0 only, तो मतलब f is differentiable। ठीक है, now whether f is continuous or not, f dash is continuous or not, so what we can do, we can find out f dash of x। f dash of x will be what, e raised to the power of 1 minus 1 upon x into differentiation of minus 1 upon x, which is plus 1 upon x square, है ना, माइनस माइनस प्लस हो जाएगा, plus 1 upon x square when x is more than 0 and 0 when x is less than 0। this is f dash of x, so f dash of 0 plus will be, we'll consider this branch when x is more than 0, so limit x tending to 0, e raised to the power of minus 1 by x divided by x square, that's what we are having। तो ये कौन सा फॉर्म है, अगेन 0/0 फॉर्म है, e raised to the power of minus 1 by x divided by x square वाला फॉर्म है ना। अच्छा, तो ये तो फिर से वही वाला लॉजिक हो गया। अगेन यू डिफरेंशिएट दिस थिंग बाय द L'Hopital's रूल, दिस विल, द पावर्स विल कीप ऑन गेटिंग इंक्रीजिंग, तो वो कर नहीं सकते, तो आप इसको चेंज कर लो बाय द सिमिलर लॉजिक, तो लिमिट x टेंडिंग टू 0 कर लो और इनफाइनाइट बाय इनफाइनाइट वाला फॉर्म में ले आओ, सो दिस इज डिवाइड बाय x ओवर हियर, डिवाइड बाय x स्क्वायर, ठीक है, 1/x स्क्वायर कर दो, 1/x square divided by e raised to the power of 1/x, as x tends to 0 this will tend to infinity, this will also tend to infinity, तो infinity by infinity form हो गया। now this will be easier to solve, है ना। तो L'Hopital's rule से as limit x tending to 0, this will 1/x square, इसको डिफरेंशिएट करो, this will become minus 2 upon h cube, minus 2 upon x cube divided by e raised to the power of 1/x का डिफरेंशिएशन is e raised to the power of 1/x into differentiation of 1/x, which is minus 1 upon x square। ठीक है, तो ये हो गया। So now further you simplify this thing, I'm doing it over here because we don't have much space, so limit x tending to 0, if you further simplify this thing, this is basically, so some of the terms are getting cancelled, क्या क्या cancellations हो रहा है यहाँ से, so x square and this x is, one of this x is getting cancelled, x square is getting cancelled, so 2/x is remaining, बचेगा क्या 2/x, बचेगा क्या 2/x divided by e raised to the power of 1/x, this term will be remaining। तो ये तो फिर से वही फॉर्म है, फिर से वही फॉर्म है, once again we are having the same form, तो फिर से you have to differentiate this thing by the same logic, so limit x tending to 0, फिर differentiation करो, so this will become minus 2 upon x square divided by e raised to the power of 1/x into differentiation of 1/x, which is minus 1 upon x square, again so this x square and x square cancels out, minus minus भी कटेगा, so what will be remaining is 2 times e raised to the power of minus 1/x, so as x tends to 0 this limit will tend to 0 as well, okay, because this will tend to what, as x tends to 0 this will tend to infinity, and सामने minus है तो this will tend to minus infinity, so this is basically tending to 0, so this will be 0 only। so yes, f dash will be also continuous because you can see ये तो हमने सिर्फ right hand derivative देखा है, right, so f dash of 0 plus is what, sorry, f dash of 0 minus will be what, 0 only, f dash of 0 minus is what, 0 only, तो वो तो 0 ही है, and f of 0 is what, वो भी 0 होगा, वो भी 0 है यहाँ से, so which means left hand derivative, right hand derivative, ठीक है, f dash में f dash of 0 plus, f dash of 0 minus and f of 0, this is, all these are continuous functions, all these are continuous means सारे के सारे 0 है, so मतलब continuous है, f dash is also continuous, so f is differentiable as well as continuous, option D is correct। Okay, here we have the next question which says that suppose n is greater than or equal to 2 is a fixed positive integer and fx is given to be this function. So we have to comment on the differentiability of f. So fx is, if we define fx properly, then fx is x to the power of n into positive x. Okay, which means this is x to the power of n plus 1 when x is greater than or equal to 0. And this is minus of x to the power of n plus 1 when x is less than 0. We are defining this mod. Okay. So f of 0 plus, is this function continuous? You can clearly see f of 0 plus and f of 0 minus will be 0 only. So as f of 0, this will be 0. Yeah? So definitely this is a continuous function. Now coming down to f dash of x. So f dash of x, if you differentiate this thing, this will be n plus 1 into x to the power of n plus 1 minus 1, which is n, when x is greater than 0. And n plus 1 minus of x to the power of n plus 1. One minus sign is there. Minus of n plus 1 into x to the power of n when x is less than 0. Now for differentiability, f dash of 0 minus, will be what? We'll consider this branch. So which is minus of n plus 1 and times of 0 raised to the power of n. Now this will be what? 0 only. This will be 0. And f dash of 0 plus will be n plus 1 into 0 raised to the power of n once again. So this will be what? 0 once again. So f dash of 0 plus and f dash of 0 minus, this is all of them are 0. Provided that, also one more thing which we need to take care is here n, 0 raised to the power of n is 0, like something tending to 0 raised to the power of n is 0. This is only possible if n is positive. Okay, and here it is a positive number because they have mentioned this thing n greater than or equal to 2 is a fixed positive integer. Otherwise this wouldn't have been 0. ठीक है, नहीं तो कुछ दूसरा कुछ होता, सपोज अगर नेगेटिव वगैरह होता तो if n would have been negative then this would have been something else. ठीक है, so in this case all of these are 0. So f dash of 0 minus and f dash of 0 plus, all of these are 0. So f is differentiable everywhere. Option C is correct. Okay, now we have this UGB question which says that if let alpha be a real number, consider the function gx is alpha plus mod x whole square into e raised to the power of 5 minus mod x whole square. We have to find the values of alpha for which g is continuous and g is differentiable. So if we can see over here that this function is always continuous, mod of x. Okay, so alpha plus mod x is also continuous. So as 5 minus mod x, because mod x is continuous, so 5 minus mod x will be also continuous, and e raised to the power of something will be also continuous. So this is a continuous function. ये continuous है, ये भी continuous है. Composition of a continuous function with a continuous function is always continuous. So continuous function into continuous function will be a continuous function, which means for any values of alpha, this will always be continuous function. ठीक है, तो first one is done. कि first one is, तो ये डिटेल में लिखना है आपको, लाइक ऑल दीज थिंग्स व्हाटएवर आई हैव सेड, मॉड एक्स इज कंटीन्यूअस, कॉम्पोजिशन ऑफ द कंटीन्यूअस फंक्शन इज कंटीन्यूअस, फिर कंटीन्यूअस इनटू कंटीन्यूअस वो भी कंटीन्यूअस है. ठीक है, तो जीएक्स इज कंटीन्यूअस, जीएक्स तो कंटीन्यूअस है, जीएक्स इज कंटीन्यूअस फॉर ऑल एक्स बिलोंग्स टू आर, और फॉर अल्फा बिलोंग्स टू आर, सॉरी, फॉर ऑल अल्फा बिलोंग्स टू आर. ठीक है, नाउ कमिंग डाउन टू द सेकंड वन, डिफरेंशिएबिलिटी. तो फॉर डिफरेंशिएबिलिटी वी कैन डिफाइन द फंक्शन जीएक्स. जीएक्स को डिफाइन करो ठीक से. gx is what? When x is positive, gx is alpha plus x whole square into e raised to the power of 5 minus x whole square. ठीक है, और यहाँ पे इक्वालिटी डाल दो, एंड व्हेन x is negative, this will be alpha minus x whole square into e raised to the power of, ये माइनस माइनस प्लस हो जाएगा, 5 plus x whole square. ठीक है, so next what we can do is we can branch wise differentiate this thing. So g dash of x, g dash of x will be what? G dash of x will be, if you differentiate this thing, this is alpha plus x का whole square into e raised to the power of 5 minus x का differentiation is e raised to the power of 5 minus x का whole square, और फिर into differentiation of this, so 2 into 5 minus x, और फिर into minus 1. ठीक है ना? तो और फिर प्लस e raised to the power of 5 minus x का whole square into differentiation of alpha plus x का whole square, which is 2 into alpha plus x when x is greater than or equal to 0. And similarly, we differentiate this thing. So alpha minus x का whole square into e raised to the power of 5 plus x का whole square into 2 into 5 plus x plus e raised to the power of 5 plus x का whole square into differentiation of this, which is 2 into alpha minus x into differentiation of alpha minus x, which is minus 1 when x is less than 0. So this is your g dash x. Now the thing is, rest of the places the function is continuous and differentiable. ठीक है, खाली 0 पे definition change हो रहा है. 0 पे there is a definition change. So it is sufficient for us to check the differentiability criteria at 0. So g dash of 0 plus, let's see what is g dash of 0 plus. So g dash of 0 plus के लिए we'll take this branch alpha square. अच्छा, this will be e raised to the power of 5 square, which is e raised to the power of 25 into 2 into 5, which is 10. ठीक है, plus e raised to the power of ये भी 25 and this is 2 into alpha plus 0, which is 2 alpha. तो e raised to the power of 25 अगर कॉमन लोगे, so this is 10 alpha square plus 2 alpha. अच्छा, सामने यहाँ पे एक माइनस भी था, माइनस was there as well, minus of 1, तो -10, ये माइनस था यहाँ पे, -10, this will be -10, right? So minus of 10 alpha square plus 2 alpha. And g dash of 0 minus, similarly g dash of 0 minus will be, यहाँ से we'll take this branch, this will be alpha square into e raised to the power of 25 into 2 into 5 plus 0, which is 10 plus e raised to the power of 25. This will become, minus डाल दो यहाँ पे, x minus alpha कर लेते, x minus alpha. So x minus, which means 0 minus alpha, तो मैंने minus 2 alpha है ना, तो 0 minus alpha, so this will become minus of 2 alpha, minus of 2 alpha. तो फाइनल में if you take out e raised to the power of 25 common, so this is 10 alpha square minus of 2 alpha. ठीक है, now g dash of 0 plus, अब देखो g dash of 0 plus and g dash of 0 minus will be equal because the function is differentiable, और वहां से we'll solve for alpha. So if you equate these two, this and this term will cancel out. So what is remaining is 10 alpha square plus 2 alpha minus ba is equal to 10 alpha square minus of 2 alpha. ठीक है, तो once you simplify this thing, what will I get from you? 20 alpha square plus 4 alpha will be equal to 0, which means alpha is equal to 0. एक तो alpha common आ रहा है, ठीक है, and what else, ये 4 और ये तो 5 से ही जाएगा, which means 5 alpha plus 1 will be 0, which means alpha will be 1 upon 5. So alpha is 0 and alpha is 1 upon 5 are the answers over here. ठीक है, these are the two possible values of alpha. Alpha 0 and alpha is 1 upon 5 for which the function is differentiable. So we have found the values of alpha. Okay, next we move on to 2011 PYQs. So here we have the first question, which says that consider a function fx which is x to the power of n. What is the function? Fx is x to the power of n into 1 minus x whole to the power of n divided by n factorial, where n is greater than or equal to 1. Now this is given to be a fixed integer. Let fk denotes the kth derivative of f. Then which of the following is true? Whether fk of 0 or fk of 1 integer or not, this is what we need to check over here. Okay, so which of these are integers? That is the main thing. So fk 0 and fk 1. So k can be any value, because they have said that this is fk is the kth derivative of this thing. So what you can do is you can find the general differentiation as well. ठीक है, so you keep on solving. लेकिन function जो है, function is a bit complicated here, not complicated kind of thing. Function ये क्योंकि n के terms में है, so better will be if we take a finite value and then we verify. Let us take a finite value of n 3 and then we verify this thing. You take the value of n to be 3, so the function becomes what? X cube into 1 minus x whole to the power of 3 divided by 3 factorial. Then question will become very simple. ठीक है. नाउ फर्स्ट टाइम यू विल डिफरेंशिएट दिस थिंग विच इज f1x, मतलब डिफरेंशिएशन फॉर द फर्स्ट टाइम. ठीक है. तो यू विल सिंपली डिफरेंशिएट दिस थिंग 1/3 फैक्टोरियल कांस्टेंट है, तो यू विल डिफरेंशिएट. ठीक है. तो डिफरेंशिएशन करके देखना एंड यू विल गेट एफ ऑफ जीरो एंड एफ डैश ऑफ जीरो एंड एफ डैश ऑफ वन. ठीक है. f1x मतलब एफ डैश ऑफ एक्स, सिंपल है. सो f1x, f10 एंड f11, दिस विल बी जीरो. बोथ ऑफ देम विल बी जीरो. ये डिफरेंशिएट करके चेक कर लो. When you differentiate this thing, this will be there. Okay, 1 3 will come out over here, 1 3 comes out over here, so x cube x square बचेगा. और clearly you can see over here this is 1 minus x and 1 minus x, मतलब f1 तो जीरो होगा ही. ठीक है. और f0 भी जीरो हो रहा है सिंस here we are having x square over here, है ना. x square और यहाँ पर भी x है, x cube है, so ये भी जीरो होगा. So definitely all of these are what? Integers. These quantities are integers. Similarly you will check for f2x, मतलब f double dash of x. Similarly if you check for f2x, you will obtain this quantity, this thing. Again फिर देखोगे f2 of 0 and f2 of 1 will be 0. फिर से वो 0 आ जाएगा, which is once again integer. So till date तो we are still getting integers. आप बोलोगे सर आपने यहाँ पे basically why we are taking this n is equal to 3. You could have simply solved this using n. You could have simply solved this using n. हाँ, n से भी solve कर लो, n से भी solve कर सकते हो. You can verify by taking n also, लेकिन थोड़ा difficult रहता है. So what we do is to simplify our process. We have just taken a specific value of n and then we are solving. And for this, and similarly you will verify, like I said, you will verify that f2 of 0 and f2 of 1 will be also 0, which is integer. तो integer ही देखना है बस. Again you will find out f triple dash of x. Triple dash of x will be what? Once you differentiate you will get this entire term. ठीक है. ये खुद से differentiation करना. Please do not see the solution. I mean I am explaining this thing, but please do the calculations on your own. ठीक है. Simple question है. Differentiation भी is very easy. Product rule ही खाली use करना है. You will see there are cancellations. This will get cancelled. ठीक है. 3 factorial and this 3 into 2 is 6 only, so this will completely get cancelled. Okay, so in final में we will be having this term. Final में we will be having this term. Again you will see that f here, because there are no fractions, so obviously f of 0 and f of 1 will be integers only. You don't even need to calculate this thing. यहाँ पे कुछ fraction वगैरह तो है नहीं. All these fractions are gone. So f triple dash of x will be also integer only. तो 1 और -1 हो रहा है, so both will be integers. ठीक है. I have calculated the value, लेकिन करना तो है ही नहीं. You people can directly see from here itself. ठीक है. This will be integer. Fraction तो है ही नहीं. So in general we can say कि f kx will be always integer. f3x के लिए f triple dash of x. Similarly once you differentiate this thing you will keep on getting integers only, क्योंकि देखो all fractions are gone now. Once you keep on differentiating this thing, afterwards 0 1 के लिए बोलो, all the rest of the things will be integers only. So for any kth derivative this is integer only, which means fk0 and fk1 are all integers. Option A is correct. तो whenever something is given in terms of m, ठीक है, अगर पॉसिबल हो सके तो यू कैन टेक सम स्पेसिफिक वैल्यू ऑफ n एंड सिंप्लीफाई, है ना. Okay, next we have this question which says that suppose f is continuously differentiable up to 3 order and this satisfy this integral equation given, which is going from 0 to 1, 6 fx plus x cube into f triple dash of x dx. Right hand side is f double dash of 1. So which of the following must be true? So these are some relations given in terms of f dash of 1 and f of 1. We need to verify this thing. So the best thing to solve this thing is basically separating this thing. Separate kar lo, which means multiply this, multiply 0 to 1 fx dx, and then simply use integration by parts. Integration 0 to 1 x cube into f triple dash of x. और तो कुछ दिख नहीं रहा है. तो best is basically if we use integration by parts over here, and that's what I have done. तो यही से देख लो, I've given the solution over here because this is just a calculative problem. You don't have any difficult level simplification here. खाली by parts ही यूज करते जाओ and we are done. तो देखो first time we are using by parts. ये हमने सेपरेट कर लिया, देन सेपरेटिंग दिस, सो वी आर ब्रेकिंग दिस बाय पार्ट्स. लास्ट में जाके टोटली वंस ऑल दीज फॉर्म्स आर गॉन, टोटली लास्ट में जाके वो कैंसिलेशंस विल गेट जनरेटेड. तो बाय पार्ट्स यूज कर लो. आफ्टर यूजिंग इंटीग्रेशन बाय पार्ट्स वी आर गेटिंग एक्स क्यूब इनटू एफ डबल डैश ऑफ एक्स. वैल्यूज डालो, देन दिस टर्म विल बी रिमेनिंग. इंटीग्रेशन बाय पार्ट्स तो आता ही है ना. लास्ट सेशन वी हैव डिस्कस्ड. सो देन फाइनली वी आर गेटिंग दिस थिंग. Okay, so afterwards, then what you do after plugging the limits, देखोगे this term and this term will get cancelled. F double dash of 1, यहाँ पे limits डालोगे क्या आएगा? 1 into F double dash of 1 minus of 0. तो F double dash of 1 is remaining. So this will get cancelled, है ना. This term and this term will get cancelled. So Then afterwards, then once again you will break this thing with integration by parts, x square into f double dash of x, and you will do this till the end. So once again, once we break this thing, 3 है, minus 3 यहाँ पे common ले लो, and then simply break this using integration by parts. तो 1 into f dash of 1, फिर से वही 0 आएगा. 1 into f dash of 1 फिर से 0. I have multiplied this 3 also. तो ये 6 हो जाएगा and this thing will be remaining. ठीक है. अच्छा, यहाँ पर एक और भी चीज है कि सपोज सर हियर तो यू आर सेइंग यू हैव टू यूज इंटीग्रेशन बाय पार्ट्स. हाउ डू वी अंडरस्टैंड विच वन टू कंसिडर द फर्स्ट फंक्शन एंड द सेकंड फंक्शन? तो भाई जिसका डेरिवेटिव इज नोन टू अस, दैट विल बी द सेकंड फंक्शन, है ना. फॉर्मूला में क्या होता है, विच एवर डेरिवेटिव इज नोन टू अस, एक्स क्यूब माइनस integration of f triple dash of x. So we'll take this as the second function because the second function is always integrated, right? So whichever differentiation is known to us, ये जानते हो ना, when IIT rule fails, whichever differentiation is known to us, उसको we'll take this as the second function. ठीक है, तो u उसको v लोगे and then you will solve. So next is basically, so you keep on doing this thing again. Last में जाके यही चीज होगा. Once you just plug in the limits over here, so this will become 3 into f dash of 1 and x into f dash of x बचेगा. Again you will differentiate, again you will integrate this thing. So you'll be getting x into fx minus of integration 0 to 1 fx dx. Just multiply these terms. Once again plug in the limits over here. This will become 1 into f of 1. फिर minus of 6 into, just multiply all these terms over here. So you will get some cancellations. Okay, this will become 6 into f1. This term and this integral will cancel out finally. और खाली ये चीज बचेगा. Only this term will be remaining. बस हो गया यहाँ से. So what is remaining? 3 into f dash of 1. देख लो, 6 into f of 1. And right hand side will be having 3 times of f dash of 1. तो बस यहाँ से simplify हो गया. So f dash of 1 will be what? F dash of 1 will be 2 times of f of 1. So option B must be correct. Okay, next we have this question which says that the function fx defined on this entire real line is continuous or differentiable. This is what we need to check. ठीक है. So the function is very simple. You simply define the function. ये तो करते ही हो. Function is very simple. You simply define the function. What is the function? Function is when x is greater than or equal to 0. This is x square into e raised to the power of minus x. And when x is less than 0, this is x square into e raised to the power of minus x, means x. ये function बनेगा. ठीक है. Now for continuity, what we'll do, we'll check for 0 plus. 0 plus पे check करोगे because the function is remaining places. This is there is no problem. The function is changing its definition at 0, so we'll check at 0. So f of 0 plus and f of 0 minus we'll check. So f of 0 plus is how much? 0 plus will be this branch we'll take. So 0 plus में this is what? 0 into 0 square, which is 0, into e raised to the power of minus of 0, which is 0 only. तो ये क्या हो जाएगा? 0. And similarly, when x is less than 0, we'll consider this branch. So x square e raised to the power of x. So this will become 0 into e raised to the power of 0. Again, this is 0. And f of 0 also we'll consider this branch. Take it, this branch. So 0 into e raised to the power of 0, which is 0 only. So function is definitely continuous. So not continuous तो गया, उड़ गया. F of 0 will definitely be there. F of 0 will be definitely there. Now for the differentiability. So for differentiability, what we do is we can differentiate this branch wise. So this becomes x square minus of e raised to the power of x. And a differentiation of e raised to the power of minus x is e raised to the power of minus x into differentiation of minus x, which is minus 1. So minus of e raised x square into e raised to the power of minus x plus e raised to the power of minus x into differentiation of x square, which is 2x. So here x is greater than or equal to 0. And then next we are having x square into e raised to the power of x, differentiating this thing. So we are having x square into e raised to the power of x plus e raised to the power of x into 2x. And now when x is less than 0. Chalega. So now we check for f dash of 0 plus, because function is changing its definition at 0. So we'll check at 0 plus. ठीक है, तो 0 plus पे क्या हो रहा है? 0 plus पे 0, e raised to the power of 0 is 1 only, and this part is 0, and similarly this part will be also 0. ठीक है, तो complete thing will be 0 only. 0 plus 0 is what? 0 only. And similarly f dash of 0 minus, this part will be what? 0. This part will be also 0, because we'll consider this branch. This part will be 0, this part will be as 0 as well. So this will be completely 0. So left hand derivative and the right hand derivative are equal, which means the function is differentiable everywhere. So option ये सी और डी तो सेम हो गया है, सी को ही कर लो. मोस्ट लाइकली दिस इज अ प्रिंटिंग मिस्टेक, सो सी मस्ट बी करेक्ट. Okay, and we have the last question here, which says that let fx be a function, and we have to comment on the differentiability and the continuity of this function. Now, this is a very well-known function given, ठीक है, which you can definitely find it using the basic definition. Likewise, limit extending to, ये continuous तो है ही, limit extending to 0 manually find कर लो, x square into sin 1 upon x. ठीक है, x square into sin 1 upon x. ये अगर करोगे तो क्या आ रहा है? This will be 0 only, because 0 into any oscillating function will be what? 0. Once you find the limits, and f of 0 is what? 0. f of 0 is also 0. तो मतलब continuous तो है. ठीक है, तो discontinuous वाला thing is gone. Discontinuous वाला thing is gone. Now, whether the function is differentiable or not, you can simply use the definition, basic definition जो होता है, f of h tends to 0. ठीक है ना, उसी से सॉल्व कर लो. f dash of 0 निकाल लो उसी से. f dash of 0 will be what? Limit h tends to 0, f of h minus f0 divided by h minus 0. उससे सॉल्व कर लो, limit h tends to 0. f of h is what? f of h will be h square into sine 1 upon h minus of f0, which is 0, divided by h. ठीक है, तो this h and this h will cancel out. तो what is remaining? h into sine 1 by h, which is still 0. ठीक है, मतलब फंक्शन तो डिफरेंशिएबल है. ठीक है, फंक्शन डिफरेंशिएबल है. तो सी भी रॉन्ग हो गया, देखो, या तो बी होगा नहीं तो डी होगा. सी इज ऑल्सो रॉन्ग बिकॉज फंक्शन इज डिफरेंशिएबल एट 0. ठीक है, नाउ बोल रहा है कि we have to see whether f dash is continuous or not. So f dash के लिए क्या करोगे? Whether f dash is continuous or not. So we'll find what is f dash of x. Branch wise differentiate करके you will find what is f dash of x. चलो differentiation पहले कर लेते हैं. So this is x square into cos 1 by x into differentiation of 1 by x, which is minus 1 upon x square, है ना, और फिर plus 2x into sin 1 upon x. ठीक है, हमने differentiate किया है बस branch wise. x is not equal to 0 and this is 0 when x is equal to 0. ठीक है, तो here you can see this x square and this x square will cancel out. Sin 1 by x into x, once you distribute the limits over here, देख लो, once you plug in the limits like limit extending to f dash of 0 plus करोगे ना, ठीक है, तो वो क्या आएगा? You will plug in the limits over here. तो you can directly see over here कि this is a bounded function. This will be 0 into some oscillating value minus 1 to 1. This will be 0. ये value तो 0 होगा, but this will create the problem because here we are having perfect cancellations. So cos 1 by x is just an oscillating function. This will be remaining to be an oscillating function. So any oscillating function plus 0. So we don't know what is the value. So the value will not exist. So f dash of 0 will be discontinuous only. ठीक है, this limit does not exist. This limit does not exist. So f dash of x will be discontinuous only at 0. ठीक है, तो f dash of x is discontinuous and f is differentiable. So option D must be correct. Now to do these kind of questions, you need not do so many calculations here. You can directly see, I have given one shortcut over here that when fx is x to the power of p into sine 1 by x, then you can use this shortcut. Okay, when p is less than or equal to 0, fx is neither continuous nor differentiable. When p lies in between 0 and 1, fx is continuous but not differentiable. And when p is greater than or equal to 1, fx is both continuous as well as differentiable. You have seen over here. अरे if p is 1, क्या हो जाएगा? x into sin 1 by x. x into sin 1 by x, है ना? तब क्या हो जाएगा? This will become, once you just take the limits over here, तो क्या हो जाएगा? 0 into some oscillating function, तो limit will definitely exist, मतलब 0 हो जाएगा. So this is a very well-known, kind of short trick which is given, and because this is a very famous function, ये तो बहुत बार repeat हो चुका है, JEE में repeat हो चुका है. This has been given in JEE, this has been given in ISI, CMI, हर एक जगह पे ये function x into 1 by sine of 1 by x or cos 1 by x has been given. And in fact, this short trick, one small short trick, this particular short trick is valid for all those functions where we are getting x to the power of p into some function whose limit does not exist. क्या? Limit does not exist. x to the power of p कुछ रहेगा into some function whose limit does not exist. क्योंकि suppose कल को अगर मान लो you are doing this thing, you are doing this question, सपोज कल को अगर क्वेश्चन थोड़ा घुमा के पूछ दे, सपोज एक्स स्क्वायर इंटू साइन ऑफ एल एन एक्स, साइन ऑफ एल एन एक्स, अगर साइन ऑफ लॉग एक्स डाल दे तो देन ऑल्सो यू विल सी ओवर हियर साइन ऑफ लॉग एक्स, यहां पे x to the power of p multiplied by some function whose limit does not exist. Limit does not exist. So can you see over here sine of log x? यहां पे as x tends to 0, sine of log x will tend to infinity. ठीक है ना? As x tends to 0 plus बोलो कि this log x will tend to infinity. तो यहां पे limit will not exist. तो x to the power of p multiplied by some function whose limit does not exist. तो कल को cos भी डाल दे, suppose x square into cos 1 by x. Then also this thing will hold. ठीक है? Any function x to the power of p into limit does not exist, this short trick will hold.